Hey guys, I welcome you all to the live session on Tableau full course by Intellipaat. This session is conducted by multiple experts who will be teaching you all about Tableau from basics to advanced level. But before we begin the session, make sure to hit the subscribe button and also hit on the bell icon so that you will never miss an update from us. On saying that, let's see the agenda of the day. Firstly, we will begin with Introduction to Business Intelligence. Then after that, we will introduce you to Tableau. What is Tableau? Why is it important? And how does Tableau work? Then later on, we will explain you the concepts of Tableau like workspace and field types. Then after that, we will be explaining you about the sorting and filtering in Tableau. Once we finish with all the basic concepts, we will be moving on to a little more advanced topics like charts and advanced analytics. Then later on, we will be doing hands-on demo on how to create dashboards using Tableau and also how to create waterfall charts using Tableau. Post that, we will tell you how to become a Tableau developer. What are the roles and responsibilities a Tableau developer must be having. Then later on, we will see the difference between Tableau and PowerBI. Then lastly, we will be covering Tableau interview questions and answers. So, this is the agenda of the video. This is a must-watch session for everyone who wish to learn Tableau and make a career in it. So, stay tuned and watch the video till the end. Now, let's begin the session.
Let's start with what is business intelligence. Now, when the name itself comes into your mind, business intelligence, what do you think of it? It's basically very self-explanatory. It's intelligence in business. Now, when you're working in today's industry, you see that there is a lot of data everywhere. From buying groceries to big oil drills, everything produces data. And companies make full use of this fact by applying basically a lot of concepts to analyze this data that they've collected. They convert this raw data into meaningful information that can then help them to increase their business profits. All right. So business intelligence is basically going to help a company to discover the data that they are trafficking. Like if a company has an application and the data flows through it, that is being trafficked through it, then they can record this data and then figure out meaningful patterns and trends that they can then use to increase the efficiency of whether they develop an application or how they can sell more products, etc. And this is why data can be very important when working in the business intelligence field. And that's where business intelligence comes. There are multiple business intelligence tools out there that help you to analyze this data. There are multiple concepts also in BI. There are basically like processing the data, collecting the data, storing the data and analyzing it and then visualizing it so that you can find out meaningful information and then use that information to optimize your performance. Now, BI, business intelligence, basically helps us to figure out decisions that we need. It helps us to figure out these decisions that we need to increase our profits and make a better business model altogether. Now, let's discuss the business tools. When it comes to picking which business tool you want to use, like there are like many business tools out there, and based on your needs, you'll need to choose a specific one. So we provided here a criteria, and based on this criteria, you can decide for yourself which one you need to use. Basically, think of what you need and check out the criteria here. So first criteria is availability and usage. Now you need to check which version of the tool is available, like how easily is it available, is it very useful to you or not. That's where usage comes in. You need to figure out whether this particular tool is useful to you or not. So check out its features, its functions, and if you think you can use those features and functions, then go ahead and choose the tool. Then coming to the second criteria, it should be easy to learn and easy to use. Now, if you want more developers to get an easy start with the new business intelligence tools, then you need to make sure that the tool is very easy to learn. If it's very difficult to learn, then it will take a lot of time to train your employees or train yourself if you're using it by yourself. And it needs to be easy to use so that you don't mess up anywhere. Like if it's a more simple user interface, then you'll remember everything about the user interface. Now that comes down to the quality of the product overall. And that's where we come to the third criteria, that is the quality of data visualization. Now the quality of data visualization varies from one tool to another. So you need to make sure that the tool you want to use has the best visualizations out there. Like if I can give you an example, Tableau has like really good looking visualizations, and you can customize them to death. You can use whichever customization you want, customize according to your need, change this degree here, this degree there, and etc. etc. And then finally, coming to cost and ease of setup. You need to know what is the cost of it. If it's not a free software, then you need to know whether it's how expensive it is. But even if it's costly, can you afford it? Will you get a good ROI? Will you get a good return of investment? If you're paying only $100, do you get a good investment of $1,000? Or do you only get an investment of, do you get only a reward of $100 again? So if you are working with this tool and you're paying a monthly subscription of $100 a month and you only get $100 of profit out of that, then it's not very useful because it cancels each other out. So you need to make sure that the tool you're using is very cost effective for you. Okay, now let's move on to the next thing. Why do we need to learn business intelligence? Now there are a few factors, and we'll discuss why we need to learn, why we need to get into business intelligence and learn all the concepts and tools within it. So let's start off with what business intelligence helps us in. Now, key performance indicator. So if you use any business intelligence tool, it will basically give you a very good feedback of how well you're working or how well your company is performing. Because you always need to have some kind of feedback to realize whether you're making any mistakes or not. You don't want to be stuck in your own bubble and think that you're working really great, even though you're not. You always need a feedback. There should be a feedback loop. And this is where business intelligence tools can come in handy. They let you know whether you performed really great this quarter or not. If you didn't, then where did you falter? Where was the issue? Then you find that issue out, then you fix that issue. And this way, it can basically be a very important key performance indicator. It gives you, it indicates the performance of your service or product or your company, etc. Then process benchmarking. You can set goals and then achieve those goals. Now, using business intelligence tools, you can decide, you can read through the data you're getting already and then decide your future goals. And you're benchmarking these goals and then you're achieving these goals later onwards. And these are one of the few of the two factors that help you realize why you need business intelligence or business intelligence tools. It also helps you to drive your sales higher. When you discover your data, basically when you query it, when you go through your data, when you understand your data, you can go ahead and increase your efficiency because you understand your data. Then you can figure out its issues and then fix those issues and hence drive your sales higher. Now let's take an example. Like if you were working for an food delivery app and you collected all the data and you want to increase your profits. So you will see like what data you have collected. Suppose you have collected data on how fast the delivery people go and deliver it, and you see in which location they can deliver it faster. And you go and figure out why are they delivering faster in this location only. And when you find that factor out, you can use it in other locations also. And that way you can increase your sales. And then comes business problems. It can basically help you to figure out if or where that loss is happening. If you have a loss, then it will help you figure out why that loss is happening. You will first read through your data. You will have an understanding of your data. Then you will realize, okay, this is the problem I have, and then you will fix that problem. So this way, it is a very good thing if you're using any business intelligence tools to help you out in your business. Or if you're just a developer, then you need to understand these details to know why you're creating business intelligence things. Or if you're a fresher, then you need to know a little bit about a market. And if you're getting into business intelligence tools, then this is also important. You need to know why you're going to get into it. Why do people demand? Why is there such a high demand for these many people working with business intelligence? Okay, so business intelligence for a developer. So if we talk about why we need business intelligence, why a person would need to know about business intelligence, suppose you're a fresher or suppose you are in a very tight fit, if you're at a dead end job and if you want to get out of that dead end job, you think you don't have any career forward, or if you're a fresher and you don't have any skills with you at that moment, and you want to do something new that earns a lot of money, then business intelligence for a developer is very good. There's a very high demand out there. Many big enterprises are hiring a lot of different business intelligence people for different roles. It's in very high demand, and there's a lot of jobs out there for this particular purpose. Now, obviously, there are so many companies out there, and they want to improve upon their already existing framework. So when they're doing that, they will use some kind of business intelligence tools for that fact, and they will hire people who have knowledge on the particular platform. So suppose if you're working with Oracle Business Intelligence Enterprise Edition, then the company will hire a person who has knowledge on it. And if that person has knowledge, they will pay them a high salary for that purpose, because he is important to the company. And that's why if you're getting into business intelligence, it's a very good idea. If you're getting into the whole field of business, and if you come from a CS background, then this can be very important, very useful for you. Even if you don't come from a CS background, this can be very helpful for you. You just have to understand a few concepts here and there, and then you can get into business intelligence field. Now let's have an introduction to Tableau. Now, we talked so much about business intelligence. I was just talking about business intelligence, why we need it, what do we need it. So this should give you an idea of what Tableau does. It's not exactly what every other business intelligence tool does, but it does a major part of it. That is visualization. Visualization can be very important to have when you are working with large data sets. Now, let's think about it. You have large sets of data. If you have a very big enterprise company, like let's take Amazon, they have outlets, or I would say they have branches everywhere in the world, and they deliver product almost everywhere. So they must have incredible amounts of data. We're talking about such large amounts of data that you cannot even think about it. Like, it's just hard to think about it. So how do you handle such large data, and how do you find meaningful insights in this sort of data? So to find meaningful insights or find new patterns and trends, you need to divide the data, and then finally you need to process it, analyze it, and finally you need to visualize it. Once you visualize your data, you get a clear understanding of what that data represents. And visualization psychologically feels good to humans. Now, if you look at raw data, like if you see an Excel sheet with all the fields like geolocation, which sale was made, what date and all, you look at it and you'll get bored. You'll just look at it and your mind will wander off. You'll start thinking about something you saw today in the morning, or Game of Thrones. You'll start thinking of those kind of things. But when you look at visualizations are very appealing to human beings. We are built to look at colorful things. So it's an evolutionary thing. It's a whole another thing I don't want to get into, but take this as an understanding that humans really like to look at colorful visualizations. And if you mix this with important business data, then you get something very useful. You create really appealing visualizations of the data you've collected, and you can very easily figure out any particular patterns just by looking at it. You don't have to go ahead and use artificial intelligence to figure out these patterns. You can just look at it and you'll be like, okay, yeah, I understand that if there's a pie chart, and in that pie chart, there is that pie chart basically describes the shares in the market from my particular product. If my product is mobiles, it will show that that pie chart will show how much share of the market I have. And then I will realize, it'll take me only a second, but if I looked at a long sheet of data, then I won't realize it. So this is how visualizations can be very useful when we're working with business intelligence or anything. Visualizations are really something amazing. And that's where Tableau comes in. Tableau helps us to create these amazing visuals, and it basically is it's very intuitive. It takes your data. It can take data from various sources, from various different formats. It can take them, and then it can use that data and visualize it. So it's very good at that fact. It's a very powerful business intelligence tool, in the matter of fact that it helps us to get very good insights into our product, our service, our data, whatever we will provide. So people in business sometimes won't even have enough time to look at all these sheets of data. So that's another reason why you can have visualizations and be happy. So that way, if you wanted to show what you've done over your quarterly, if you suppose you worked for a quarter in a month and you want to show your progress, or you want to show progress of how the day of your application, then rather than showing someone just a few lines of written statements, you can show them graphs. People can look at graphs from far away and realize, okay, yeah, he's done really good, and I can see that my company is working really well. If I see you guys must have seen that graphic used a lot, where the line graph goes top, it goes from bottom to top and then again top, which shows a success, which shows success of your particular company or whatever you're working with. So that's how Tableau can be very useful. It can help us to create visualizations that we can use to figure out meaningful insights and observations that we can again use to increase the profits we have, or basically increase the efficiency of our product or service, etc., etc. Now, when you're working with Tableau, Tableau has two sets of tools. Like, you have your developer tools. When you want data analytics out of Tableau, you have two sets of tools in there. You have your development tools and your share tools. So development tools will basically help you to create dashboards, charts, reports, visualizations, and share tools will help you to share all of the dashboards, charts, and visualizations that you have created. Now, sharing is as important as developing. Maybe not that important, but it is important, because if you just create new items but you don't share it with anyone, then what's the point of it, right? So you have developer tools as well as share tools. Now let's talk about how Tableau works. So in this simple graph, you can see that data in Excel format or CSV format or simple access or text format, whatever it is, that data source is connected to Tableau. Basically, that Tableau points to that data and figures out this data exists, and then it takes that data and creates visualizations or dashboards based on queries that we keep in. So if there is a data set and I only want specific part of those data, like let's take the example of food delivery app again. I have collected data on all the how long it takes for delivery people to go and deliver the product. So in that data collection, I want to figure out only data for those people who go to a particular location. If they go to Delhi, then I want information about people going to Delhi. Is this an example about delivery people going to Delhi? So that will be a query. I'll query it and then I will visualize it. And then I will only display the data of what I want. And then you visualize it. And finally, you can go ahead and publish that data. It doesn't end on visualizations. You have to go ahead and publish this data so that you can share it with other people, so that they also can see what's happening. If you work in teams, or if you have a very huge company and you want to impress someone, or if you have a deadline where people have where your boss has asked you to show you what is the end result, give you a feedback of that particular application you created, then you can easily just send that link to him and he'll be able to see the dashboard that you've created or the visualization you've created. And that's where, then this is how Tableau works. This is a very, very basic understanding of how Tableau works. If you go into detail, you'll find a lot of more concepts out there that you need to know when you're working with Tableau. But it's still easy. It is one of the easiest visualization tools to use. You just need to start it up and there you have it. You can use it even without going through a guide. You can get a basic understanding without even having a guide of your own. Let's talk about an example. So I talked about that food delivery app before. Now let's talk about Netflix. How Netflix could you go ahead and use a visualization tool, or Tableau in our case. So let's talk about the data that Netflix collects. So data that Netflix would collect is events data and operations data. Now events data basically talks about all the things that Netflix is doing. If it releases a new show, if it releases The Witcher, or if it releases a new show Dracula, then that counts as an event. And when it's going to release, where it's going to release, all those kinds of data will come in events. And then you have operational data of how that data will be released and how fast it can release, those kind of things of data. So for events data, you'll use one of the components like Kafka, but operations data, you'll use Cassandra. And once Netflix has collected all of this data, it will store it in Amazon S3 bucket, where S3 is used for storing very, very, very large data sets. Now we know Netflix is there everywhere in the world, like almost everywhere, or mostly most of the big countries. But most of the big countries have such a large population that they're bound to produce the data, right? more and more data. So that those large sets of data can be stored using Amazon S3, and then they can be sent to fast storage where you want to select only subset of that large data. Now suppose, let's say that Netflix has collected events and operations data from all around the world, and in all around the world there are major countries like America, Canada, China, Russia, and India, and a lot more countries like UK, Europe, the whole Europe. And all of that data from all of these countries will be stored in S3. But what if they only wanted to see data from particular India? Then they would use one of Amazon Redshift or Teradata Druid to check out the only a subset of that large data, only that particular data, the data that they want to check out. Then you have data processes that basically help you to process all of this data. Now, each of these particular tools that have been mentioned, Hadoop, Spark, Presto, and Beehive, and Pig, these tools basically help you to they basically help Netflix to process such large amounts of data. They're optimized, they're highly optimized to process all of this data. And then data services, which basically help you to transmit the data from here and there. Then you have data exploration. Now you already know about this if you have some idea of the whole data science field, where you're using R, we're using Jupyter Notebook, Python, Portal for exploring the data. You are basically analyzing the data, creating graphs, and you're running algorithms to figure out about the whole nature of that data. And once you've done that, once Netflix has done that, then it will basically go ahead and visualize that sort of data. It will visualize using Tableau. Tableau is a very good visualization tool, and a lot of companies use it. Especially, you can see that here in this example, Netflix uses it, and they create these visualizations that will help them to figure out. Since we took the example of India, let me talk about it again. So once they've collected India's data, once they've processed it, once they've analyzed that data in data exploration, now they want to they want to create visualization of it so that they can show it to the top dogs of the company, or those people who have a lot of power in the company and they have the deciding power. So to show them, you can't just show like a lot of algorithms and math equations and all. You need to show them visualizations, because they have very less time, and to get their attention you'll need to create something bold, something interesting to look at, and that's where you come in data visualization. And it's not necessarily that you always have to impress someone or you have to get someone's attention. It's nice to have data visualization so you yourself can make meaningful insights and observations and make the changes you want to make after you've understood the data. And this is how Netflix would use Tableau.
Basically, these Tableau products are divided into two types. The first is the developer tools, and the second one is the sharing tools. So now developer tools is nothing but they are used to create the dashboards, the worksheets, basically your visualizations. So with the help of this developer tools, you create your visualizations, and with the help of the sharing tools, the visualizations that you've created using your developer tools are shared to audiences, right? I hope I'm being clear. Developer tools and sharing tools. So we have Tableau Desktop as the main developing tool, okay, and we have Tableau Public as well, right? So Tableau Desktop, we have two editions. We have personal and professional edition, okay. All your development work are done right here in your Tableau Desktop. You create your reports, you create your charts, and all the analysis process is done in your Tableau Desktop, right? And when it comes to Tableau Public, it serves, I mean, it is used for both the development and sharing purpose, right? You can develop your charts, your reports using Tableau Public as well. Okay, it is a free product offered by the Tableau company, but there's a limitation when it comes to Tableau Public. You can connect it only to a limited file types in which your data source must be, right? And there's no security when it comes to Tableau Public. Everyone can see your data when you publish your dashboard in Tableau Public, okay? So this is about Tableau Public, right? And then we have the sharing tools. Okay, sharing tools, they use the developer tools in order to develop your visualizations, and then they share your visualizations to the audiences. Okay, we have Tableau Online and Tableau Server. Okay, I think Tableau Online is not mentioned over here, but we have Tableau Online and Tableau Server. We have two sharing tools. Okay,
Just a quick info, guys. Test your knowledge of Tableau by answering this question. What are the components of a dashboard? A. Horizontal. B. Vertical. C. Image extract. D. All of the above. Comment your answer in the comment section below. Subscribe to Intellipaat to know the right answer. Now, let's continue with the session.
but one limitation, with the help of both Tableau Online and Tableau Server, you can publish your data. But the limitation of Tableau Online is that, editing of workbooks or any editing uh, works are limited to the number of rows, and your server data connections is required when it comes to Tableau Online, right? So Tableau Online is also a sharing tool, but there's one limitation, which is nothing but editing of worksheets inside your Tableau Online is limited to the number of rows. Okay, and you need to have a server data connection in Tableau Online. But on the other hand, when it comes to Tableau Server, it is also a sharing tool. Okay, it is used to share and create visualizations for organizations especially, right? So now, why do organizations use Tableau Server? They can also use Tableau Public when it comes to publishing data. But when it comes to organizations, they need security. Yes, and Tableau Server is the sharing tool which is used by all the organizations because it comes with full security. Like the data of an organization is need to be secure, right? So for that purpose, Tableau Server is used as a sharing tool. So you can share your visualization, you can share your dashboard throughout your particular organization, right? You can decide to whom this particular visualization is to be shared, whether you need to share only the visualization or you need to share the visualization with the data to which particular member of the organization and so on. So you can decide on that point when it comes to Tableau Server, right? So Tableau Server is fully secure, okay, when it comes to your data. Okay, so you need to use your Tableau desktop first to create your visualization, and after that you will have to connect to your Tableau server. Your Tableau server will have a user ID and password which is provided by the organization for security reasons, and then after which you can publish your data into Tableau server, and you can decide who must view the data. Let's say your higher officials, your colleagues, you should decide who should view the data who should view the visualization and the dashboards that you've created, and who shouldn't, or who should view it along with the data, and so on. Okay, everything can be decided in your Tableau server for the security reasons. Okay, so that's why organizations prefer Tableau server when it comes to publishing the analysis, right? And we have something called Tableau Reader. So during the early days, so Tableau Reader was the only way for content creators to share the dashboard, right? We didn't have Tableau Online or Server or to share the visualizations that was created. Okay, so they used to build visualizations using the Tableau desktop. Okay, and they used to share those visualizations using the Tableau Reader. Okay, and you can share the visualizations using the Tableau Reader throughout the organization without access to the desktop. So when people in your organization do not have access to the desktop, so when I say they do not have access to the desktop, it means they aren't supposed to have the access to the data itself, right? So in such cases, uh, such audiences will be provided with the visualizations using this Tableau Reader, right? So early days, this was the only sharing tool which was available, right? And we have something called Tableau Prep as well. So Tableau Prep is one of the latest products launched by the Tableau company. Okay, it's the Tableau's, you can say it's the ETL tool. It's the extract, transform, and load tool of Tableau. Okay, so Tableau prep, it just prepares your data. Okay, it's a personal data preparation tool. I can call it a personal data preparation tool. Okay, it just allows the users, you can aggregate, you can cleanse, you can merge different rows if you need, I mean different columns, or otherwise you can, prepare the data for analysis in Tableau, right? You need, you will have some basic things that can be that need to be done to your data, and you need those options to be used during every analysis. Let's say you will need to split a particular column into two, or you will need to merge two columns into one, and you need this merge to be there in all your analysis, in all your, I mean every time you open your Tableau, you connect your Tableau with your data source, you need this merged column to be there always. You needn't go every time and keep merging or keep splitting. So this is just an example. Okay, so this Tableau prep, okay, it prepares the data by which every time you will be given the prepared data for analysis. You needn't start from the scratch, right? I hope you understood about Tableau prep as well. Okay, so these are the different products offered by the Tableau company. Okay, so now this is our start page of Tableau. We are going to connect our Tableau with the sample superstore data which was provided by the Tableau company itself during the downloading process, right? So it is a Microsoft Excel file. So I'll just click on this, after which I'll be able to view all the Excel files available. Okay, I'll click on the sample superstore and I'll say open. So as you can see, my sample superstore, the name of my data source, it's visible over here. Okay, this is my data source page right here. Okay, the connection, it gives me the information about to which data source I am connected to, the name of my data source, the type, the file type to which my data source belongs to. Okay, and you have the different sheets available. We have 3 sheets. So as you can see in my Excel file over here, we have 3 sheets: orders, people, and returns. Okay, we have 3 sheets available. And similarly, you can see 3 different sheets over here. And these are nothing but the named ranges of these 3 sheets. So in Excel, whenever you create a sheet, a named range is automatically created. Okay, so it is, just the same. It is just a copy of your actual sheet. Okay, and you there's just one small change between your sheet and your named range, right? Your table or your sheet, it's a defined grid of cells of data, right? And your named range, it is just one or more cells to which you have assigned a particular name, right? So I'll just give you a very simple example, okay? Just one point by which you'll understand what is the actual sheet and what is the named range all about, right? So for example, if I have a column in my uh, any one of my actual sheet, and that is nothing but the sum of 2 different columns, let's say column A1 and B1, or let's say any 2 columns, right? So the column header will be A1 plus B1, right? So when I go into my named range, right, the header will be changed, will be given a name. It will be assigned a name as, let's say, uh, income plus expenses, or whatever your A1 and A2 is supposed to be, right? So that is a very small difference between your actual sheet and your named range. But other than this, you will not be, I don't think there's any difference when it comes to sheets and named range. You can use both these uh, to perform the analysis in Tableau, right? It will work just the same, right? So now we'll be using the different sheets over here. Okay, and before that, let me tell you about this data interpreter, which is available over here. Now, what is this data interpreter? So data interpreter, it just cleans your data. It helps to clean your data. This we have connected our data source. Okay, and you have something called data interpreter over here. So data interpreter, it helps to clean your data, right?
Just a quick info, guys. Intellipaat provides Tableau online training and certification course mentored by industry experts. The course link of which is given in the description below. Now, let's continue with the session.
Yes, and now this is known as the canvas over here. You will drag your sheets over here. So let me drag my first sheet. Okay, so now I have my order sheet over here, and all the different columns and rows which are present in my order sheet will be visible right here. Okay, and I all I have to do is just drag a particular sheet and drop it in my canvas area. Okay, and then I'll have to jump to my sheet. It says go to worksheet over here, where I will be building my visualizations, right? But before that, let us just discuss about the different sorting options which are available over here. Okay, and after which I'll be explaining about this over here. We have two different ways by which you can connect your data source with Tableau. The first one is the live connection and the second one is an extract connection. Okay, right now by default it is always a live connection. Okay, so now we have been connected with our data source sample superstore in a live manner, right? So I'll just tell you all the basic formatting options over here, sorting and formatting options, after which I'll explain about these two, the differences between these two ways of connections. Okay, so as you can see, you have this sorting order. So right now it is in the data source order. Okay, you can either change it to A to Z ascending, right? When I click on A to Z ascending, all my column headers or column names, they will be sorted out in an A to Z ascending order, right? So I have only one sheet over here and the columns of this particular sheet are sorted in this A to Z order. Okay, you have Z to A descending and you have something called A to Z ascending per table and Z to A descending per table. So now why does this per table come over here? Okay, so at one point of time I can have a maximum of 32 tables in my canvas. Okay, so we have this joining process which can be performed. Let me have my second sheet. Okay, so as you can see, there's an inner join which has been created between the two sheets. Okay, we have four different types of joins which we can change it manually. Okay, we'll be discussing about this data joining and data blending soon in our upcoming sessions. Okay, so right now we have two tables or two sheets in our canvas. Okay, and by default an inner join is applied, right? So now when I choose A to Z ascending per table, okay, so first I'll have my the columns of my first sheet orders. Okay, and as you can see, you have the sheet name right on top of the column name, which indicates to which sheet this particular column belongs to, right? So as you can see, after this, you have the people table and you have the people table again sorted from A to Z, right? So it is A to Z per table or Z to A per table. Similarly, if I say A to Z ascending, okay, the columns of both the tables get mixed up in order to arrange it in an A to Z descending order. As you can see, I have product, profit, quantity, which belongs to my orders table, and after which I have region, which belongs to the people table, and again orders, and so on. This is because it is not A to Z descending per table, it is a common A to Z ascending, right? And as you can see, you have two region columns over here. One is normal region and the other one is a region with people inside braces. So what does this signify? This tells us that when you want to create a join, you will need to have a common column, a common field by which a join can be established, right? So this tells me that the region of people is the field, common I mean, the region is the field which is common between both these sheets, right? So this tells me the field which has been used in order to perform a join, right? So this is just the, so we have something called manage metadata over here. So when you click on that, we have the different field names which are available inside my orders table. Okay, the table name is given right over here. And we have something called remote field name. So now what does this remote field name stand for? So when I go back to my uh, this page over here, when I click on this preview data source over here, I can rename a column right here in Tableau. So no change is going to be made in my data source, but just for analysis purpose, just for my understand this particular column as I would like to rename this, make it a short form of it. I don't want such a big column name. For example, customer name, I want it to be as CN. I don't want, I want to make it short. It might be any reason. So I can very well rename the column, okay, right here in Tableau. There's no change going to be made inside my actual data, right? So I can just double click on this option over here and I can rename it, okay, or I can click on this drop down arrow and I have this rename option over here. I can use that as well. So let me rename it as CN, okay, customer name, okay, CN. Now the column has been renamed, okay. So again, when I click on this drop down option, I can reset it to the name it originally had, right? As you can see, we have the customer name over here. So now let me rename it as CN, right? And now when I go into this manage metadata, so as you can see, the field name, it displays the field names inside Tableau, right? So CN, I had renamed my customer name to CN. But though I have made a change, only the field name displays the change, but the remote field name, it gives the original name as it is available in the data source. So with this, you can understand that field names are nothing but the names of the fields inside Tableau while working with Tableau. But the remote field name, it is the actual name of any particular field as it is available in your data source, right? So this is the difference between field name and remote field name. So at any point of time, if you have renamed your fields and you would like to view the original name of that particular field, you can use this remote field name uh, option, I mean this column, to just go through that, right? So we'll go back to it and I'll reset the name of this, okay. And then we have different file types, okay, available in Tableau. And as you can see, you have something called ABC over here, you have a globe symbol over here, and you have a hash symbol over here, you have a calendar symbol, and so on. So just click on that small symbol which is visible, and you can see these are the different data types which are available in Tableau. Okay, so this is a string data type. We have Boolean, true or false values. We have date and time, we have number whole and number decimal, and we have something called geographical role. So geographical role is nothing but it might be a country, it might be a state, okay, it might be a city. We also have airports which can be linked with the help of the latitude and longitude. We have built-in latitude and longitude, okay, which can be assigned as a geographical role data type. So geographical role data type is used while creating maps, right? So we'll just go through all those things as well. So basically these are the six different data types which are available with Tableau. So number as in decimal and whole, we have date and time, date, string, boolean, and geographical role. Okay, so this small symbol over here indicates which data type this particular column belongs to. Okay, and we can also find out the number of rows in this particular sheet. So right now 1000 rows are visible. If I would like to say I need only the 5 rows, okay, only 5 rows will be visible. And similarly, if I want to find out let's say the 20,000 rows, so as you can see, 20,000 is something, is a number which was greater than the actual number of rows available in my sheet. So when I specify a number which is greater than my actual size itself, it will automatically be converted to the original size. So when you click on this view data over here right next to my sheet name, you will be able to see the entire data, the total number of rows and all the different columns which are available in this particular sheet, right? And you can very well hide and unhide a few fields. You would like to hide a few fields while the analysis purpose, right? You can very well do that with the help of let's say this drop down over here. You can just click on hide. Okay, so customer ID is being hidden from my view. Okay, so I can just click on this show hidden fields. Okay, after which the field which was hidden will be grayed out. Okay, and I can very well unhide it again in a similar manner. Okay, and we have an option to split as well. Okay, let me say, okay, I have my customer ID. Okay, first I'll have my country. Okay, so when I just for an example purpose, okay, I don't want to split my country as in a real time, as in a real use case scenario. So just this is just for explanation purpose. Okay, so when I go into split, okay, so it will ask the separator by which my column needs to be split. Okay, so I can mention the separator as hyphen or comma, semicolon, colon, and so on. Okay, and it will ask whether you need to split the first half or the last half or split all, right? And the number of columns which you need to create as and you want to place those splits in and so on. Okay, I'll just so let's say you can also split the product name. Okay, you have the split option, and as you can see, product name has been okay, I don't think product name is okay, it's not split. Let's see country. Okay, so you can just let's say column, I mean customer ID, you can just split it. Okay, I'll use the custom split, and I'll have to mention either it's a hyphen or a comma, and the separator, the delimiter, I have to mention it, after which I can separate either the first half or the last half. Okay, so this is the basic splitting option. If you need, you can use these options inside your analysis. Okay, so after going into the sheet, okay, see, these are the different splits that were created automatically with the help of the space as my splitter. Yes, I did not, though I did not mention anything in my product name split, I did not mention a delimiter. It has considered the space as the automatic delimiter, and it has been split into these many number of columns, right? In these cases, space has been chosen as the default split limiter, and in customer ID, hyphen has been chosen as the delimiter. If I want to mention anything else as comma, colon, and so on, I can mention it, which will then be used as the splitter. right? So yes, this is the basics about column formatting and sorting. Okay, now we'll be discussing about these two options over here, the live and extract connections, right? Okay, so now, as I told you, we'll be discussing about the live and extract connections. The differences between live and extract connection. So first, let me theoretically tell you what both mean, right? So when I place any particular sheet over here, those options are visible. Okay, I have live or extract. I can toggle between both. Okay, one at any particular time. I can either have a live connection or an extract connection. So as the name tells me, live connection is nothing but my Tableau is connected to my data source in a live manner. In the sense, there is always a connection between the data source and the Tableau, right? Your data might be in in any type of file, it might be in any cloud. So when I say connected in a live manner, there is always a connection which is established between Tableau and my data source. Okay, so one limitation or one problem which arises when we work with live connection is that the analysis speed or the way you are working with Tableau, the process speed might be affected when your data source is too large, right? There might be a few lags, a few delay while analysis of being performed, or when you're creating visualizations right here in Tableau. But one advantage when you have a live connection is that, okay,
Just a quick info, guys. Test your knowledge of Tableau by answering this question. Which of the following is not a trend line model? A. Linear trend line. B. Exponential trend line. C. Binomial trend line. D. Logarithmic trend line. Comment your answer in the comment section below. Subscribe to Intellipaat to know the right answer. Now, let's continue with the session.
when you try to refresh, okay, your live connection, whatever changes that have been made in your data source, which it will be updated right here in Tableau. Okay, but this refreshing process can also be done when you have an extract connection, but you need an internet connection to perform the refresh when it comes to extract, right? So I'll just explain it once more. When you have a live connection, you need only when you have an internet connection established, live is possible, right? Because you are going to connect it all the way to your cloud or your server or your database, right? So you need internet connection which is established to have a live connection with your data source. Okay, in such a case, while working with the data that you have right now, you can just click on the refresh button, okay, after which your entire data here in Tableau will be replaced by the data which might have updates that has been done during the course of time, after which you have established the initial connection, right? Only when you click on the only on the refresh button, your data will get updated as per the changes made in your actual data source. Okay, but when you choose an extract connection, what happens is a snapshot of your data, of your original data, okay, a snapshot of your original data will be saved right here in your system in the Tableau repository. Okay, so the processing speed is much faster because your data is right here in your system. Okay, every time you needn't go all the way to your cloud, fetch data and perform the analysis. Okay, when you have the extract, you do not have the data, but you have the snapshot of your data right here in your system. So when do we use this extract connection? So when, this extract connection can be useful. For example, when you want to increase the speed in which you are performing the analysis, when you have a very large set of data, and when you establish a live connection, the analysis speed might be affected. So in such cases, you can switch over to the extract connection. On the other hand, if you are traveling, when you do not have an internet connection, you can very well extract, get an extract or snapshot of your original data, and after which you can keep on working, keep on analyzing your data while traveling. When you are in an airplane mode, or when you do not have an internet connection, you can very well use the extract, which will be saved right here in your desktop, right? So, and you can also refresh your extract connection, but only after you have an internet connection established. The particular update made in your data source will be reflected right here in your Tableau, right? So these are the two basic, these are the two, these are the information about these two options available. Okay, I hope you've theoretically understood what are the pros and cons of each, right? So now I have a very small Excel file as an example by which these features can be explained. So now I will change the data source over here. So now I can also connect, multiple data sources to my Tableau. One might be an Excel file, one might be some other file. I can have two or more data sources at one point of time in Tableau and perform the analysis. Okay, that is the concept of data blending. Okay, we'll be discussing that with example as well. So right now, let me first change the connection. So I'm going to click on this drop down arrow. Okay, I can edit the connection, right? I'm going to edit the connection. I am going to connect this live versus extract sample, a very simple file, to my Tableau now. Okay, so by doing this, my sample store will be removed. Okay, and my live versus extract will be placed over here. Okay, so I'll just show you. Okay, this is that Excel file, my sample to explain about live versus extract. Okay, it's a very small file. It has a few names, the states to which these particular users belong to, the date of sales that has been done, and the corresponding sales. Okay, it's just for an explanation purpose, just an example file. Okay, so right now this is my data. Okay, and I'm going to perform analysis on this data, right? So I have connected this Excel file with my Tableau. I have only one sheet, and that sheet is visible right over here, right? So let me say data source order. Okay, so whichever order, as you can see, yes, whichever order it is visible in my data source, okay, the same thing is the same order is being visible right here in my Tableau. Okay, so now I'll go to my sheet. Okay, so since I try to edit the connection, the splits that I made in my previous example or my previous data source remain over here, as they do not belong to my data source itself. It belongs only to Tableau, so it remains right over here. So I'll just delete all these things. So this red exclamatory mark over here tells me that this particular, field do not belong to this data source, right? Okay, so now as you can see, I have date, name, state, and sales, which was available in my data source. Okay, I'll explain what are these dimensions and measures all about. First, we'll discuss about the connections, the two types of connections. Okay, So now I have my name. I'm just dragging the name and dropping it in my view or in my rows. You can use any one method. Okay, I'll have my date, right? And I'll have my sales. Okay, yes, so now I have the information just as it is in my data source. Now I'll go back to my data source. I'm going to add another name over here. Let's say Shruti, who belongs to, let's say, Andhra Pradesh. Okay, and the purchase has been made on, or the particular sales has been done on, let's say 5th of May 2019, and some, let's say 40, just a random sales. Okay, so I have added a new row in my data source, right? And I'm going to save it. Okay, so now when I go into Tableau, okay, so my new field, my new row has still not been reflected. The changes that I have made to my data source has not been reflected over here. So now how to find the change? How to find, okay, I'll go to my data source. Okay, so as you can see, we are connected in a live manner. Okay, yes, so we are connected in a live manner, right? I'll go to my sheet. And now how do we refresh this? Right? So now how do I bring the changes here in Tableau? Okay, all I have to do is, this is my data name. I'll just click over here and I'll choose this refresh option, which is available over here. So when I refresh my data source, okay, okay, so now as you can see, the row that I had added in my data source is being reflected in my data here in Tableau. Okay, so just right click on your data source, choose this refresh button. Okay, after which the updates will be reflected right here in your Tableau, right? So this is with the help of the live connection. This is what happens in a live connection. So how do you refresh a live connection? Just right click and choose this refresh button. Okay, now let's see what happens in a extract connection. So if I want to choose my data source to be connected in an extract manner, just click on this extract. So as it says, extract will include all the data. So right now, what are the different fields which are available, all the necessary columns and rows which are available in my data will be included in the extract. So when I try, so my new field is right now added inside the data as well. Okay, so which means this field is also included in the extract which has been created. So now when I try to go to my sheet in order to perform my analysis, it will ask me. So now sheet 1 live versus extract sample. So save extract as. So this is going to be saved as a Tableau data extract in my Tableau repository, right? So I'll say save. Okay, right? So now my extract has been saved right here in my system. Okay, so right now I do not need my internet connection in order to work, in order to analyze my data source. Okay, so similarly, we have everything just as the same, but you will notice one small change which will indicate that you are connected in an extract manner. Okay, so I'll just show you. See, I did not show you when we were in a live connection. So while we are connected in an extract manner, you will see two cylinders over here. So one indicates the actual data source and the second cylinder indicates the extract which is saved right here in your system, right? So right now, as I was telling you, we have two cylinders over here, okay, which tells me that we have been connected to our data source in an extract manner. Okay, so now I am going back to my data source, okay, and I'm going to add another name, say from some state, and the sales has been made on 10th May 2019. Okay, and let the sales be some random number. Okay, so now I have added another row in my data source. I am going to save it. Okay, and after which I move into my Tableau. So now again I would like to refresh the data inside Tableau. I'm right clicking on it, and I'm clicking on refresh. Right, as you can see, my field that I had added right over here, my last row, is still not being reflected inside my Tableau. Though I had made a refresh, right, this is not being reflected in my Tableau. Now, why is that? Because this refresh button works only for a live connection. So since we are connected in an extract manner, I will have to go into this extract, which is available over here, and then click on refresh. Okay. So as you can see, the entire content of the extract will be replaced during the extract refresh, right? If you have modified filters or hidden fields, lost during, yeah. So when you try to refresh, as I told you, in an extract manner, the entire extract will be replaced with a new snapshot of your new data source, right? Now, after we went into this extract and then tried to refresh it, we have this column, I mean this row, which I had added in my data source. So I hope you understood, what basically the basic differences between your live and extract connection, the pros and cons, right? So you can just toggle between, let's go into a live connection again, okay? And this tells me extract includes all data till this point of time. So this is when I had refreshed last. Okay, so till this point of time, your extract will include all the data which was available in your data source till this point of time. Okay, so after this point of time, if I had made any changes in my data source, only after refreshing the extract, that particular change will be updated in my Tableau. Okay.
Just a quick info, guys. Intellipaat provides Tableau online training and certification course mentored by industry experts. The course link of which is given in the description below. Now, let's continue with the session.
One indicates the original data and the second one indicates the snapshot. And similarly, in a live manner, we have only one cylinder. So with this small difference, you can identify in which way, in which manner your data source is being connected with Tableau. Either it is in a live manner or in an extract manner, right? So while if you're just going to use Tableau for just the practicing purpose right here with our sample superstore, it doesn't matter. You can either have a live connection or an extract connection. That is in no way going to affect your uh, analyzing work, right? Okay. So now again, we'll go back to our data source. I will remove the sheet from the canvas and I'm going to edit the connection. I'll go back to my sample superstore, right? See, it's just clicks away, and as you can see, we had these field names in our view when we were discussing about the live and extract sample, right? So that is why we have these red exclamatory marks. So I'll just have my order sheet and I'll go back here and I'll just remove them from the view, or I can delete them from here. Right? Okay, so now we are back with our sample superstore data. Okay, so now as you can see, again, we are in a live manner. We have connected it in a live manner. We have, okay, the data source name still hasn't been changed, right? So it sometimes happens when we try to edit the connection over here. So though we have a data source over here, name, a new data source over here, the change sometimes might take some time or after a few, after you start working for some time, it'll automatically change. So right now, let me just come back. Okay. So right now I'm going to connect it to a Microsoft Excel file, sample superstore. Yes. Okay. Yes. So we have our sample superstore over here. Okay. Now regarding metadata and data blending, working with metadata, and now today I'll tell you about what are these dimensions and measures all about. Okay. So Tableau is very intelligent. It differentiates, it divides all the different fields available in your data source into two categories, into dimensions and measures. So basically, dimensions are nothing but discrete data, okay? And measures are nothing but continuous data. So now why does it say discrete and continuous? How does it differ the fields? How does it divide those fields depending on discrete and continuous nature? So now let's say category or city or country. These values, they never change. For example, you might add a new country to it, but that particular country is discrete in nature. So that particular country name, I hope you understand what I mean by discrete. The value of it will always remain constant, right? But when it comes to, let's say, a discount or profit, quantity or sales, your sales might keep changing every minute. Your sales might keep changing every year, right? So it is not constant at any particular point of time. It keeps changing. It is continuous in nature, right? So this is what it basically uses in order to differentiate between the fields. So dimensions consist of those fields which are discrete in nature, and measures will consist of those fields which are continuous in nature, right? So I'll just show you, how what major differences are there between these between the fields under these two headings, under dimensions and measures. Okay, so basically when you have a blue color, it means it is discrete in nature, and it means it comes under a dimension. And when you have discount, when you have a green color, okay, it means it is continuous in nature and it is placed under measure, right? So let me just show you how to create a simple view in Tableau. Okay, so this is our workspace. This is our sheet 1 over here. Okay, I'll just drag any of my fields and place it into my rows and columns. Now this space over here is known as the rows shelf, and this place over here is known as the columns shelf. Okay, so I'll place my category in my row shelf, or you can also place it in your column shelf. Okay, and I'll have one measure, or one field under measure which is continuous in nature. I'll place it in my columns. So now as you can see, I have created, I can easily swap these uh, fields in my rows and columns with the help of this icon over here. This is the swap icon. Control plus W is the shortcut. When I just click on this, all the fields in my rows will be moved into columns, and all the fields in my columns will be moved into rows. So now as you can see, I'll just click on this icon. As you can see, my sales has moved into rows and category into columns. So this is a very simple visualizations that we have created now. Okay, so what will happen? We have different marks over here, right? We have so many different marks. We'll be discussing about each and every mark, right? So now to start with, to tell you the difference between dimensions and measures, what I'll do is I'll try to, let's say region. I'll just drag and drop region into the colors mark. Okay, now let's see what happens. I'm just dragging region and dropping into my colors mark. So each particular category is my dimension. Okay, it is discrete in nature. So each particular category is being divided into 4 colors. Now, why 4 colors? Okay, so I have placed region in my colors mark, and region is nothing but a discrete field. Okay, discrete in the sense I have a countable number of values, or it has a finite number of members in its column. I mean, this particular field has a finite number of members. So as you can see, I have the color legend over here. So my region field consists of 4 different values, 4 different members: central, east, south, and west. And each region has been assigned a unique color, right? And this indicates the western region, southern region, eastern, and central, right? So each particular category tells me the sales done under each particular region, right? Similarly, I'll place some other dimension in color. Let's say segment. Okay, you can let's say segment or ship mode. Okay, anything. Let's place our ship mode inside the color. So it is nothing but I'm placing a discrete field inside a color mark. As you can see, it is a discrete field. It has 4 members or 4 finite values. Okay, and each value is being assigned a unique color. Okay, right? So when you place on any particular color, your tooltip gives you the entire information required to know about this particular color or space, right? So this is what happens when we try to place a discrete field inside the colors mark. Okay, so now let me remove this. Now let me try to choose a field from my measures. Let me try to place a continuous field in my colors mark. Now what happens? Okay, I'll take my sales. Okay, sales is already present over here. Let me take okay, let me have my sales as well. Or okay, let me have my profit, any measure for that matter of fact. Okay, so when you place a measure inside your mark, your colors mark, now what happens? I do not have a finite number of values or members inside my measure, because it is a continuous field. Okay, and as you can see, a single color has been assigned, but with a change in shade indicating the lowest and the highest profit, right? Similarly, I can have any measure, and this is the way my view or my visualization will be given a color. Okay, there'll be a change in shade, and there'll be a single color which will be assigned to this field, okay, with just a change in the shade indicating that it is a continuous field. And as you can see, it all my continuous fields will be aggregated, okay, and the default aggregation is sum. Okay, so these are the basic ways you can try and find out the difference between a discrete and a continuous field. Okay, now I'll also show you a few other differences. Okay, let us try and place it in the filter shelf. Okay, this shelf or space over here is known as the filter shelf. Let me have my region, which is discrete in nature, inside the filter shelf, right? So now as you can see, we can filter out the regions. Okay, there are 4 different regions, and I can easily filter out. I can include only these 2 regions in my view. So when I try to have only central and eastern region, and I click apply and OK. So now there's a change in the chart. Okay, as you can see, the bar level has been changed because I have included only my two particular regions inside my view. I need the analysis to be done only for these particular two regions. Okay, so I'm filtering out the unwanted data. Okay, or I'm filtering only the necessary data. You can have it in any way, right? So now when I try to place region inside color, I have only two colors because I have chosen only central and eastern regions. I have filtered out the other two regions. Okay, so this is what happens with a discrete field. Okay, when I try to filter a discrete field. Now what happens when I try to filter out a measure or a continuous field? Okay, I'll have my sales inside the filter shelf. So just drag your measure, place it inside the filter shelf. Now as you can see, we had uh, the values with check boxes when we try to filter out a discrete field. But when it comes to a continuous field, we have this is the way we can filter it out. So it initially asks us what is the, I mean, how do you want to filter on sales? How do you want to aggregate it? Okay, let's say as sum, that is the default aggregation. I'll go into the next dialog box. Okay, and now as you can see, we have different options over here. So now I'll just tell you the different, I'm just telling you the difference of a discrete and a continuous field under each circumstance, how these fields behave, right? Yes, so this is how your measure acts. Okay, you can either set a range of values between which, okay, I need the values only between these particular, I need only the result, only the visualization in between these values, okay, to be viewed inside my view, to be used into my analysis. So I'm filtering out the other values.
Just a quick info, guys. Test your knowledge of Tableau by answering this question. What are the components of a dashboard? A. Horizontal. B. Vertical. C. Image extract. D. All of the above. Comment your answer in the comment section below. Subscribe to Intellipaat to know the right answer. Now, let's continue with the session.
Similarly, I can have this option as well. So I can set a minimum value. Okay, so let it be, let's say this is my minimum value. So all the values at least this or above this are to be displayed in my view. I do not want the values before this range to be displayed. Okay, I can set the minimum value, and similarly I can set the maximum value. Okay, display values only maximum of this number, right? And similarly, we have one more called special option. Okay, we can display only the null values or only the non-null values and all, right? Okay, and one more way, I'll just try to create a map now, and I'll show you how your maps are colored using a discrete and a continuous field. Okay, so in order to clear the sheet up, so I don't want this visualization again. Okay, I'll just use this option over here. Okay, it's the clear sheet option. Okay, when I just click on this, my entire sheet will be cleared, right? So now I'll just tell you how to create a map. Okay, right? So I'll just choose any. In order to create a map, I will need a geographic data type field, right? So let me have my state. I'll just double click on my geographic role field, right? After which this latitude and longitude, which are the auto generated fields, they automatically appear in your rows and columns, right? And we have the state information over here. So this, I'll just create a symbol map over here, okay? Right? And if I want to name each state, all I have to do is just drag the state and place it inside this label mark, okay? By which all my different states are being named. Now, when I would like to color this out, okay? Let's say depending on sales. Okay. Now when I place sales inside the colors mark, the same thing happens over here, right? So the lighter the shade, the lower the sales, and the darker the shade, the higher the sales. So right now I think California is the darkest. So it has the highest number of sales, right? So yes, so this is these are the basics, of how your discrete and continuous field work when you are placing them in the filter shelf or in your marks type, whichever type of mark you have. Okay, and we have something called show me over here, right? So when you click on the show me, you have different charts which are being visible over here. Right now they are just grayed out. Okay, so what are these charts and how can you create these charts, right? So when you place your cursor in any particular chart, it gives you the information. So as you can see in this space over here, so I'm just placing my cursor in this particular chart. So it's a highlight table, right? And what are the basic requirements in order to create a highlight table? So you need one or more dimension in order to create a highlight table, and you need one measure for sure, right? So this show me option, it clearly tells you, so whichever type of chart you want to create, what are the basic necessities, I mean the basic requirements in order for this chart to be created, right? So let's see, for a pie chart, I need one or more dimension, or I need at least one or two measures, right? So we have different charts. We have bar charts, we have horizontal bar charts, we have side by side bar charts. Okay, so we'll just try out one chart. Let me have my category. Okay, and I'll have my subcategory. Okay, and I'll have my sales, right? So with this particular combination, I have two dimensions and one measure. Okay, so it might be in any, it might be either in your rows or in your columns, so that is not going to affect the way you can create charts. Okay, so with these combination, when I have two measures, I mean two dimensions and one measure, okay, so these are the different charts that I can create. Okay, so by default it is a bar chart that is being created. Okay, if I want, I can have a side by side bar chart, or I can have a box and whisker plot, or I can also have a packed bubble. Okay, see, as you can see, you can have a packed bubble, or whichever is precise. Okay, whichever suits your analysis, you can very well go and choose that option, right? So as you can see, we have a category under which all the different subcategories are listed out. Similarly, we have the other categories with the corresponding subcategories. Okay, and this bar corresponds to the sales which has been done in this particular subcategory. Now I can also swap my view, as I told you. Okay, so each box corresponds to a particular category, and all the corresponding subcategories are present inside us. Now we can sort this out. It is all in a jumbled manner, so let me just remove my category. So now I have all the different subcategories, okay, and the sum of sales, right? So when I try, you can easily sort them in the ascending and descending order by the sum of sales with the help of this shortcut, sorting options in your toolbar. Okay, when I say sort, okay, as you can see, depending on the sales, okay, depending on my measure, let it be profit or any measure in this place, it will be sorted out. So I can also try and label my sales. Okay, as you can see, I needn't go into my tooltip, I needn't place my cursor and then get the information about sales from the tooltip. So since I placed my sales inside the label mark over here, I'm being able to view all my bar, all my bars are labeled with the corresponding sales of the particular subcategory, right? So this is being sorted out in an ascending order from the lowest to the highest. Similarly, I can also sort it the other way around. So by this, I can easily find out which category. I can also swap it up. So which subcategory has done the maximum sales? Okay, so by this way, I will, be able to find out the maximum sales, the minimum sales, or let me say the maximum profit and the minimum profit. Okay, just sort it out. As you can see, we also have negative profit. Okay, and the label, we have sales over here, so that's why there's a mismatch. Just remove this up and place profit over here inside your labels. So now, as you can see, we have the highest profit, which belongs to the copiers subcategory. Okay, and we also have negative profit for a few subcategories, and the lowest of which belongs to the table. So though it might have a higher sales, profit is negative in nature, right? So, these are a few basic ways by which you can keep creating your visualizations. Just drag and drop your different dimensions and different measures in your views, okay, by which different types of analysis can be performed. Okay, similarly, we have, okay, I'll just have my sales back here. Okay, so we have this tree map over here. Okay, so now this is nothing but a tree map. Okay, so as you can see over here, this symbol indicates the size. Okay, the size of each box corresponds to the profit. Okay, the color corresponds to the sales. So the darker the color, the higher the sales. Lighter the color, the lesser the sales. Okay, and the subcategory, is being labeled inside the label. So each box is being labeled with a subcategory. Okay, so you can keep changing the chart, or you can keep changing the measures and dimensions which are being included in your view, right? So this is the basic differences between your dimensions and measures, your the way it reacts or the way it performs when placed inside filters and inside your marks and in your visualizations. Okay, so yes, so now I'll just clear the sheet up. Okay, so now we have this option over here. So this Tableau icon over here. Okay, when I click on that, I will be directed to my start page. Okay, this is the start page of Tableau. And when I click on this again, I'll be moved to the sheet from where I had moved to the start page. Like for example, if I am in my data source and I would like to go to my start page, and again I'll be moved to the data source sheet, right? So then we have undo. So in Tableau, we have n number of undos. You can keep on undoing your data n number of times. Okay, there's no limit for undoing your data in Tableau, right? So this is the tool, the toolbar and the undo option over here. Okay, and this is the save option. Okay, in case you want to save any particular view, you can use these options, or you want to save all your visualizations. Okay, you can use these options. Okay, and this is about the data connections. Okay, you have to add any new data source, you can do that. Okay, and this is, you can pause auto updates in case you have assigned a scheduled refresh, right, in your Tableau server while working in your desktop, Tableau desktop over here. In case you do not want any updates to interrupt your analysis, right? You can very well pause the updates. Okay. And then we have this new sheet option over here. So we can create n number of sheets, okay, in Tableau. And this is one shortcut by which you can create a new sheet. So when I just click on this, my second sheet is created. I had only one sheet and this is my second sheet. Okay, or you can also go into worksheet and create a new sheet, right? And similarly, when you click on this drop down arrow, you have new worksheet, new dashboard and new story. Okay, These are the ways by which you can create a new sheet or dashboard or story, right? And we have something called duplicate over here. Okay. For example, if I have a base, some visualization that I have created in this particular sheet. Okay. So if I want this visualization to remain as it is, okay, as well as I want to perform further analysis in this visualization itself, right? So I can have the sheet as it is, I can create a duplicate. So I needn't go to my other sheet and start building this view from the scratch. This might be a very basic view, right? So it can be done in seconds. But when we have a very complex visualization with many dimensions and many measures or fields in my marks, okay, and with filters and so on. So when I want to create a duplicate of this particular visualization and I do not want to perform all these actions again right from the scratch, I can create a duplicate, okay, by which sheet 1 of 2 is created. So I'll have my sheet 1 as it is, and I'll make changes to my sheet 1 and so on. Okay, so this is the use of this duplicate icon. And this clearing the sheet, I've already told you, everything in your sheet gets cleared up. And when you click on this drop down arrow, you can clear your sheet. Okay, you can clear the only the formatting of this particular worksheet and all these options. Okay, you can clear the filters alone, access your sizing and so on. Okay, this is the option of clearing. We have the swap option. Okay, we just now discussed about it. Okay, it just swaps from the rows and columns, the fields in your rows and columns, the sorting in ascending and descending order. Okay, we have this highlight option. We have different types of highlight. Okay, we have around 4 to 5 different types of highlighting options. And this option is just to enable or disable your workbook highlighting. Workbook is nothing but a collection of worksheets, dashboards, and stories. The entire set is known as a workbook, right? So you can enable or disable your highlighting, okay, to your entire workbook, or you can enable or disable the sheet highlighting if you had one. Okay, and highlighting can be done by any one of these fields. So okay, so these are the options which comes under highlighting. Okay, this is actually a very a shortcut menu for highlighting. Okay, and this is nothing but you can hide the mark labels, and you have this fix axis. This is used when we have our maps in our sheets. Okay, it is used to fix axis. Okay, this is about the size of our view. Right now it is the standard size. Okay, if you want to fit width, the entire width will be utilized. Okay, fit height is similar to the standard view. Okay, because the entire sheet is being, I mean, the height is being used. Okay, an entire view is just nothing but your fit width. Okay, so when you have complex visualizations, this will work accordingly. But basically, this is what happens when you change the type of view, the size in which your view is to be done. Okay, and this is nothing but the show and hide cards. Okay, so these are known as cards or shelves. So this is my page card or page shelf. This is my filters card or filter shelf. Okay, this is my marks card or shelf and so on. So if I want to hide them or if I want to unhide them, I can very well use these options. So right now we have the marks card, filter shelf, page shelf, row shelf, column shelf. Okay, my title, which is nothing but this sheet 1 over here, it is being visible. Okay, and we have something called caption. So if I try to make caption visible, as you can see, this is just summarization of what is being visualized in this particular sheet. Okay, so this sheet gives the information about sum of sales for each category, right? Color shows details about region, right? Color shows details about region, and the marks are labeled by the sum of sales. So by default, a caption is created with the fields that are used inside the visualization. If you want, you can manually type in any caption, okay, some extra information that you need to provide inside, about this particular sheet, okay. And we have summary, okay. Summary is nothing but similarly the sales for this particular measure, okay. We have the sum, the average, all the different aggregations, right? And we have legends as well. So what are the legends? Right now we have only the color legend, okay? We have shape legend and size legend. So we have the size mark over here. Okay, let me just remove this region from colors. Okay, my color legend is no more visible. Let me have my region inside size. Okay, as you can see, there's a change in size for each particular region. So as we had colors differentiating between the four regions, now it is being differentiated with the help of this size mark. So this is the size legend. So these legends, they just give information as in for which particular size belongs to which particular region, right? So it's just like a key to whichever mark, let's say size or shape or color. So this is all about legends, okay? And filters. We can filter this particular visualization using category, region, and sum of sales, because these are the three fields which are being used in our visualizations. Let's say I want to filter it by category. Okay, as you can see, an interactive filter is visible over here, and automatically my category field has been moved into the filter shelf. Okay, so now I can choose any categories for which I want the view. Whichever category I want to be visible in the view. If I want only furniture category, only that is being visible. If I want only technology, only that is being visible, right? So this is all about filters, okay, and highlighters. So I can also highlight using this category and region, okay. I cannot highlight using my measure, and that is why I have only my dimensions over here, okay. So let's say I wanted to highlight by region, okay, and this highlight is automatically created, okay. And when I click on it, all the four different regions are available, and when I keep moving on each particular region, that particular region gets highlighted, okay. This is a very basic feature of highlight, right? We have different types of highlight, okay. We'll be discussing all these things in detail, right? So this is default highlighting option, right? I can also highlight it by category. Okay, we'll just try that. I'll just remove category from filters. Okay, and I'll try to highlight using category. So I have highlighting of region and category now. I want only furniture to be highlighted, and inside furniture I want only central region, eastern region, okay. Since we do not have filters, if I would have filtered the furniture option, okay, only the region of furniture would have been highlighted. But since highlighting is just we have all the fields, categories in the view, okay, they are not removed from the view like filters. When we had filters, we had the other categories completely removed from the view, okay. But that's the basic difference between highlighting and filters, okay. And so I can highlight using these options, okay. This is just to make your visualization more interactive and interesting, okay. Then we have this presentation view, okay, which can be used when you go in for presentations, right? And we also have the share workbook with others, okay? And so we have two sheets now, okay? Let me just tell you a little about how a dashboard looks like. Okay, let me delete this second sheet. So now I have sheet one and a duplicate of sheet one in which I have made it a few changes. Okay, so you can also You can create a new worksheet, okay, or a dashboard or a story by either going into worksheet, new worksheet, dashboard, or story, new story, or you can use this tool icon from the toolbar, or you can use these options over here. So new worksheet, new dashboard, and new story. Okay, so this is how a dashboard looks like. All the different sheets will be visible right here. Okay, all I have to do is just drag and drop into my view, right? So all the filters, legends, everything will be visible in our dashboard as well. Okay, so this is how we create a basic sheet, and with the help of the sheets, we create a dashboard. And story is nothing but you have your sheets, your dashboards, everything in a single view, and that is your storyline. Okay, so we'll be starting with this note on file types. Okay, so as I told you, .twb, which is nothing but the Tableau workbook. This is your default file type in Tableau. Okay, it holds all the content on your worksheet, your dashboard. The it just stores the entire workbook which is created. Okay, it stores all the information regarding a particular workbook. So as the extension, as the name tells you, it's Tableau workbook. It holds all your worksheets, dashboards, stories, everything which comes under a workbook, right? It carries all the information regarding your data source connection and also the metadata created for that particular connection. Okay, it has information such as like what fields are being used in each view or in each sheet. Okay, how your measures are being aggregated, what are the different formatting that you've applied, the different styles of formatting, anything that is made to the dashboard or worksheet or story, everything will be saved, everything will be, this extension, this file type will contain all these sorts of information. Okay, it but one main point about this file extension is that it relies completely on your live data source. Okay, as it does not, it contains only your workbook. It does not contain any data, okay, within the workbook file. So because of this, it is completely reliable on a live data source connection. Okay, so what is the use of this file type? This file type, .twb or Tableau workbook can be shared only to those people who have access to the data source, because as it does not contain any data, as it relies completely on a live data source, the people whom you share this workbook with should have an access to the data source. So only then they will be able to open the workbook and uh, you know see what particular analysis is being made inside your workbook, right? Else there is no point in sharing this workbook without the data for which this workbook has been created, right? So this is the default file type which will be provided while saving a particular workbook in Tableau. Okay. Next, we have the Tableau packaged workbook. We have it over here. So it's .twbx. Okay. So it bundles the data with workbook, with your corresponding workbook, right? So we had only your workbook information in .twb, but whereas in contrast, this packaged workbook, it contains both your workbooks and the extracted data, right? It also includes any picture actions, any geocoding that you have been added to your workbooks. Okay, it's just like you can compare it with a zip file, right? If you rename this Tableau packaged workbook as a zip file, you can open it in Windows and you can see all your workbooks and corresponding data files. Okay, it has the extracted data. So we have a file and extension for the extracted data as well. We'll be discussing after this actually. It's known as the .tde file, as you can see over here. Okay, it's the data extract file. So your packaged workbook .twx will contain your extracted data as a .tde file. Okay, and these files can be shared to clients who do not have access to the data source, but who need to view the workbook. right? So your .twb, your Tableau workbook, will contain only the workbook information, whereas your packaged workbook will contain your extract file along with your, along with the corresponding workbook. Okay. And when you want to save your file as a packaged workbook, when you want to save your workbook with this particular extension .twbx, you will have to go in to an extract connection and then save it as a packaged workbook. You cannot save your workbook as a packaged workbook when you are in a live connection, okay, because it includes a data extract file. You have to change your connection as extract, by which an extract will be saved in your Tableau repository, and after which you will be creating you will be saving your workbook as a packaged workbook, which will contain the extract data file along with your workbook, right? And we have the .tde, the data extract file. Okay. And as we had discussed yesterday during the live and extract connection, when we were working with an extract connection, before moving into the sheet, Tableau had asked me to save the extract in the Tableau repository, right? So that is the .tde file. So as we know, extract files are nothing but they are just a snapshot, okay, or a local copy of the entire data. Okay, it doesn't store any connection string. Okay, it shares only the underlying data and it cannot be refreshed. So when you have this extract file in your system, your processing speed will be increased when compared to a live connection. Okay, so this is about the extract file, and .tde is a file extension which was available in Tableau initially. But as newer versions were launched, we have something called .hyper, in which our data extract is being saved nowadays. Okay, it's a new in-memory data engine, right? And with this new data engine, the extracts in Hyper, they take advantage of the improved data engine. Okay, it supports like faster query performance is being made, right? As when you compare with the data engine which was before. Okay, and you can also save larger extract with a faster analytic and processing speed when it comes to your .hyper file extension. Okay, you have many other benefits, like you can create and refresh, faster when compared to your .tde file. And there's one limitation when it comes to your .hyper file: you cannot downgrade.
Just a quick info, guys. Intellipaat provides Tableau online training and certification course mentored by industry experts. The course link of which is given in the description below. Now, let's continue with the session. Just a quick info, guys. Test your knowledge of Tableau by answering this question. Which of the following is not a trend line model? A. Linear trend line. B. Exponential trend line. C. Binomial trend line. D. Logarithmic trend line. Comment your answer in the comment section below. Subscribe to Intellipaat to know the right answer. Now, let's continue with the session.
Okay, you cannot downgrade because TDE or data extract file. Then we have the data source, Tableau data source .tds file extension, right? So when you connect with your data source for the first time, okay, you will have some modeling works or formatting works to do. Okay, and this particular .tds file, it contains the information required, like to connect to your data source, as well as other custom and calculated fields such as changing aggregations, creating groups and sets. Okay, all these changes which are being made inside your data source here in Tableau will be saved in this .tds file. Okay, so when you're trying to change the metadata, changing the metadata in the sense you will perform some formatting options, you'll try to split, you'll try to sort it out in some particular order that you wish to. Okay, all these kinds of information are stored in this .tds file. Okay, and by saving these changes as a TDS file, you can make use of the metadata changes next time when you use the file. Okay, so that's the use of this TDS file. It just saves the path and the necessary metadata changes, all these kind of information, but it does not contain the actual data. It is not like your data extract file, which will have the actual data. Your data source.tds file will only have the information regarding the data source, but not literally the actual data, right? So, and similarly, just like our workbook and packaged workbook, we have the data source and packaged data source file extensions over here. Okay, so as we went through the packaged workbook, so this is also something like this packaged data source file will contain the .tds file over here, which will contain all the information, the path, the way, all the metadata changes, all those necessary information about the data source. So your package data source will have your TDS file as well as your data extract, right? So with this packaged data source, you have your extract and the necessary changes regarding the information regarding the necessary changes made to the data source, right? When someone has access to your data source and would like to view the data with all the metadata changes, right, you can share the packaged data source to them, okay, as it contains the extract data and also the metadata changes that you have made as per your desire. Okay, so no worksheets or dashboards are contained within this packaged data source. It has only extracted data and the changes made to the and the metadata changes. Okay, and it can refresh the extract data as the data source is within the TDSX file, right? When you have an internet connection, you can very well refresh your extract just like we normally do with the extract file that we have. Okay, and it can also be used offline since it contains an extract. Okay, so this is all about the packaged data source file. And we also have a few more that are not listed on this table over here. Okay, some 2 or 3 more simple ones, right? We have the .tbm file. TBM stands for Tableau bookmark. Now, when do we use this Tableau bookmark file extension? Right? So it saves the worksheets when working as a team to create a workbook. For example, you are in an organization, you are planning to create a workbook with say some 10 to 15 sheets, and you have divided this work to your team, which contains 10 to 15 members. So each member will be assigned to create a sheet, and they will save that particular sheet as a Tableau bookmark. Okay, after which you will be combining all the bookmarks, which means you'll be combining all the sheets and you'll be creating a complete workbook, okay, with the help of all these sheets. So each user or each team member has created a sheet and saved it as a Tableau bookmark.tbm file, and after which you will be combining all the worksheets to create a workbook. So when you work as a team, when you want to share the work among n number of people, you can use this particular file extension. Okay, and you cannot create a bookmark from a dashboard page because your bookmark will contain only worksheets, right? That is one important point. So only worksheets can be saved with this particular file extension .tbm. Once you move into a dashboard, you will not be able to save a dashboard itself because dashboard is a collection of worksheets. So the lowest granular level, which is the worksheets, can be saved as your bookmark file. Okay, and then we have something called Tableau preferences .tps file. Okay, so like why do we, what type of information that this file extension consists of? When you wish to create a custom color palette, as in for your organization, you will have some particular color, some particular pattern to be present in all your worksheets, some particular theme for your workbook, like company brand colors or logos or any such kind of information which is unique only for your organization, when you need this type of custom changes, to be present in all your worksheets, okay, you can save these in as a .tps, which is nothing but the Tableau preferences file. And what is the advantage of saving these as a file? Okay, you can use this file across all your workbook, because these changes will be applied to your entire workbook very easily. You needn't go manually and keep applying this custom changes, these color palettes, this theme for each particular worksheet or dashboard. So when you try and save a file with this extension, your entire workbook will have the same, you know color palette or theme which you have been used or saved in this particular extension, a file extension. Okay, and we have one more, which is the Tableau map source .tms. Okay, so when we need to create a map with Tableau, okay, we can also uh, create custom maps. Either you can download it from a map box, you can get it from a map box, okay, or might be you can get a custom map from the web mapping service WMS server. Okay, you can use all these custom maps right here in Tableau, and generally this custom maps are used to save with this file extension, Tableau map source.tms file. Okay, and when you want to save the custom maps with your colleagues, okay, who are working on the same workbook, or with the same process of analyzing this particular data source, you can share this file extension with your colleagues, so that your custom map will be shared to the people whom you would like to share it. Okay, and next, we have the lesser spotted file extensions. This is just for information. In case you come across any of these file extensions, you should know what it means. So they are very less spotted, because they are the file extensions regarding the license activation. Okay, we have something called .tld. It's the Tableau license disconnected file extension. It contains information regarding the license of Tableau. And we have something called .tlf, which stands for Tableau license file. Okay, it contains the license file of Tableau, and you also have .tlr file, which is nothing but the Tableau license request, return, or response. So all these files are lesser spotted, and it is something which is related to the license activation, so we wouldn't be using that much when we work with Tableau. Yes, so this is all about the different file types that we have in Tableau. And while saving your Tableau workbook, you can just toggle between these different file types and save them. Okay, and as per your requirement, right? So this is all about the different file types. So after which we'll be moving into, which is about data join and data blending. Okay, so for that we'll go into our Tableau, and we'll try to connect it with our sample superstore. Okay, yes, so we have connected uh, our sample superstore data source with Tableau now, right? So we have 3 sheets. Now we'll first discuss about data joining. What is data joining in Tableau? Okay, so data joining is nothing but you can join any 2 tables or 2 sheets from the same data source file. Okay, you can join any 2 tables in your Tableau and perform your analysis. So when you want to join any 2 or 3, or you can join a maximum of 32 tables in your canvas over here at one point of time. Okay, so when you try to join, you should have a common field or a key or a foreign key, the common field between those 2 tables by which the join will be performed, right? So, and data joining, as I already told you, can be done only between tables from the same file. Okay, though you have similar information in another Excel file, and when you try to have two data sources, you should go to a data blending option, which is much better in that case. Okay, in our earlier versions we did not have an option to join when we had to join tables from two or more data sources, but in the latest versions we have the joining process also. But the way it works definitely differs. Okay, the how data join and data blend works differs. We'll see the differences one by one today. Okay, to start with, we'll stick on to data joins. First we'll finish off data joins, and then we'll move on to what is all about data blending. Okay, so data join basically can be done between tables or sheets which belongs to one particular data source. Okay, so here we have three different sheets. We have orders, people, and returns, and I'll have my order sheet, and now I'll try to join my second sheet. So yesterday we had only one sheet in our canvas and we were working with this particular sheet. We went into our sheet, we tried to create visualizations. Okay, so now we'll be trying to join another table with the existing table, and let's see what are the different types of joins and the requirements for a join to be performed. Okay, so now as you can see, the inner join is the default join when you bring in two tables inside your canvas. So this is the default type of join which takes place, and only because you have a common field a join is being possible over here. So when two tables do not have a common field or a key to join, you will not be able to join them in either of the type. Yes, so as you can see, initially we have, I'll just type some random number and it tells me the exact number. Okay, it has, or you can just go into this icon over here and find out the total number of rows which is available in this particular table. Okay, so we have these many number of rows in my orders table. So when I try to create a join, okay, we have the same number of rows because the common key is nothing but the region. So uh, all the data which is present, all the rows which is present in orders is being matched with all the rows which is present in the people's table. So there's a complete match as we have an inner join. So that is why we have the same number of rows. Okay, and inner join is nothing but all the information, all the rows which are common, which match in both the tables will be displayed. The explanation for all these joins is just like as we have in SQL: inner join, left, right, and so on, right? And left join, as you can see, all the information from my left side table will be included, and all the information which match both will also be included, right? So this diagram tells you, and when you place your cursor, you have the necessary information. It includes all values in the left table and all matches from the right table, right? And members without matches will show up as nulls on the right. Okay, so right now we do not have any null values because every row in orders has a match in your people table, right? And when we try to move into a right join, since we have a complete match between these two tables, now we are getting the same number of rows over here. And right join, as your explanation tells you, it includes all the rows from your right side table, including the matches from your left side. And a full outer join will again have all the rows from all your tables. Okay, so these are the joins that we have in Tableau. Okay, inner join is the default join. Okay, and we'll just try to join two other tables now. Okay, let me have orders with returns. So now with orders and returns, if you want to find out which is the key, okay, this will be displayed right over here. Your order ID of orders table is being matched with order ID of your returns table. And by default, it's a inner join. Okay, and as you can see, there's a change in the total number of rows because only these many number of rows are being matched with these two tables. Okay, and when we try to change the type of join, okay, you will have more number of rows as you are including all the rows which belong to your orders table, which will have all the 9,994 rows, and those that match with returns will also be included. Okay, so that is why there's a change in the number of rows. And again, when you move on to your right join, you'll have the rows from your returns table, all the rows from your returns table, okay, will be matched. I mean, and all those matchings with the left side table will be included. And again, your full outer will have the entire rows when you join both the tables. Okay, so these are the different types of joins, right? And when we do not have a key to join, you can very well tell Tableau, in case you have the same content with a different column header, you can tell Tableau to create a join. Okay, and before we move into blending, into data blending examples, okay, we'll just have a look at something called union, which is mentioned over here, right? So we have something called new union. Okay, union, if your data supports union, only then this option will be displayed over here, right? So only if your data supports union, this option will be displayed over here. Only if there's a possibility to combine all the different tables, or or any two tables as a union, this option will be displayed here, else it will not be displayed over here. Okay, and when it comes to joins, it appends the result sets horizontally, right? That is one point when it comes to joins. But when you consider union, your union appends the result sets vertically. Okay, so that is one difference between your join and union. Okay, your union will just combine two or more tables, okay, by appending values from one table to another, but in a vertical manner, right? So if you want to create a union, you have to just double click on this. You will have the different ways by which you can perform the union. You can just drag and drop your fields inside this space over here to the tables that you would like to perform a union on, or you have this wildcard tab over here. Okay, and you can include, for example, if you have n number of tables and you want all the tables with a particular uh, suffix or prefix, let's say you can use this asterisk sign. Okay, and mention, for example, if you have the month information, the for example, let's say 2019, you have Jan 2019, Feb 2019, you have 12 different tables, or you have n number of tables for all the years with the months as Jan 2018, Feb 2018, and so on till 2019. And if you want to perform a union of only one particular year, let's say I'll say asterisk 2019 or asterisk 2017, all the tables which consist of this particular suffix 2017 will be included in the union. Okay, you can also try and exclude that. Okay, it's all up as per your requirement. Okay, and if you want your expand to be search all your subfolders and all the different folders which is available in your desktop itself, you can do that. Okay, so this is all about the union. So now I'll just show you when we have a join which is being made over here. When you go to your sheet, okay, you have your dimensions and measures column. Okay, right now we do not have any measures which belong to this people table. We have only two columns or two fields in people which are discrete in nature, right? So this is because, so whenever you create a join, when you go into your sheet, you will have your dimensions divided into those many number of tables which belong to your join. So these dimensions belong to my orders table, and these dimensions belong to my people table, and these are the measures which belong to the orders table, since people do not have any measures as such, right? So this is how your sheet looks like when you have created a join over here. Okay, so to explain about data blends, I have two Excel files with which we will be, performing a blending action, right? So for that, I'll just uh, close this up. I'll just open my Tableau again, and I'm going to add two data sources to perform a data blending action, right? So first I'll have my data blending sample one, which is nothing but the office sales. Okay, and before that, let me just show these two different files over here. Okay, we have something called office sales and coffee sales over here. Okay, so this is my office sales. So I have four different columns over here: the state code, the state name, the market, and office sales. Okay, and we have coffee sales over here, which consists the information regarding this particular data source, like product type, your product name, state, region, and coffee sales. So as we are trying to create a data blend, okay, why we are creating a data blend? Because these are two different Excel files, these are two different data sources. So when you try to combine tables from multiple data sources, data blending is the option that you should go for. Okay, and as you can see, we have one common field, which is nothing but the state in both my Excel files, right? And we have something called region and market over here, as I just now told you while explaining about data join. The content is just the same. We have all the four different directions which are mentioned over here, right? But the column header is different. So Tableau will not recognize this as a key. It will recognize only state as a key. So right now we have state as a common field, which will be recognized by Tableau. But in case we do not have the state column over here, Tableau will not recognize region and market as a key. So at that point of time, we have to edit the relationship between these two Excel files. Okay, and we have to tell Tableau that please create a blend with region and market as the key, right? Both these fields are common in nature, so please create a blend. So we will have to edit the relationship manually, right? So we'll see first with the common field which is already available how blending can be done, right? And then we will see how to edit the relationship in case when we do not have a common field between the multiple data sources. Okay, so this is all about our data source, the Excel files that we are going to work with, right? Okay, so now I have, and there's one more point over here. When you have your office sales connected to the Tableau, and then when you try to add another data source with this option, okay, it means you are assigning office sales as the permanent primary data source and your coffee sales as the permanent secondary data source. I'll just tell you that. We'll go into the sheet first. Okay, I have my office sales. I have only one data now, one data source Excel file connected to Tableau right now. Okay, and now with the help of this option over here, add data source. Okay, I'm just going to click on this. I'm going to add another Excel file, and that is going to be my coffee shop sales. Okay, and as you can see, when I go into my sheet, I have two different data sources over here. So when I click on office sales, the necessary information regarding office sales is displayed. The dimensions and measures which belong to only to office sales is displayed. And when I go into my coffee shop sales data source, the dimensions and measures which belong to this particular data source is displayed right over here. Okay, but when you try to add your data source right from your data source sheet over here with this option, Okay, what happens is, we'll just see that. Okay, so this is when I added a data source after moving into my sheet. Okay, so now if I can assign, I can change the primary and secondary data source as my desire. Now how do I do that? How do I assign the primary and secondary data source? Okay, so when I have, so state is the common field between these two. I'll just have my state. Okay, and I would like to compare the sales of the coffee shop and the office sales in one single view, right? So as you can see, I dragged the state from the coffee shop sales into my columns, and now there's a blue tick which is being visible right next to the cylinder over here. And as I told you yesterday, we have one cylinder because we are connected in a live manner, and if we have two cylinders, we would have been connected in a extract manner, right? So since we have only one cylinder over here and it has a blue tick, this means that you have chosen coffee shop sales as your primary data source, right? Now I'll have my coffee sales in the view in my rows, and I'll go into my coffee sales, just click on the other data source, and you have this link icon over here which tells you that state is the key with which both your data sources has been linked. Okay, and I'll drag my office sales in my rows as well. Okay, so now as you can see, there's an orange tick over here indicating that your office sales is the secondary data source. Now in what way does this affect your analysis, your performance? In what way does primary and secondary data source affect your view? Okay, so now data blending is nothing but it's a left outer join. So when you blend tables from two different data sources, the join which is being made is the left outer join. Okay, that is the only type which can be made when it comes to data blending. So when you say left outer join, you need a table on the left side and you need a table on the right side, right? And I hope you can visualize what I'm trying to say. Left outer join. Okay, I'll just show the symbol for left outer join. Right now we have only one. Okay, I'll just tell you that after finishing of this. Okay, when you try to blend tables from two different data sources, the join which is being made is nothing but the left outer join. So your primary data source will be the table on the left side, and your secondary data source will be the table on the right side. So all the information from your left side table, which is your primary data source, will be visible, including the matches from both the tables, right? And that is one way which by which your primary and secondary data source will affect your view, right? So right now we have coffee shop sales as our primary data source and office sales as the secondary data source. And as you can see, we have two null values over here because we do not have these two states in our office sales. It is being displayed as null values. Okay, but in the case of an inner join, this will never happen because only the matching values will be displayed. But since it is a left outer join, okay, all the information in my coffee sales are displayed, but only the matching ones in my secondary data source are being displayed with null values, right?
Just a quick info, guys. Test your knowledge of Tableau by answering this question. What are the components of a dashboard? A. Horizontal. B. Vertical. C. Image extract. D. All of the above. Comment your answer in the comment section below. Subscribe to Intellipaat to know the right answer. Now, let's continue with the session.
So I'll go into my second sheet. Now, as you can see, every sheet, the primary and data source that we choose in every sheet is independent of the next sheet. Like every single sheet is independent of each other. So if I choose coffee shop as primary and office as secondary, this will not be reflected in my second sheet. My second sheet will start from the scratch. So right in this sheet I can decide the other data source as my primary and secondary and vice versa, right? So we had of coffee shop as primary and office as secondary. We'll move into our second sheet we'll have office sales as primary. I'll take state from my office sales. Okay, and we had only 3 states in our office sales, right? See, we have only Delhi, Kerala and Orissa, and all the states are being visible over here. But when you try, and I'll have my office sales as well, right? So I am going into my coffee shop. So my office, now my office sales has been made the primary data source. I'll go into my coffee shop and I'll take my coffee sales and place it right over here. Now, as you can see, we have one null over here. Though we had around 4 different states in our coffee, sales table, only 3 are being visible because these 3 belong to my primary data source, and only the matching values are being displayed over here with a null value in my coffee sales. So I hope you understood, the change that is being made because the changes in the primary and secondary data sources. Okay, so the basic join, which is by which these two tables are being combined, is by the left outer join. So whichever is my primary data source, that particular data source, all the information regarding in that table will be displayed, and only the matching ones from the secondary data source will be displayed. I hope this point was clear so far. Okay, the difference between, and you can also see the symbol over here. My office sales has an orange tick, which tells me that office sales is a field or a measure which belongs to my secondary data source. And similarly over here, you have, when you go onto your second sheet, you have coffee sales, which is, given with a orange tick indicating that it is your field or measure from the secondary data source in this particular sheet, right? So this is the basic way of how you blend your data. Okay, we can also create calculated fields. We can also apply some blending calculations if we require, right? So in our example right now, we have office sales and coffee sales. Now I would like to see the sum or the total sales, the sum of coffee sales and the sum of office sales. I want another bar graph which tells me the total sales. Okay, we can perform this, this type of calculation. This is known as a blending calculation. We are trying to blend fields, measures from 2 different data sources. We are combining it into one calculation, and we are trying to display that information as well in our view, right? So this is known as the blending calculation. So Tableau allows us to perform such calculations, right? Okay, but before that, let me just tell you one more point. So I tried to, add a data source after moving into my sheet. Now what happens, or why I did not try to add a data source from this option mentioned over here? Okay, there's a small change by adding your second data source using this add button, and by using this add data source button after moving into your sheet. Okay, let's see what happens. What is the change that is being made? Okay, I'll just delete the sheet. Okay, and I'll just clear the sheet. And once you clear the sheet, the blue and orange tick marks are disappeared, because right now you can choose your primary and secondary data source as per your desire, right? So I'll just try to close my coffee shop sales, and I'll go into my data source. So right now I have only my office sales, and in my sheet as well I have only one data source to which my Tableau is connected, right? So now when I try to add a data source with this option over here, okay, I'll add my coffee sales, right? We have office sales. I am adding another data source, which is my coffee shop sales. So now, as you can see, I had office sales initially, which is blue in color over here. Okay, there's a vertical line right next to it indicating that it is your primary data source. Okay, and we have the coffee shop data source over here, in which is orange in color, indicating that it is your secondary data source. And by default there's an inner join which is being created. Okay, and similarly you have this blue and orange line over here indicating that this will permanently be your primary data source and this will permanently be your secondary data source. Okay, and this is one difference by adding your data source using this option and after going into your sheet. So once you add the data source after going into the sheet, you can manually change the primary and secondary data sources, as per your requirement per sheet. But when you try to add another data source in your data source page itself, this is the point which happens, this is the thing which happens. Your first data source will be made the primary and your second will be made the secondary data source, and there's an inner join which is being created. Okay, how is there a join being created when we have tables from two different data sources? Okay, so this is a feature that Tableau has introduced in, I think after Tableau, I mean from Tableau 10. That's the version from which this feature was introduced. But before that, when you wanted to, combine tables from multiple data sources, blending was the only option. Okay, you can try joining your tables as well, but one disadvantage is that your primary and secondary data sources will be fixed over here. But in our case, when we try to blend the data, okay, we had the option to change, to move between the primary, to change the primary and secondary data sources as per our desire. So again, I'm going into my office sales. I have only one data source and I'm going to add another data source with the help of this icon over here. So again, we have, we'll go into a sheet. Again, we have two different Excel files over here, two different data sources. Okay. And we just now tried to, bring in our state and the sales information from both these data sources. Now, in case if we do not have a column which was common in between these two data sources. So now what can be done in such a scenario, right? I told you we can edit the relationship between these two. And now we'll try to see how to use a calculation inside after you blend your data, right? Okay. How to include measures from multiple data sources in a single calculation and how to retrieve the necessary information from that, right? So we have two data sources, the coffee shop and office sales right now. Okay. So coffee shop sales, it has four different states. Okay, and whereas my office sales has three states, right? So I'll choose my coffee shop. It has more number of states, right? So I'll choose coffee shop as my primary data source. Okay, so I'm bringing the state of coffee shop sales into the columns. Yes, so I have chosen the state column, the state dimension from my coffee shop sales. So by this, my coffee shop sales data source becomes the primary data source, right? After that, I will have the coffee sales measure in my rows, okay? And I'll go to office sales. I'll bring my office sales measure into my rows as well, right? So if you want, I can swap it up. Okay, as you can see, we have four different states, okay, from the coffee shop data source, and we have the corresponding sales. And similarly, since it is a left outer join, only the matching states from my office sales, which is the secondary data source, only the matching states values are displayed and the others are displayed with a null value. Now I would like to create a calculation named as total sales. So that calculation should display the total sales done in these states in both in both this data source as well as this data source. So I want to add up the sales of both these measures, and I want that value to be displayed in my total sales calculation, right? So how do I create a calculated field? You have a small drop down arrow right next to dimensions. Just click on that. You can create a calculated field with this option over here. Okay, and you just name your calculation. Let it be total sales, right? And now the calculation is nothing but it's just the summation of my coffee sales and my office sales, right? So right now we are inside the office sales, right? So I will say sum of office sales. Okay, since this office sales belongs to the data source that we are right here. Okay, and when you try to say sum of coffee sales, now as you can see, since coffee sales does not belong to the data source that we are working on right now, it belongs to the primary data source. We have this, the name of the data source, and then we have the name of the measure, right? So similarly, if we try to create a calculation inside our primary data source, let's see what happens. Okay, you can create this calculated field in any, or let it be a primary or secondary data source. There's going to be no change. Okay, so now right now we are in our primary data source, and I'm creating a calculated field, say total sales. Okay, and over here you have your sum of coffee sales, which belongs to this particular data source, and your sum of office sales, which will be displayed along with the data source name, right? As you can see over here. Okay, so now there's an extra sum. I hope, no, it still contains an error. We have an extra closing brace over here. I think it should be fine now. Yes, the calculation is valid. So we are just summing up the coffee sales and office sales, which belongs to this particular data source. So this is the calculation that we have made inside the calculated field, right? So just click on apply and OK. And once you create a calculated field, it will be displayed right here under the measures pane with an equal to hash symbol. And this is the symbol for your calculated field, right? So now what I'm going to do is I'm going to bring this calculated field right next to the sales measures in my columns. Right, so now as you can see my total sales, when you place the tooltip somewhere over here, so this gives me the information about the Kerala state. The office sales is 2,400, of coffee sales is 1,300, and the total sales, it is just adding up the values of both the sales, right? But there's a small fault in this. When I say total sales, I should get the value of MP and Punjab as well over here. Now why is this being displayed as null? Okay, because whenever an integer value is added to null, null is being displayed. So we want to make a change in our calculation by which, though we have null values, just give me the actual values in case there are any during the summation process, right? So I'll just make a small change in the calculation, after which we will be getting the sales of MP and Punjab as well in our total sales. So that is what I want to happen when I say total sales. So I'll just remove this from my view now.
Just a quick info, guys. Intellipaat provides Tableau online training and certification course mentored by industry experts. The course link of which is given in the description below. Now, let's continue with the session.
So I'll just use the function called Zn. So this Zn is nothing but the zero null function. Okay, so when you have a null, okay, that will be converted into zero, and during the your summation process, if you have any actual values, it will display the actual value and it will not display the null. itself, right? So let's see now what happens. Okay, so we'll just see what happens and I'll come back and explain. Okay, so now we'll try and place this over here. Yes, so now as you can see, I'll just go into this again. Okay, so now as you can see, since my office sales had null values, I used the zero null function in my office sales measure during the calculation, because I wanted to change the null values of this particular measure as zero, so that during the summation process, the values of my other measure are actually being displayed. Okay, so this is the small change that I've made. I've added the zero null function. Okay, and as you can see, just when you place your tooltip over here, it tells you that this information is regarding the state of Punjab. There's no office sales being made, and the coffee sales is 880 and the total sales is 880 as well. So as you can see, the coffee sales for Punjab is 880. So this value is being displayed in your uh, you know uh, your total sales as well. And this null values over here, it corresponds to this place over here. Okay, it is just telling me on the whole, in my view, there are two null values, and it is talking about the null values right in my office sales. So please do not confuse that, since it is placed next to my total sales. These null values indicate that there are two null values in my office sales, right? So this is how you can use calculations when you are blending tables from two different data sources as well. Okay, and this calculation can either be in your primary data source, or if you want to create your calculation in a secondary data source, you can do that as well. There is no change that is going to be made, right? So we'll go into a primary data source where we have the calculation, and now I'll just try to swap it. Okay, we have a vertical bar chart over here, and now I'll just try to label them so that you'll have the idea of what are the values of each particular bar chart over here. So when I try to label them, if I label the total sales, okay, so all my bar charts over here will have the value of only the total sales. Now, why is this happening? I want the total sales to be labeled only over here. I want office sales to be labeled over here, and I want coffee sales value to be labeled over here. Now, how do we do that? As you can see, you have three different bar charts over here. So the first one corresponds to your coffee sales. Okay, the second one corresponds to your office sales, and the third one to your calculation total sales, right? So go into your coffee sales. So right now we are inside coffee sales bar chart. Now bring in your coffee sales inside label. So only your coffee sales are being given the actual label. Then go into the office sales bar chart. Okay, this is the type of chart, and it's my office sales. Go into your office sales data source, bring your office sales into label, right? So this gives the labeling of my office sales. And finally go into total sales, and then go back and bring in your calculation over here inside label. So I think the labeling is appropriate now. Okay, you'll have a better understanding, and once the user sees this chart, they'll have a clear view of what is being displayed in this particular chart, right? And you needn't go and have a look at your tooltip. All the necessary information is displayed right over here. Okay, so this is how you perform a calculation in data blending. Okay, so after this, we are moving on to a new topic about something called auto-generated fields. For that purpose, I'll just close this, and we'll come back. We can very well, just edit the data source. We can change data source inside Tableau itself, but just to, make things familiar, I'm just, repeatedly opening Tableau and connecting it so that you'll get used to, how it is being done. So you'll just get used to the environment. So that's why only after you drag a particular table or sheet in your canvas area, you can go into your sheet. Okay, else you will not be able to move into your sheet. Okay, so right now we are back to our sample superstore data source. Okay, and as you can see, we have under our dimensions and measures, we have a few fields which are not available in our data source and which are italic in text. Like you have the measure names, you have latitude, longitude, number of records, and measure values. So these five fields are known as the auto-generated fields. So this is something which is by default created when we connect our data to Tableau, right? If we do not have any geographical field which belongs to our data source, we will not have the latitude and longitude being visible over here, right? So now why do these fields are present over here, and what is the use of these fields, right? So we'll just see one by one. We'll start with the number of records, okay, which is placed under the measures pane. Okay, we have measure names inside dimensions, and we have all the other four inside measures. Okay, so first we'll start with number of records. So as you can see, it's a generated field that counts the number of rows. Okay, it's an auto generated field. So now what is the use of this number of records? So just bring this number of records and place it inside this text. So as you can see, it displays the total number of rows which are present inside this orders sheet. Okay, so it has the total number of records. As it tells you, it counts the number of rows present in this particular sheet, right? And with the help of this, you can just see how these number of fields or number of rows are being distributed. When I say that, what I mean is, let's say I'll have my market or region over here. Okay, I'll just bring my region in rows. So as you can see, my 9994, the total number of rows, are being distributed in this way among all the four regions that are available, right? Similarly, I can also have, let's say, ship mode when I bring it into my rows. So I have four different ship modes: my first class, same day, second class, standard class, four different ship modes, and the number of rows are being divided in this way, among this, against this particular dimension, right? So you can easily find out the total number of rows inside your table with the help of this number of records auto generated field, right? So, and if you want to, verify whether it is exactly showing you the total number of records by as it showed initially, the 9,994, you can very well try and verify that. Just go into analysis in your menu bar. Okay, click on totals and say show column grand totals. So as you can see, this was the same number as your as we had in our data source, right? Your orders table had those many number of rows. Yes, so this is one way by which you can use the total number of records. You can find out in what way your total records are being distributed. Let's say my category. Okay, so this is the way, and the grand total is also being displayed, right? So this is the use of the first auto-generated field, which is nothing but the number of records. Okay, and then we have something called measure names and measure values. So now what are these measure names and measure values? Okay, so these are not from your original data source, right? Tableau has created these automatically so that you can build certain types of views that involve multiple measures. So in case you have a view in which you want to compare the profit, sales, and quantity at the same time in a single view, you can use this measure values instead of choosing each measure from your measures pane. So this measure values will contain all the values of your measures. So as the name tells you, It contains all the values of your measures. Okay, and measure names is nothing but it will contain all the names of the measures. And why is it in a discrete, why is it under dimensions? Because it is of string type, so it is discrete in nature, and that is why the names of my measures, okay, my measures are nothing but discount, profit, quantity, and sales. Okay, all the names of my measures will be stored in my measure names, and all the values of my measures will be stored inside measure values. So I'll just show you that if I bring measure names in my filters, as you can see, these are the different measures which are, available right here, and number of records is my auto generated field, where latitude and longitude belong to a different data type, so that is not included. Okay, so if I want to include all these in a view, I can very well do that with the help of this single auto generated field over here, right? That's the purpose, basic purpose of why we have these two right here. Okay, so I'll just give you some examples. Okay, we'll try to bring it in a view, and let's see in what way the view can be changed with the help of these auto generated fields, right? So let's say we have date. We have a date field, okay, order date, which is of date data type. I'll bring this date field in my columns or rows, anything. Okay, and let me have my say any one measure, let's say sales. Okay, and as you can see, there's a line chart which is being created. Okay, so the automatic chart, when you have one date dimension and one measure, is the automatic, I mean the line chart is the automatic type of chart which will be created. We'll go through all the combinations over here and all the automatic charts that will be created with different combinations, right? So right now we have a date field, a date dimension, and a sales, which is a measure, and we have a basic line chart, right? So now what uh, will I do if I want to compare profit along with my sales? And I want, so now, right now, two line charts are being displayed, right? So now if I want both these to be displayed in a single chart, I want to compare both these lines in a single axis. How do I do that? Right? So, and I want to include discount as well. Okay, there are three different line charts, but I don't want this view. I want a single XY axis and all the three lines in the same view, in a single view, right? So now what do I do that? So instead of, bringing all these here, you can just bring your measure names inside your filter and say, I want only sales, profit, and discount. Okay, click on apply and okay. So right now I have filtered my measure names. I am including only sales, profit, and discount. Okay, so now when I bring my measure values in my rows, okay, there's some change that is being made. Okay, we don't have a proper line over here. This is because we have to go to a, yes, I'll just remove this. Okay, we'll have our measure values. Okay, we'll have our measure values right now inside filter. Okay, first I'll tell you how to create a combined chart with two measures, and then we'll go on to three measures, right? So first we'll go with two measures. So we have an option without using measure names and measure values, which is known as the dual axis. When we have two measures, you can use this dual axis option, right? See, as you can see, you have your sales this side, you have your profit this side, and you have your color legend. So you and you can see a structure change over here, right? You have your sales and your profit, and there's a vertical uh, structure change, which tells you that you have created a dual axis chart. Okay, both your lines are being visible in a single chart. So by this you can compare both these measures in a single way. right? So now how do we do this when we have three different?
Just a quick info, guys. Test your knowledge of Tableau by answering this question. Which of the following is not a trend line model? A. Linear trend line. B. Exponential trend line. C. Binomial trend line. D. Logarithmic trend line. Comment your answer in the comment section below. Subscribe to Intellipaat to know the right answer. Now, let's continue with the session.
Measures, right? We'll just see that. Okay, I'll just remove these two. Now, as we told, I'll go into my measure names. I'll select only my sales, my profit, and my discount. Okay, and I'll say apply and okay, right? Now I have my measure names inside my filter, right? And I have chosen only through three different measures. So now what I do is I bring my measure values in my rows. Okay, and now I would like to color it. So there's a chart, there's a mixture of all these three values. So I would like to color them up. I'll bring my measure names in color. Okay, so now as you can see, the lines are being separated. So there's different colors given for each measure. Okay, and if you want, you can also bring your measure names for a better understanding inside your label. So it tells me that you can very well identify the lines with the help of this color legend as well. If not, you can also label them. So this tells me that this is the line of sales. This is how my sales is being increased in these particular years, and this is how my profit is increased, and this is all about my discount. So just for an example purpose, how to include more than two measures. When you have two measures, you can go in for dual axis option. When you have more than three measures, or when you want to add, if you want, you can keep changing. You can edit the filter, you can include your quantity as well. Okay, and you'll have four different lines now, and there are different colors mentioned over here. So this is where your measure names and measure values are used basically, right? Okay, so after this measure names, measure values, and number of records, we have something new. We are going to see how to create something called a hierarchy, and how do we create folders, right? And before that, we'll just see how to manage metadata inside your sheet. You can also rename your fields inside your sheet. Okay, just as we did in our data source page, you can very well do that. Just you can either slowly double click this, or you can very well go into this and you can rename this particular field. Okay, you can do that. You can show and hide any fields with the help of this, just as we did in our data source sheet. Okay, and let's see how to create a hierarchy now. Okay, so now what is a hierarchy? So for example, if I have something called category, okay, and I would like to have all the information related to category in one place. So by this, searching for a particular information or a particular field, and navigation is very easy when we create hierarchies. When we have so many number of fields, when we have n number of fields where you have to go in search of every field. So when you create hierarchies, like all the fields related to customer, like customer ID, customer name, in a hierarchy. You can have your country, city, state, region, all these under one hierarchy. You can have your category, your product name, your subcategory, your product ID, all these under your products hierarchy. So you can very well do that. This is just for you. It just makes easy for navigation, and searching for any particular field is made easy. That's it. So that is why we generally create a hierarchy, and usage of this hierarchy in your view is also better and easier. Okay, let's just see that now. Right now we have category over here. Now, how do you create a hierarchy? You just click on this drop down arrow next to your field name. You can just say hierarchy, create hierarchy. Okay. Or you have one more option. just so whichever field you want to be placed in under this, just drag this subcategory and place it on top of category, and it tells you create a hierarchy, and by default the name of the hierarchy will be all the fields that are right now present in your hierarchy, right? So we can just give some random name, say category information. Okay, so I'll just say okay, and a hierarchy is created. This is the symbol for hierarchy, and I have my category and subcategory. Okay, and you can save your space under dimensions by creating hierarchies as well, right? So when you click on this, it just shows what are the different fields present under this particular hierarchy. Now, how do we use this inside the view? So just drag this hierarchy itself in your view, and as you can see, okay, I'll just place it in my rows, or let it be in columns, and I'll have my sales. So right now, as you can see, there's a plus symbol over here. This indicates that this particular dimension is a hierarchy. Okay, and when you click on this, you will get the next field which is being available in this particular hierarchy, right? So if I want, I can analyze the sales regarding the categories, and with one click, instead of searching subcategory and bringing it all into my view, I can just use this plus icon, and then I have the field which was in my hierarchy, right? If we had another field in this hierarchy, let's say if I have my let's say the product name, if I want it to be placed inside this hierarchy as well. Okay, as you can see, I can change the order. Okay, I want product name to be the last, so I can create such an hierarchy as well. So when I try and drag this hierarchy over here, I'll have these symbols. Okay, and you have different products names under each subcategory, as you can see over here, right? So yes, so this is where you can just again drill it up. Okay, and this is the basic way of how you create and how useful your hierarchy is in your view. Okay, and we have default hierarchies as well. Our date field over here, okay, is a default hierarchy. Let's see that. So when you place date over here, okay, and as you can see, we did not create a hierarchy, but I mean, but by default we have a plus symbol over here indicating that it is a hierarchy. So when you just click on this plus sign, you get the corresponding quarters for each particular year, and again when you click, you get the corresponding months under each quarter. Okay, and then again you'll have the days of each month under each quarter under each year, right? So this is the default hierarchy. The date field is by default as a hierarchy that we have in Tableau, right? So this is how you create a hierarchy. And similarly, you can remove your hierarchy just by clicking on this drop down arrow and say remove hierarchy, and your fields are placed back in their places, right? And so this is all about how to create a hierarchy. And then we have something called creating a folder. Okay, so now how do you create a folder? So now I would like to create a folder. Okay, yeah, just somewhere some blank space over here. Just say group by folder. Okay, and then go into, let's say, my city. Okay, I would like to create a folder. Okay, and you have, yes, you, after you have grouped by folder, you have to change this option, and only after that you will be able to view this create folder option over here, right? So somewhere some blank space over here, you just create a folder and you give a name for your folder. So right now I would like to create a folder with a name, say locations. So it will consist all the fields related to the locations, right? So I'll say okay, and now as you can see the folder symbol, your folder is created over here. But like your unlike your hierarchy, you could drag your hierarchy and place it in your view, but you cannot do that with your folder. You cannot drag your folder. It is just for the purpose of combining all the fields which give information of which gives similar information. Like as in I can also create a folder for category information. I can place my category, subcategory, and my product name, product ID, and so on inside my category folder. But one difference is that I cannot drag my folder right into my view. It is just to organize your fields into separate folders. Might be easier for navigation. In order to find out any particular field, you have to go into that folder, okay, and just find out. Now how do you place the necessary fields inside your folder, right? For example, we have our locations folder now. Now I want my country inside this folder, so just drag country, drop it into the locations folder. Drag city, drop it into the locations folder. Drag region or postal code, all the geographic roles we'll place into the locations folder. And we have state, okay, place it into your locations folder. So if I want any information regarding the location, okay, I'll just go into this folder and choose that particular field and drag it into my view. So the order in which the fields are placed doesn't matter, because we are not going to drag the entire location folder into the view, right? So this is just for you to easily identify or easily search for any particular field. So you can organize this as per your desire and requirement, right? So this is how you create a folder inside your dimensions pane, okay? And so we have just seen how to create a folder and how to create a hierarchy. Okay, so now next topic that we will be moving into is, I'll tell you the different marks. Okay, right? What are the different marks which are available? What are the automatic marks created when we have different combinations and so on, right? So and all about titles and captions, as we were discussing yesterday. Just double click on your title and you can keep changing your sheet name. If you have something like product category wise sales in your sheet, you can name it as you desire, or you can also insert your data source name over here. If you want to give extra information in your sheet title, you can keep adding all these information, right? And if you want to change the font as well, all these are general formatting options that are available. So this is how you can change your title, okay? And about the captions, you can just double click on your caption and you can edit your caption very well. Okay, so these are the two things which you can perform, which you can change in order to give some extra information regarding what analysis you have been made in your view, right? So now all about our marks card. Okay, so initially we have something called automatic. So without, I'll just remove my caption. Yeah, so by default, this T over here stands for text table. Okay, so right now it tells me text is the automatic chart, because we don't have anything in our rows and columns. So when we start with Tableau, the automatic will be a text table. So now as we keep on adding our dimensions and measures to our rows and columns, the automatic keeps changing accordingly. Okay, so automatic, it just chooses the best view or the best mark type, okay, for your data according to what you have placed in your rows and columns, right? So first we have for example, we have both dimensions inside our columns and rows. Okay, so when we have, let's say, our subcategory, okay, and we have, uh, let's say, category, okay, as you can see, and you can very well fill these places with sales, okay, for the different subcategories over here. Okay, you can have any combination, but the basic rule is that when you have two dimensions, when you have rows and columns both with dimensions, your automatic view will be a text table, right? So this is the first automatic view with this combination. So if you have both dimensions, any combinations of any two dimensions, you will be getting a text table by default, right? As you can see, there's automatic text mentioned over here. Okay, so this is the first combination. Next combination is that when you have, just now we saw when we have both dimensions over here, the automatic is a text table. Now what happens when we have both rows and columns with measures? Okay, so I have my sales and profit. Okay, so when you have both measures, okay, it's the shape mark which is being automatic in nature, right? So this shape tells you what it signifies, what it tells you about. Okay, so this is the second combination. So we have two dimensions, it will be a text table. When we have two measures, it will be a shape mark type, right? And the next automatic mark type is the bar chart. Now how do we create, when does Tableau create a bar chart? Okay, in what combination does it create a bar chart? So now when we just now discussed about two dimensions, two measures, and now let's see about one dimension and one measure. I have my subcategory, which is a dimension, and I'll have my sales, which is a measure. So right now, the automatic mark type is a bar chart. So when we have one dimension and one measure, this combination, it can be, anyway, you can swap it up. There's no necessary that your row should have measures and your column should have dimensions. You can have it, any way, but your automatic mark type will be the bar chart. Okay, so and next we have one more combination. So so far we've seen three combinations. The next one is we have date dimension, okay, and we have a measure. So when we have our date dimension as in one of our column or rows and one measure, so the line chart is the automatic mark type, right? So we just now went through two dimensions, two measures, one dimension, one measure, and one date dimension and one measure, right? So these are the automatic types, and you can very well change the path for a line chart over here. Okay, you have the line type, you have the step type, and you have the jump type. So these are the different path that you can choose when you have the line chart. Only when you have the line chart displayed in your view, you will have this path option right over here. Okay, and let's see about the different, all the other mark types as well. So we just went through the automatic text, bar, line, and shape. Okay, so now let's see how do you create an area mark type chart. Okay, area is nothing but it just shows the total values. Okay, it's just like a line chart, but the area below the line will be filled up with some color, right? That is an area chart. It shows how a particular dimension is contributing to the trend. Okay, and we'll just see how to do that. We'll have let's say a measure. Okay, and we'll have dimension. Let's say we have the date dimension. Okay, and as you can see, you can have your category in the color. Okay, and for each particular category you have been given a color, right? And this is the normal line chart. Now you have to change this into the area chart. Okay, so now if I go into area, so this is how you change it to an area mark. So the line below each, every line corresponds to the category wise sales. Okay, so and you have the area which is being filled with color below each line. So this is how an area mark looks like, right? So this is also with the same combination, but area is not an automatic mark. We have to manually go choose it, right? So this is all about the area mark, and we have the square mark. So when do we use, see, we have the square mark over here. So now when do we use this square mark? So it is generally used like when you want to show individual data points. Okay, your data is displayed using squares. Let's just see an example. To use a square type, a square mark, you should have both dimensions in your rows and columns, but one should be a date dimension, okay, and the next should be, let's say, a category, okay, and by default, a text will be shown because as we discussed earlier, you have two dimensions for which the automatic mark is text, okay. So now when you try to place a measure inside, let's say profit, okay, I'm placing my profit inside my measure, okay, and it is converted into a square mark. So like each square gives me the information about the profit for each category under each year, and you have the color legend. So as the color keeps getting darker, okay, your corresponding profit information is being displayed with the help of the color, okay, and this is also known as a heat map, right? And the next mark that we have is the circle mark, okay, so it displays using filled circles. So as you can see, we have the circle mark over here, okay, and let's see if I have two measures. So we just now discussed when we have two measures, it will be a shape. The automatic mark will be shape, okay, and it will be an open circle. So if I change it to a circle mark, it will be a filled circle. So that is the change that we have between the shapes and the circle mark. So when I place, let's say I have my product name in details. So as you can see, for each product name, one filled circle is being displayed, right? And it gives the necessary profit information and sales information for each circle. Okay, so this is about the circle mark, and we'll again have the shape marks. Okay, we have different shapes that we can assign, right? We have two measures and we have the shape mark. Okay, so when you want to clearly see the individual data points, and also while viewing your categories associated with these points, you can make use of the shape mark. So the default shape is an open circle. Okay, I'll have the, let's have the subcategory in detail. Okay, by default you have the circle as the default shape. So if I want different shapes for each subcategory, okay, I'll have my category. We have only three categories, right? So if I want to give three different shapes for each category, all I can do is I'll go into this shape, okay, and I'll say more shapes, and I can assign a palette, okay. So let's say you have so many different options available, okay. If this is the default, okay, I'll assign the palette and apply. Let's see if my each, yeah, so by assigning my category into shape as well, my each category will take up a shape, okay. You can change the shapes with these options, okay. You can change the shape for office supplies into any different shape as you wish, right? Yes, so this is how, if you are placing a dimension inside my shapes mark, okay, each member of the dimension will be given a unique shape. If you do not have those many shapes, for example, we have customer names, we have so many number of customer names, but we do not have sufficient shapes. So during that point of time, the shapes will be repeated. And in such cases, use shape mark is not recommended, because your shapes will be repeated, right? So that doesn't give you appropriate information. So when you have limited number of members in any particular dimension, like category or subcategory or ship mode or segment, you can go on with this shapes mark, right? So these are the basic combinations, okay, and the basic charts which we will be using in our examples, okay.
Just a quick info, guys. Test your knowledge of Tableau by answering this question. What are the components of a dashboard? A. Horizontal. B. Vertical. C. Image extract. D. All of the above. Comment your answer in the comment section below. Subscribe to Intellipaat to know the right answer. Now, let's continue with the session.
So in Tableau, you can sort your data either in ascending or descending order by any of these three options. That is based on data source order. By default, when you are loading the data from any of your data sources, it would be arranged in the data source order. So you can change it later through alphabetical order, or even based on the order of the data based on the associated values of another fields. That is, in Tableau, we have two types of sorting. So you can sort your data either based on computed sorting, or you can go for manual sorting. Computed sorting is the sort which is directly applied on the axis using a sort dialog button, and manual sorting is used to rearrange the order of dimension fields by dragging them next to each other in an ad hoc fashion. That is, when you go for a computed sorting, you choose the sorting based on the corresponding fields and the aggregation methods. If you go for the manual sorting, you have the up and down arrows where you can sort the values based on your own requirements. Let's go for a live demo to see how sorting can be applied on Tableau. So I'm connecting to sample superstore dataset. So here I'm going to take the customer name and sales. The default option, as I told you, by default it is sorted in data source order or the alphabetical order. So you can change the sorting either ascending or descending based upon the measure value which is referred on the view. So here on the measure axis you have a small sort symbol. So you can click on the sort symbol to sort your graph either ascending or descending. You also have the same sorting option to sort it ascending order or descending order in your toolbars as well. So here also you can use your sort option to sort your data in descending or in ascending order. So these are the default sorting methods where you can sort your data either ascending or in descending order. As I said, if you want to sort your view based on computed sorting method, click on the dimensions, go for sort dialog box, click on the sort option. So this is the sort dialog box where you have the sort order. Either you can choose ascending or descending. You can, by default, as I said, it is sorted by data source order. If you want to change it to alphabetic, change it to alphabetic, or go by field option. So in this you can choose the various fields as well as aggregation. For example, if here I am showing the sales of each customer on my bar graph. If I want to sort this graph based on profit, that is average of profit, I choose profit and aggregation average. Now I am sorting the graph in descending order based on average of profit. Now my graph is sorted based on average of profit even though I show customer sales on my view. So this method is called as computed sorting. The next type of sorting available in Tableau is manual sorting. For example, if I choose the order date and profit, if I want to manually sort this year of order date, then I go for sort option. I go for a manual sort and I choose what needs to be on the top and what needs to be on the down. So this order is based on my own requirements. I manually sort my values. So this is referred as manual sorting. In case if you have multiple dimensions, for example, category, subcategory. Here I have two dimensions, category, subcategory and profit. So when you have multiple dimensions, you would be able to sort your graph based on individual panes. That is, each individual category has some subcategory of products. This is referred as panes. So I can sort my pane individually by clicking on particular value. I have the sorting option. So either you can go for sorting by ascending order or you choose descending order. You can also choose different sorting order based on different values in the pane. So this can be used when you use multiple dimensions. So these are the sorting methods available in Tableau. That is, you can sort your graph based on computed sorting, manual sorting, as well as you can also go for, when you have two dimensions, you can sort it based on individual panes as well.
So we'll start with filters. Okay, now what are filters? Okay, as you can see, you have a filter shelf which is available over here, and we had already discussed a little about how our dimensions and measures work inside filters, right? So what is the use of these filters? Why do we need them, right? It just narrows the data shown in your view, okay, so that you can focus only on the relevant information as per your requirement. For example, I might have different ship modes, okay, but I would like to retrieve the information of only the first class ship mode, or only same day ship mode, or anything of your choice. So during such cases, instead of going through all the ship modes, I can just try and choose one particular ship mode. I can filter out the others and, focus on only the relevant information. Okay, and this shelf over here, it also allows you whether you need your data that you have mentioned in your filter to be excluded or included, right? I have placed my ship mode inside filter. Okay, in case I want the information only regarding first class, I can check this box. Or if I want information of all the other ship modes excluding first class, I can either check the other three boxes. Okay, this is one way. Or an easier method is I'll check the first class, which I don't want to include in my view, and I'll go click this exclude button over here. So now, as you can see, the first class has been striked out, which means I am excluding the information, the member which has been checked, whose box has been checked. So now I will be getting the information of all the other ship modes. So this filter shelf allows me to either exclude or include data in my view. Okay, and whenever you try to filter a field, you can choose any filter or any measure, any dimension on any measure into your filter shelf. And if you have applied a filter to any particular dimension on measure, that field will be displayed inside this shelf over here. For example, I have my category. I'm just dragging it and placing it into my filter shelf. I want information only about furniture and technology. Apply and OK. Now my category is placed inside the filter. So with this, I can identify that my category dimension, there's some filter being applied in this particular dimension. Okay, and we have a particular order in which the filtering is executed. Okay, we have 5 different types of filters. We have extract, filters, we have data source filters, we have context filter, we have dimension filter, and we have measure filter. Okay, so what is an extract filter? As the name tells you, it filters the extracted data from the data source, right? So, and similarly, what is a data source filter? Data source filter, the filter will be applied right into your data source before you get the information, the data from your data source itself. Okay, so that is all about the data source filters.
Just a quick info, guys. Intellipaat provides Tableau online training and certification course mentored by industry experts. The course link of which is given in the description below. Now, let's continue with the session.
Measures filter. So now what does this context filter, what is it all about? So sometimes there might be a scenario where you have two dimension filters or two measure filters or any two filters of the same type, right? So I'll have my category being filtered. I want only technology information. And similarly, I'll have my ship mode also inside my filter. I'll need only my first class and second class. Okay. So when you have, more than two, more than one, two, or three different types of filters inside your filter shelf. Now, how does this get executed? So we have the order of execution, okay, or the order of operations in which filter is being executed. So first, the extract filter will be executed. Any filter that you have applied to your extract will be executed. Then any filter that you have been applied to your data source will be executed. Then we have something called context filter, and then the dimension filter, and then finally we have the measure filter. But in this case, we have two dimension filter. So now which dimension filter will be executed first, right? Tableau will get confused and it will provide a completely different view which we do not expect, right? Because I want the category to be filtered first, and then under this technology category that I have included in my view, I want the ship mode to be filtered. But Tableau considers both these filters as the dimension filters itself. The order in which your filters are visible, the order in which your dimensions are visible in this shelf does not play a role. Like what I'm trying to say is, since I have my category on top and then I have my ship mode, it doesn't mean that category filter will be executed first and after which ship mode filter will be executed. Tableau considers both as dimension filters and they will be executed at the same time. Now, in order to solve this problem, okay, in order to solve this confusion, we will assign one dimension filter as the context filter. So by doing that, we are telling, according to the order of operations, the dimension filter will be executed only after the context filter. So in this example, I will change my, dimension filter. I'll say add to context. By doing this, okay, there's a color change, which means this is my context filter. This will be executed first, and then my ship mode, which is my dimension filter, will be executed. So these are the order of operations, and this is what we can do when we have a problem. When we have two similar type of filters, we can try using this option in order to avoid confusion, right? And these are the different types of filters, and we'll just see how to use filters, okay, and all about these extract, data source filters, context, dimension, and measure. Now I'll just tell you what is all about internal and external filters. Okay, so if I have, say, my segment in my filter, right? I have three different segments. I want only home, office, and consumer to be filtered. I'm not excluding it, I'm including home office and consumer. Okay, I'll click apply and okay. Now I am going to bring my segment in my columns, okay, and I'll bring my profit inside rows. So as you can see, it has been filtered. The segment, my corporate segment, is not being visible over here. Okay, so we have removed one segment type from the view by filtering segment dimension. Okay, and you can also try to show the filter. You can show this filter, and by this you have created an intent filter. The user themselves can change the filtering options. Okay, so you can either create a filter for any dimension by dragging it inside the filter shelf, okay, or else you can also choose this drop down option over here, and you can say, you can there'll be an option. Since I have already filtered, you can choose the filter option from this drop down box, or it is always better you just drag it into your filters shelf. Okay, and so now we have segment inside our view. Inside our view, in the sense, segment is a dimension which is placed in either the row and column, and we are filtering the view in terms of a dimension which is already present in our view. So this is known as an internal filter, right? So when your dimension or measure is a part of the view itself, okay, it is known as an internal filter. Now, what do you mean by external filter? Okay, so if I want, I'll just remove this. Okay, so now I have my segment and profit, no filters, right? So now if I want to see the profit for any one particular category of products, okay, though my category is not a part of the view, so right now I have only my segment and profit in my view. Okay, I'll just drag my category into filter shelf. I'll say only technology or only furniture, any one option, and I'll apply. There's a change in the bar chart over here. Okay, so my chart has been changed according to the filter that I have applied. It's a category filter, it's a dimension filter, but my category is a dimension which is not present inside the view, right? Though it is not present inside the view, I have used it to filter the information which is being displayed in the view. Now this is known as an external filter. So when you have your dimension in your view and you're trying to filter that dimension, it becomes an internal filter. And when you try to filter out the information in your view with a dimension which does not belong to your view itself, it becomes your external filter, right? So this is all about your internal and external filter. And I'll just tell you about the tabs. So I'll have my subcategory inside filters. So now as you can see, we have 4 different tabs. We have the general tab, we have wildcard, we have condition and top. Okay, so general is nothing but you have 3 options. You have to select from a particular list. You have the list of all the subcategories in this dimension. You can keep choosing from the list. You can enter particular subcategory name in order to search it, or you can select all the values or select none of the values with these options. Similarly, you have custom value list. You can manually type in your the subcategories to be filtered out or included or exclude from the filter. Okay, you can manually type in the subcategories over here, and use all will automatically use all the subcategories present inside the filter option. I mean, if present inside this particular field. Okay, so this is all about your general tab, and you have a summary of what are the filters, the filter options that you've been used so far. So the field name, you have selected 0 of 17 values, and it keeps changing as you keep selecting. Okay, and this is about the general tab. Okay, and your wildcard tab. Your wildcard tab is nothing but you can filter using these 4 options mentioned over here, right? So for example, I have subcategories containing, let's say, A, B, L, E. So this is something that my subcategories contain, right? So if any of my subcategory name contains this four alphabets over here, okay, this particular text over here, this string, if any of my subcategory contains these strings, it will be displayed in my view. Let's just try that. Click on apply and okay. So right now we'll just clear the sheet. Okay, I'll have my subcategory. Okay, yes, I'll again bring it to my filters. I'll go into wildcard and I'll say this is the text, apply and okay. Now when I bring my subcategory in my view, okay, so tables is the only subcategory with a string that I had mentioned. So when I remove this filter, I have all these subcategories. Okay, let's try one more. I'll say if my has A and B together, so that text together, what happens? I'll go into wildcard tab, I'll say A, B, apply and okay. Now we have only labels and tables, okay, which had A and B string. So with it, you can also filter out the information using these options as well, right? And similarly, we have something called starts with. So whichever alphabet you want the subcategories to be displayed, which starts with any particular alphabet, let's say, okay, starts with A, apply and okay. And as you can see, all the subcategories starting with A is displayed. Similarly, you have something called ends with, let's say, S, apply and okay. All the subcategories which ends with S, are displayed over here. And similarly, the last one that we have is exactly matches. So now I should type in category, a subcategory name which exactly matches. If I say table, apply and okay, there's nothing that is going to be displayed because it should exactly match my subcategory name. So when I say tables, so this is when this particular subcategory will be displayed. Okay, this is all about your wildcard tab, right? So, and we have something called the condition tab. So by field, so this I can assign a condition by which my filter is to be performed, right? I can choose any particular field, let's say by sales, and aggregation can be chosen from these options, okay? And your sales, you can just use this load option over here to load in the minimum and maximum values of my sales, of my sum of sales, right? So with the help of these minimum and maximum values, you will have an idea, as in please filter out or please display only those sales which are greater than, let's say, around 50,000. So with the help of this minimum and maximum value, this just gives me the range of values of my sum of sales for me to decide on what value I can mention over here in order to filter it out. Okay. So now this is just the same. If I say by formula, I will be typing in the exact formula, sum of sales greater than 50,000 inside this formula box. So both works the same way, right? And we have something called the top tab. So if I want to filter out the data, let's say I want to see the top 10 sales by sum of sales, okay? And I'll say apply. Okay, I should choose this. Okay, none over here. And I'll go to my top and I'll say top 10 by sum of sales. Okay, just apply and okay. So right now I have my subcategory. I should just apply a filter top 10 by, I'll have my sales. Okay, so as you can see, first I'll sort it out, and I want to display only the top 10, or let's say only the top 5. Now how do I do that? I'll bring my subcategory inside filters, go to top, by field, top 10 by the sum of sales. So just click on apply and OK. You will be displayed only the top 10 sales. That is why I sorted out in a descending order. So only the top 10 by the sum of sales measure will be displayed in your view, right? You can also try and change this. You can also say as bottom 10. So the least uh, 10 subcategories by sum of sales will be displayed, right? So this is how you try to filter out using the different tabs available in the filter shelf, or the filter dialog box, right? We'll be starting with calculations and expressions. We will look into what are LOD expressions, and we'll also discuss about groups. We'll go into our workbook, okay? And we just went through how to create a calculated field and how you can just go through the list of inbuilt calculations and functions that are available in Tableau with the corresponding syntax, with an explanation of what it does, and with an appropriate example, right? So today we'll see what are the different table calculations, and we have something called quick table calculations. How can a quick table calculation be quickly applied to our table, right? So for that, let me just create a text table first, right? Now let's have our order date in terms of years in our column, okay? Next, we'll have our order date, okay, in our rows as well. But this time I'll just click on this drop down arrow and I'll choose the discrete quarters of order date. And then when I drill down, now this is the table that we have tried to visualize. We have the different years that we have in the order date dimension. And we also have the different quarters and the corresponding months under each quarter, right? Now let me just expand this a little bit, and you can also format it. We shall increase the font, right? Yes. And then we shall place the value of sales in the text part, right? So now this is a simple table that we have visualized. Now let's try applying the table calculations one by one on this table, and let's see what are the different ways of computing, what are the various options available in the edit table calculation dialog box, right? So when you click on this drop down arrow right next to your measure, right in the pill of your measure, okay, you have this option called quick table calculation. Now you can apply quick table calculations only on measures, okay? Just click on this drop down arrow and you have this option called quick table calculation, and this is the list of the quick table calculations. They are nothing but table calculations which can be quickly applied to your table, right? So that is why we call it as a quick table calculation. Now let me say I would like to find the running total of sales, okay? And this is how the running total of sales is calculated, right? So when you look into the values, we have January 2015, and when it comes to February, we have the value of January that is summed up with February, and the sum of both is placed, I'm sorry, not of February. This is done in a horizontal manner, right? Which means it moves from January 2015 to January 2016 to January 2017. And finally, the sum of all the 4 Januaries is placed in this last column, first row of last column, which is nothing but January 2018, right? And similarly for February, we have 4,000, which is summed up with the value of February 2016, and the sum of both the Februaries, which belongs to 2015 and 16, is placed over here. And then it moves ahead, and the final value, which is the sum of February 2015, 16, 17 plus 18, is placed in the second row of the last column, right? So this is one way. This is the horizontal way in which your running total is calculated. Now you can change the way your calculation is getting computed, right? Or the direction in which your calculation is getting computed, right? Now when you click on this drop down arrow, you have an option, you have a a separate option which appears now, and this is known as the compute using, right? Now basically table calculations are defined by how they are partitioned or grouped and how they are addressed. Addressed is nothing but how they are computed or in which direction they are computed, right? Now when you click, now by default it is computed in a horizontal manner. Okay, table across the table the calculation is computed, and this is the by default way of your calculation by which it gets computed. Okay, when I click on table down way of computing, okay, now there's a vertical manner from top to bottom in which the calculation gets computed or the running total is calculated, right? So for the year of 2015 we have January value, we have February value summed up with January value that is placed over here. Then we have the first 3 months sales value which is placed in this March, and so on. This goes on till December 2015, right? So every column, you can just verify this, click on analysis, you can go into totals and say show column grand totals, right? So that you will be able to clearly verify that table down, computing any calculation or for example running total calculation in a table down manner is equal to the grand column total that we have calculated and displayed in our worksheet, right? So this is table down way of computing. Let's try the table across. Okay, now when it comes to the table across way of computing, when you try to display the row grand total, you'll be able to see how the row grand total matches up with the last column values over here, because the running total is calculated in a horizontal manner across every row, right? So that is why we just verified it with the column grand total and the row grand total, right? You can just remove them. And I also have, now let me just tell you about the next way of computing. Now it was table across, which moves in a horizontal manner from left to right across the table, right? Then we have the table down way of computing. It moves from top to bottom in a vertical manner, okay? And then we have table across, then down. Now this is table across. First it moves in a horizontal manner, then it moves to the first column of the next row, and again it moves in a horizontal manner, right? So I have a simple diagram for this with which you'll be able to understand. Yes, table across is nothing but it is just in a horizontal manner from left to right. Okay, table down is in a vertical manner from top to bottom. Then we have table across, then down, which means it moves in a table across manner, then moves on to the first column of the next row, and then moves again in a horizontal manner across the table, and then goes down to the next row of the first column, right? And this goes on, and the final value is placed in this last row of the last column, which means in our example, the final value is placed in December 2018. So the summation of all the values that we have in our data set for all the different months and all the different years, this is the final sales value that is placed right here in the last row of the last column, right? This is computing using table across, then down. And similarly, we have table down, then across, right? Now this might look meaningful because it moves in a vertical manner from top to bottom, and it carries on this summed value of the first year to the starting of the next year, and this goes on, and the final summation of the entire values in this table is placed in the last row of the last column, which is nothing but December 2018. And when you look into this diagram, this is how table down then across way of computing is carried out. It moves in a vertical manner from top to bottom first, which is table down. Then it moves across to the first row of the next column, right? And then again it moves in a downward direction, and this goes on till it finally reaches the last row of the last column, which will contain the sum of the entire values of whatever is present in this table. right? Where we will use this. Yeah, when you need to calculate the sales or profit that your organization has done, might be you would like to compare what is the total sales done in every year. When it comes to when you have 4 different years, you can just try calculating. You can either show the column grand total. Yes, definitely. Both results are the same in the sense table across, then down, table down, then across, right? I think you're talking about these two. Okay, now when it comes to table across, then down, the way the final value might be the same, right? But the way you're calculating differs, right? Now in this way of computing, which is table across, then down, so you can simply compare of how it moves in a horizontal manner, right? So month by month you can keep calculating, and you can also apply a secondary calculation on this, right? So we'll look into that. And when you look into table down then across, you can clearly understand what is the total value of sales at the end of the first year and what has happened at the end of the second year. So far for these 2 years, what is the total value of sales, and so on. You can just totally depends on your requirement. Though both the final values of both these way of computing the calculation is the same, the method and the way it gets calculated is completely different, right? So yes, it all depends upon your requirement. If you have any such requirement in your real-time scenario, then you just have this option that you can go ahead, right? So this was about the first 4 ways of computing, right? And just like these, we have pane down, pane across, then down, pane down, then across. Now, what is a pane? Pane is nothing but the sub partition that we have. Okay, this is the quarter 1, this is quarter 2, quarter 3, and quarter 4. Now, this is, we have computed it using pane down, which means the value of the first 3 months of quarter 1, the summation of quarter 1 of 2015 is placed over here. The summation of all the sales value of 2016 of quarter 1 is placed over here, right? So this is something like a subtotal that we have when you compute it using the pane down option. And then we have pane across, then down. Now across, then down, this is again, it moves first in a horizontal manner, moves to the first column of the next row, and this way of computing is done till the end of the first pane, right? So till the end of quarter 1, which is March of 2018, we have this running total which is carried on, and after which it freshly starts from the April month of next quarter of 2015, right? So this is, you're computing it for every pane, for every quarter. You are simply computing it either pane down then across or pane across then down, right? And this was the way of computing, and you can just look into these diagrams. I'll be sharing this file as well. Okay, now let's try applying the next, and you can clear your table calculation with just one click. Okay, you have an option called clear table calculation. Only when you have already applied any quick table calculation, you will have the option to clear the table calculation, right? And next comes difference. This is how the difference between two values get calculated. Now, why is the first column completely left blank, right? Now, whenever you would like to calculate a difference, you need two numbers, right? Only then you will be able to calculate a difference between these two numbers. So when it comes to difference, we have an extra option over here called relative to, right? And by default, relative to is previous, and by default, compute using is table across, right?
Just a quick info, guys. Test your knowledge of Tableau by answering this question. Which of the following is not a trend line model? A. Linear trend line. B. Exponential trend line. C. Binomial trend line. D. Logarithmic trend line. Comment your answer in the comment section below. Subscribe to Intellipaat to know the right answer. Now, let's continue with the session.
Calculate the difference from, and that is why it is left blank. And then when you look into the next year of 2016, a difference has been calculated between 2016 and 15, and the result is placed in this column, in the second column under 2016, right? So this is how your difference is getting calculated relative to the previous value. Whatever previous value is present in front of it, according to that, your difference is getting calculated. Now, what if we say relative to next value, right? Now, 2015 has a next value. So yes, a difference is calculated and placed in the first column, and this goes on. But when you look into the year 2018, you do not have the next year from which the difference can be calculated, right? So that is why 2018 is completely left blank, okay? And next comes the first and last, right? Now, when I click on first, so we do not have a blank first column. We have the first column, which is completely filled with 0, right? This is because we are calculating the difference from the first value, right? So which means first value, the difference between the first value and the first value is 0. The difference between the second value and the first value is so and so, right? So every column is compared, is using the first column in order to calculate the difference, right? And similarly, when I say relative to the last column, we will have the last column, which is left, displayed as 0, because last column subtracted with the last column is again 0, right? So these are a few ways by which you can calculate the difference between any two numbers, okay? And you can change how, in what manner or between which numbers you are calculating the difference from, right? And with one click over here called clear table calculation, you can simply clear whatever calculation you had applied onto your table, right? And then comes the percent difference. Now this is very similar to difference. Now the only change is that your difference will be represented in a percentage format, right? So that's the small change when it comes to percentage difference, and you again have relative to options that you can choose from, right? Next we have percent of total, right? Now when I say percent of total and it is computed using table across, which is the default manner of computing your calculations, right? So when I say percent of total, so out of a total of 100%, okay, what is the contribution of this particular year which belongs to, or this particular month which belongs to 2015, 16, 17 or 18, right? Now let's try, I'll just change the way it is getting computed, right? Now when I try to show the column grand total, you'll be able to see we have, when you sum up all these values, you will arrive at a total of 100%, which means out of my total, which is 100%, what is the contribution of each month in every year, right? So by doing this, I'll be clearly able to see that in the year 2015, it is September month which has done the highest or contributed highest towards the total value of sales. And similarly, when it comes to 2016, we have the month of November, which has contributed the highest value or the highest amount of sales when you look into the total sales, right? So this is just the percentage, the contribution of this particular month out of 100%, right? So which means when you simply sum up all these values, you will arrive at a total of 100%, right? So this is how you make use of the percent of total calculation, right? Then we have rank, okay, just with a few rows and a few columns, and we have 5 different functions under rank. We have rank, rank modified, rank unique, rank dense, rank percentile, and the simple rank. So we'll just go through rank right after we complete the remaining options that we have, that you can apply, that you can make use of in while using your table calculations, right? Then we have percentile, right? Now when you say percentile, now it is computed using a table across option, right? So it is in a horizontal manner. The least is given 0%, the highest is given 100%, and in between values are given equal percentages according to their contribution to the total value of sales, right? Now let me just change the way it is getting computed. Let's go ahead with table down. Now when you look into this, when you sum up the entire rows of my first column, you will not arrive at a total of 100%, because this is the percentile calculation, which means the highest of all is given 100%, the least of all is given 0%, and all the others out of 100%, whatever is the contribution of each month is clearly specified in this as a result of this calculation, right? So every single month is calculated as of what is its contribution out of the total, out of 100%, right? So this is not something like the percent of total. There's a small change between percent of total and percentile calculation that you can make use in Tableau, right? Now, next we have our moving average. Now, when it comes to moving average, we have two different types of moving average. We have the simple moving average and we have exponential moving average. And simple moving average, I'll create a separate table for that, and I'll explain what is moving average all about. And when it comes to exponential moving average, that is the inbuilt forecasting tool that we have. Yes, I think you're asking about the forecasting. Can we predict quarter 4 based on 3/4 percentile? 3/4 percentile. Now, prediction, it comes under, I think you're talking about forecasting. Yes, definitely we can forecast values, but you should have enough historical data, okay, in order to forecast values. So yes, we'll be looking into detail about forecasting as well. So yes, definitely. And as of your question for now, yes, you can definitely predict your quarter wise, your month wise, or your day wise values of, you can predict day wise in any terms, year wise. It totally depends on what amount of data you have with which prediction can be done, right? So we have a few basic criteria for that. Yes, we look into that in detail when we move into that topic of forecast analysis. Okay, so now as of now, this is yeah, and then comes the moving average. Okay, now we have a few calculations involved under moving average. We'll go through that in detail as well right now. Okay, then we have year to date total, right? Which means if you have till date, a data set which contains till date information, you can simply make use of this year to date total, and you can calculate the compound growth rate or year over growth. I mean, year over year growth, how your growth has been throughout these years, or again, your year to date growth will be calculated when you have a data which contains information or data till this particular date, right? Till date, the current date, right? So these are some of the calculations that you can quickly apply to your table. That is why they are placed under quick table calculations. And we also have, when you apply any quick table calculation, you have an option called edit table calculation over here with the delta symbol, right? Now let me just clear the table calculation, and I'll also remove the column grand total, right? So now when you click, let's say I'm going to make use of the running total. Now, as you notice, right next to your measure, you have a delta symbol or a triangle symbol, which indicates that this is a measure on which you have applied some kind of table calculation, right? So that is why your sum of sales is has a small delta symbol right next to it, indicating that you have already applied some calculation on this measure, right? And after applying a calculation, you'll be able to view this edit table calculation. Now, this is the dialog box which appears. We have, you can simply decide what calculation you are going to make use of. Okay, what is the aggregation you are going to choose in order to calculate the calculation, and the ways of computing. You can choose the way of computing using these options itself. Okay, and when it comes to specific dimensions, now this is something like, I hope you remember we had something called selected, or we had targeted highlighting, right? You can select fields with only with which you would like the highlighting to be visualized in your data, right? This is something like that we have specific dimensions. As of now, year of order date has been the checkbox of year of order date has been clicked, which means it is the addressing field. Okay, addressing field is nothing but the direction in which it moves, right? So this is moving across the years. So we have year of order date as the addressing field, and we have month and or quarter as the partitioning field, right? So it just partitions the calculation using month and quarter. Okay, or you can also have your month and quarter as the addressing field, which means it will move in a downward direction. Okay, when these are chosen as the addressing field, and you'll have the unchecked box which acts as your partitioning field. So your calculation goes in this way, and there's a partition. You can just imagine there's an imaginary partition between every year, every column, and that is why year of order date is considered to be the partitioning field when you choose the options in this way. So the boxes which are checked, they act as addressing fields, just the direction in which they move, in which the calculation moves, and the unchecked box act as your partitioning field, right? And we have this option called restarting every. You can restart every month, okay? Or when you have, let's say this, you will not have your restarting option because we have only the month and quarter as our partitioning fields, right? So there's no point. You do not have an option to restart every month or every quarter, right? So this is one option that you have. You can just decide upon them. These are different ways by which you can calculate your let's say your values of sales or profit or any such values, right? These are the different options that you can make use of, and that again purely depends upon your requirement, right? So this was about partitioning and addressing fields, and we also have, you can sort them out. Okay, let me just create another sheet. Now let's have the different subcategories. Let's have the different categories, and then let's have the corresponding sales, right? Now let me apply a quick table calculation, let's say of running total on this table. Okay, and it is computed using table down. Okay, and now let's try going into the edit table calculation dialog box. Okay, now when you click on specific dimensions, you can simply decide whether you would like to, in this we do not have any partitioning field, right? Because we do not have anything in our column shelf, right? So this is, as I told you, it depends on what and how you have visualized, you have created your table, right? And then I just wanted to tell you about this. When I say sort order in terms of specific dimensions, you can just customize it. You can have it arrange your sum of sales, okay, in either the descending order or an ascending order, right? So it just starts from the least value of sales, and then it goes on to the highest value, where we have phones is the subcategory which has the highest value of sales, right? So the running total is calculated in an ascending manner, okay, which means from the lowest value of sales to the highest value of sales. And when you say descending, it will start from the value of sales of phones and it ends at here, right? So I think it is fasteners where it ends, okay? And when you click on ascending, I think it starts from fasteners, right? So yes, I think I said art. No, it is the fasteners subcategory which has the least value of sales. So it starts from this, else you can just sort it out in your descending order, right? So this is again up to you, whichever order you would like to go ahead with, right? And then we have adding a secondary calculation, right? Now we'll go back to our sheet number 1. Now let's apply. So we have applied a running total calculation, and it is computing using table across, right? Now when I go into the edit table calculation dialog box, you have an option called add secondary calculation, which means on top of the result of my calculation that I've already applied to the table, On top of this, I will add another calculation, right? Now, if I say add a secondary calculation, we'll again get another dialog box which says secondary calculation type. Now, these are the only options. These are the only type of calculations that you can apply as a secondary calculation when your primary calculation is running total, right? So out of the running total values that I've calculated, calculate the difference from, okay, and it is relative to the previous value, right? So this is what you are applying, one calculation on top of the other, and where your first calculation becomes your primary calculation and your second calculation becomes your secondary calculation, the one that you're applying on top of the result of your first calculation, right?
Just a quick info, guys. Intellipaat provides Tableau online training and certification course mentored by industry experts. The course link of which is given in the description below. Now, let's continue with the session.
Okay, and now let's just go into moving average and I'll let you know. For that, I'm just going to filter out the date dimension, okay, so that I can explain the moving average with the most simplest set of data that we have, right? Now I'm just going to, let's say I'll bring my order date and I'm going to filter out, so that instead of getting the data of the 4 different years, I would like only 2015 years data. And again, I'll bring my year of order date, and this time it is going to be in terms of months, because I'm interested only about the month of January, right? Now, by doing this, when you bring in order date into your view, you will have only 2000 year data, only Q1 data, out of which only the month of January related data will be displayed. And these are the different days that we have in the month of January. Now you might see the days of the month of January starts from 3rd of January. We do not have 1st or 2nd, and we have 3rd, 4th, 5th, 6th, 7th, and we do not have 8th, right? And we have quite a few numbers or dates that are missing. Now this is because this is what you have been provided in your data set, right? So as a Tableau developer, you are just working with whatever data has been provided to you, right? So we basically are not concerned about the missing dates or missing data, okay? There might be, it might be a holiday for the superstore, or it might have been, there's no order that has been made on that particular date, right? So there might be n number of reasons for that, but basically we do not have entries for these dates in our data set, and that is why we are just continuing with whatever data we have that we have been provided with, right? So that is why it starts somewhere from 3rd January, because we do not have entries, we do not have data for 1st or 2nd January, or any missing date that we have in our data set. Okay, so now I'll bring the value of sales and I'll place it in the text part, right? Now this is the month of January of the year 2015 and the corresponding days value of sales, right? Now let's try applying the moving average calculation. Okay, now this is the simple moving average that we are going to discuss about. An exponential moving average, as I told you, we'll discuss in detail when we are forecasting with the data that we have, right? Exponential moving average is the calculation behind forecasting in Tableau. Okay, now let's try applying the simple moving average calculation on our measure called sum of sales, right? And for that, I am just going to create a duplicate of my sales, okay? And I'm going to bring this into my visualization, right? So now I have sales, copy and sales. So on my sales copy measure, I'm going to apply the quick table calculation of moving average. This is just to show you what is my actual value of sales, right? And from which the moving average has been calculated, what are the values of moving average, right? Just to compare between the actual value of sales and the moving average of sales, right? Now we'll go into the edit table calculation dialog box, and we have a few options. Okay, now this is the window value, right? Now this window value is nothing but with respect to how many values you are calculating the moving average for this particular measure, right? Moving average is nothing but it is just a smoothing technique, or it just smooths out fluctuations in your calculations, right? So we have mentioned, so we have something called current value, null if there are not enough values, and when you have different combinations, the value changes accordingly. And in some cases you have a blank value on the first row, in some cases you have two blank values. Now let's see what happens with different combinations in these check boxes and what are they used for, right? So now basically a moving average is calculated by default with a window value of 2, right? Which means, now let me uncheck this box as well, right? It says with respect to two previous values, I am calculating the moving average, right? Now, how does this happen? Okay, now we will look into the actual value of sales. Okay, now I have used 2 as my window value, which means with respect to two previous values, I will calculate my moving average, right? So when it comes to 16, okay, I do not have any previous value to calculate the moving average from. So that is why I have left the column as the cell as blank over here. When I move on to my second row, though I do not have enough two previous values, I should have two previous values to calculate the moving average from, right? I do not have enough previous values. I have only one previous value, but yes, that doesn't matter. I'll simply place that one previous value over here, right? But when it moves on to the third row, we have enough two previous values to calculate the moving average from. So it just adds up. It just says 288 plus 16 divided by 2, which is nothing but we have our value of 152 in our third row, right? So and this just goes on with the previous two values that you have. You calculate a moving average and you place that value right next to that particular row, right? Now this is what happens when you haven't included your current value and you are not displaying any null if there are not enough values. Now when I click on this null, if there are not enough values, what will happen, right? As I told you, when I am in my second row, I do not have enough previous values, but still, as I have just one value, I'm just simply placing that in this row. But when I say null if there are not enough values, my second row and my first row both become null, because for my first row, I do not have enough previous values, as well as for my second row, I do not have enough previous values to calculate the moving average from. That is why it is left blank. And only from the row where I have enough previous values to calculate the moving average from, I have my moving average of sales column, which starts, right? So this was about how do you null if there are not enough values. Now let's see what happens when I am going to include my current value. Okay, now as I told you, 16 did not have enough previous values, but since we have mentioned, or as we have mentioned, yes, you can include your current value also. It is simply displaying its current value. When you look into the second row, we have one previous value, and we are also allowed to include the current value, which means 288 plus 16 is nothing but 152 that is placed over here. Now, when you move on to the second row, it calculates the moving average with the two previous values, including its current value, which means 16 plus 288 plus 20 divided by 3 will give you 108. And this just goes on Okay, now this is a small change that happens when you would like to include your current value or exclude your current value while calculating the moving average, right? So this was one option. And now let's see what happens if I'm going to display null if there are not enough values. Again, the first two values are displayed as null because they do not have enough previous values to calculate the moving average from, right? So these two options that we have, including and excluding the current value, whether to display null if there are not enough values or simply leave it as it is. Now these, we have changes that happens to the result when you have different combinations of these two different check boxes that we have, right? Now this was the concept behind simple moving average, or how a simple moving average will be calculated. Okay, now after this, I think we'll start with rank. I'll just connect Tableau with that simple file that I have, which is just for explaining rank. I have this rank sample. As I told you, it's a very small data set. We just have very few number of rows and columns. Okay, yes, this is rank sample. I just have 2 columns and I think around 5 rows. Okay, in this rank sample, I have a few names and the corresponding sales. Let's see how Tableau gives ranks to these names depending upon its value of sales, right? Now, let me just connect this to Tableau, right? I will be connecting this to the rank sample, and we have our name and the corresponding sales just like we had in our rank sample. Let me bring it over here. We have our name and the corresponding sales in the text part, right? So we have the names and sales. Now let's apply the quick table calculation of rank, okay? Or you can also create a calculated field, right? Where you start typing as rank, you'll be able to view. We have one simple rank function. We have rank dense, we have rank modified, rank percentile, and rank unique, right? So we'll just make use of these different rank calculations, okay, in here in our calculated field itself, so that you'll be clearly able to understand or view the difference between these different types of rank functions, right? So first I'll just say I'll make use of the simple rank function, and I'm going to apply this rank function on my measure, right? And my measure is nothing but my sum of sales, right? So I'll just name this as rank, click apply, and okay. You can just bring this rank and place it in your visualization. We have our rank. Okay, it says first rank, second rank, fifth, third. Now, when you look into the value of sales, right?
Just a quick info, guys. Test your knowledge of Tableau by answering this question. What are the components of a dashboard? A. Horizontal. B. Vertical. C. Image extract. D. All of the above. Comment your answer in the comment section below. Subscribe to Intellipaat to know the right answer. Now, let's continue with the session.
We have the highest value of sales, which has been given the first rank. Then we have the next least value, or the next, the one which is lesser than the highest value, right? The next lowest value, which has been given the second rank. Now, when it comes to the third rank, we have a tie. We have same value of sales, okay? And that is why the same rank has been given to both these names with the same value of sales, and the next higher rank is skipped, which means after third rank we should have had a fourth rank, which is skipped, and 20. Okay, now this might be given something around third rank. This will also be given the third rank. This will also be given the third rank, right? Now how will the next higher rank be skipped, right? So we will not have the fourth rank, we will not have the fifth rank, we will directly have the sixth rank for the next value of sales, right? So this is the rank function all about. We are just omitting, or we are just neglecting the next higher rank when we have a competition and when you make use of a simple rank function, right? Now let this calculation be as it is. Let me create another calculated field where I have the next rank function, which is rank dense. Okay, and in rank dense, I'll again say rank dense of sum of sales, right? Just click on apply and okay. When you bring in, I'll just try to rename it. This is rank dense, right? Let's see how rank dense handles combination. I mean, handles the same value of sales or handles competition, right? Now I'll bring rank dense and place it somewhere over here. I'll try expanding this. So we have the simple rank, and when it comes to rank dense, we have the first rank, we have the second rank, we have the third rank. When there's a competition, we have the same third rank. But instead of skipping any higher rank, it just moves on to the fourth rank, right? So it doesn't skip out any ranks, just as our simple rank function does. Okay, now that's a small difference between rank and rank dense. Then we also have the rank modified. Okay, let's see how competition is handled by rank modified, right? And I'll just name it as rank mod. Okay, click on apply and okay. Now you have the rank mod, which is a function, which is a calculated field that you have created. When you bring this into visualization, we have rank mod. Now it says first rank, second rank, and it straight away goes on to the fourth rank, right? So what happens under rank modified, the least rank is skipped and it straight away goes to the next higher rank when there's a competition, right? Now this is a small change. You can just compare this in contrast with our simple rank function. It skips the next higher rank, whereas your rank modified skips the previous or the lower rank, okay, and then moves on with a higher value. So this is one small difference between rank function and rank modified. Then we also have our rank percentile. Okay, again, just like how we had our percentile values in our quick table calculation, when it comes to percentile of rank, when it comes to the rank percentile, values range from 0 to 1, right? So it says we have the least value of sales with a 0, the highest value of sales with 1, and then all the intermediate ones are split up are provided out of a total of 1. What is the contribution of this particular value of sales, right? And the last one that we have is the rank unique function. Rank unique of sum of sales. Now as the name tells you, it gives a unique rank. Okay, even if there's a competition, it gives a unique rank to all my value of sales, right? I'll just click on apply and okay. Now when I bring in rank unique into my visualization, you'll be able to see we have first, second, third, fourth and fifth rank. Now for every value of sales, whether there's a competition or not, even when you have a competition, you will be given a unique rank. Okay, now for the same value of sales, okay, how does Tableau or how does this function has calculated a unique rank, which both have the same value of sales, which means which name has been given the highest rank. Now G has been given the highest rank because it first looks into the value of sales. Okay, if there's a match in the value of sales, it simply next moves on to the actual name. It just calculates the ASCII code of your name, and according to which your unique rank is given, right? Now when you look into the alphabetical order, we have G, which comes first than W, and that is why G is given the higher priority, the higher rank when compared to the next alphabet, which has the very same value of sales, right? So this is how competition is handled by the different rank functions. Okay, we have rank simple rank, we have rank dense, rank modified, rank percentile, and rank unique, right? So the simple rank function skips the next higher rank when we have a competition. The rank modified function skips the least rank, okay, when you have a competition. When it comes to rank dense, there's no skipping of any ranks, okay, even if you have a the same value of sales, even if you have a competition, okay, there's the same rank that has been given for both the value of sales, but there's no skipping of the higher or lower rank. But when it comes to rank unique, every value in your file will be given a unique rank. So first it will look into the value of sales. If there's a competition, it will simply go into the ASCII code of characters, and that is how the one which comes first in an alphabetical order is given the higher priority rank, and then comes the least rank, right? So this was all about the different rank functions that we have in Tableau, okay? And with this, right after this, we are going to start with our LOD expressions. Level LOD, like LOD is nothing but the level of detail expression, right? Now, when it comes to Tableau, as I told you, this is considered to be one of the complex topics in Tableau, right? But still, once you grasp the concept behind this, I'm sure definitely this is going to be one of the easiest topics, right? So let's see what is an LOD expression, what are the different LOD expressions that we have in Tableau, okay? Now LOD is nothing but we are going to compute calculations which has complete independency from the view level of detail. Okay, now I'll tell you what is view level of detail. Okay, so this is the basic syntax. We have fixed, include, exclude. We have dimension 1, dimension 2, and then we have a colon, and we have an aggregated expression right over here. Okay, this is the syntax. Now, when you look into the diagrams, we have one diagram which is purely for exclude LOD expression, and we have another diagram that was for include, and this is for exclude. First, I'll explain what every diagram or every symbol in this particular diagram represents about, right? And yes, this is the diagram for include. And as you see, we have aggregation over here and we have granularity on this side. So aggregation is inversely proportional to granularity, right? Now, what is granularity? Breaking down one plot into different plots. Okay, we are making it granular in nature, right? After which, it totally depends. After which we will arrive at a raw data on which there is no aggregation that has been applied. Aggregation is nothing but the sum, the average that we apply on our measures. Okay, so an aggregation is inversely proportional to granularity, which means as you keep decreasing your aggregation, you will have a data which is more granular in nature. As you keep increasing your aggregation, you will have a data which is lesser granular in nature, right? So this is basically about aggregation and granularity. Then we have this dotted line over here, right? Now this dotted line corresponds to the view level of detail. What do you mean by view level of detail, right? For example, I'll just open up my workbook. Okay, now if I have category and let's say profit, now my view level of detail is nothing but what are the fields that are present right now in my view that corresponds to the view level of detail, right? Now category and sum of profit are the dimension and measure which fall or with which a visualization has been created, that is placed as or yes, so as I told you, this is the view level of detail. Now this dotted line corresponds to what fields are present in your visualization. Okay, and then we have a filled circle over here and we have a filled arrow mark. Now this filled circle represents a measure and this arrow mark represents a dimension. Okay, so here as per this diagram, we have the first filled circle which represents the measure called sum of sales. We have the next arrow mark which represents the dimension called country. Then we again have a circle, we have another arrow mark and so on, right? So I have an example with which we'll be discussing about include LOD expression in detail, right? And once we discuss about that example, we'll try connecting that example with this diagram and we'll see how the calculation has been carried out. right? And when we say include is our LOD expression, okay, we are including a new dimension, okay, with which a calculation will be performed, okay, and this dimension that you're including is not present in your view level of detail, right? So you are including a dimension with which a calculation will be performed, okay, and that dimension is not present in your view level of detail, and the corresponding result of this calculation we will be brought back to the view level of detail so that the result can be viewed in your worksheet, right? So this is just like a cycle. You have a measure and a category, you have a measure and a dimension in your view level of detail. You are including a dimension which is not a part of your visualization but only a part of your calculation, and then you are displaying the result of this calculation, right? So this is general explanation of this diagram for include, right? Whereas when you look into exclude, we again have aggregation and granularity, we again have the view level of detail, okay. But when you look into this diagram, there's a small change. The calculation when it comes to exclude is carried out above the view level of detail, but when it comes to include, the calculation is carried down the view level of detail, right? So I'll explain about these with appropriate examples, right? So we'll go back to our workbook. We'll just delete. Right. So now let me tell you, we'll start with our include LOD expression. Okay. Let's calculate the average of sales. Okay. Now I'll bring sales. Now you can place sales in your column, and then from this drop down arrow, you can change the way it is aggregated as average of sales. This is one option of how you can do this, or you can just instead of left clicking and then dragging your sales, you can right click on sales and then drag, place it in this space over here, after which automatically this dialog box appears and you can choose the way it should be aggregated from here itself, right? So we have our average of sales, and let's have our category, and let's have our subcategory, right? So we have the average of sales. Okay, we have the subcategories listed under every category, and we have the average sales of every subcategory that is getting displayed right over here. Okay, now what if I would like to compare the average sales of categories with the average sales of category in terms of subcategory? Okay, how do we do that? Okay, we will have to remove the subcategory. We will have to calculate the average of sales in terms of subcategory and then compare it with the average sales of category itself, right? Now you might have a small confusion of what is the difference between average sales of category and average sales of category in terms of subcategory, right? Now I'll try to complete the visualization first, and then I have a separate text file which is known as the LOD sample that I have. Okay, it is just something like a sample file of our superstore. Okay, so I'll explain how average of sales in terms of category is calculated and how average of sales in terms of subcategory is calculated, and why there is a change in the result between these two values, right? So as of now, we have our average sales in terms of categories. Okay, now I'm going to create a calculated field where I am going to calculate the average sales of subcategory, right? And I'm going to include the dimension called subcategory, okay, which is not present in my view right now. So I am including a dimension in the calculation that is getting performed. Okay, and this is the syntax. We have our keyword, we have our function or LOD expression name, which is include. Then we will have to specify dimensions that we are including in any calculation, and then we have our aggregated expression, which is nothing but the average of sales, right? So I'll just click on apply and OK. Now, when you bring this sales of subcategory, which is a calculation, into your view, as you notice, the way your average sales is plotted is completely different. The values are, totally different. The sales of subcategory is completely high when compared to the average of sales. This is because there's a second layer of aggregation that is applied on the result of your LOD calculation. So we will have to just change this into average. Okay, and now when you look into the tooltip, you have an average of sales and you also have average sales of subcategory, and we have different values for them, right? Now let's clearly go through every step behind how these values are calculated, okay, and why there's a difference between the average sales of category and average sales of subcategory. Okay, and as I told you, I have a simple file for that. Right, so this is the LOD sample, the sample file that I told you. I'll be connecting this with Tableau, and I'll tell you, we again have three different categories. We have furniture, appliances, and technology, under which, for example, under the category called furniture, we have chairs, tables, beds. We have quite a lot of subcategories, and similarly under appliances we have around 2 to 3 subcategories, and under technology as well we have 2 to 3 subcategories. Right, now let's see, just like how we did in this workbook with sample superstore data, how to calculate the average of sales, how to calculate the average sales of subcategory using your include LOD expression, and what is the main purpose of making use of an LOD expression. Now we were discussing about LOD expressions, right? We have include, exclude, and fixed, and we started with include LOD expression. This is the LOD sample. As I told you, we'll try connecting this with Tableau, and I'll show you how I have an LOD explanation, LOD sample explanation notes as well. Okay, I'm sorry, this is taking a little time. It is a text file. This is my LOD sample that I'm going to open. Right, we have again category, subcategory, and their corresponding sales. Okay, now I'll bring the categories and let's have the corresponding sales value, right? And when I change the aggregation, when I say I would like to view the average of sales, now this is how the average of sales is getting calculated. So first we'll see how average sales of every category is getting calculated, right? And we'll look into this. I'll have this side by side, right? Now it says we have the total sales, which is 10,400. Okay, so when you just add up all the sales value, okay, when you add up all the values of sales in the column, in the field called sales, you will have a total of 10,400, right? Which means in our workbook, when you bring in sales into the text part, you'll be able to view the entire sum of sales. Right, so this is the total value of sales, which is 10,400. Okay, and when you calculate the sales of furniture, we are just adding up the sales value right next to the category called furniture, whatever subcategory it might belong to. As of now, we are concerned only about the category furniture. So I'll just add these. I'll add the value of sales, which is under the category of furniture. So we are arriving at a result of 150. Okay, now average sales of furniture is nothing but the total value of sales 150 divided by the number of occurrences of furniture, right? So furniture, whatever subcategory it might have, so furniture occurs 1, 2, 3, 4, 5 times in our data set, right? And that is how we calculate the average sales of furniture. Now when you look into our workbook, we have average sales of furniture, which is nothing but 30, right? Now this is the same way by which average sales of categories get calculated in our sample superstore as well, but I will not be able to clearly tell you the number of occurrences in this simple way that we just now did with this LOD sample, right? So that is why I thought I created a miniature or a sample just like our sample superstore, okay, with which explaining about this average of sales will be even better, right? So that is how we arrive at the average sales of subcategories, right? I mean average sales of categories. Okay, now this is the value of average sales of sample superstore categories, whereas this is our average sales of our LOD sample. Okay, and we'll just go back to this. And similarly, we have the total sales of appliances. Total sales of appliances. So wherever you have appliances, you just add up the value of sales and you will arrive at this total value, which is nothing but 6,900. And the average sales of appliances is 6,900 divided by the number of occurrences of appliances. So you have 1, 2, 3, 4, 5, 6, and we have 7, 8 over here, right? That is why we have 6,900 divided by 8, which is 862.5, which is the average sales value of your category called appliances, right? And again, similarly, you calculate the average sales of technology in the very same manner, right? And we have arrived at this sheet. You can just have this as a bar chart if you would like to, or you can also have it as a text table, right? Now, what if I would like to compare this average value of sales, okay, with the average sales of in terms of subcategories, right? Now, how do we do that, right? Now, I'll just show you. Okay, so now when it comes to average sales of furniture, average sales of appliances, this is just the straightforward method of how average sales is getting calculated. Now, how do I calculate the average sales of appliances in terms of its subcategories, right? Now, there's a difference between both, right? This is just the average sales of that particular category, but this is the average sales of appliances in terms of subcategory. Okay, I hope you're able to get the difference between these two. Now, when I say in terms of subcategories, under appliances, I have two subcategories. I have TV and I have fridge, right? So I will calculate the average of fridge and TV separately, right? And then calculate the average of subcategories of appliances, and which will arrive at a single value. Okay, so I'm just calculating the average sales of fridge, which is nothing but under appliances. When you look into fridge, we sum up the sales of only fridge subcategory. Okay, and it occurs around 1, 2, 3, 4, 5 times. So 4,800 is the total value of sales only of the subcategory called fridge under appliances, right? So 960 is the average sales of fridge. Average sales of TV is nothing but, again, you calculate the sales value of only TV, and the number of occurrences, you divide by the number of occurrences and you arrive at 700, right? Now, therefore, the average sales of subcategories of appliances is nothing but average sales of fridge plus average sales of TV divided by 2, which is nothing but 830. So your average sales of appliances is 862.2, but your average sales of appliances in terms of subcategories is 830, right? So I hope you understood why there's a change between these values of calculating average sales of categories or average sales of categories in terms of subcategories. Right? So basically, this is the concept behind, the calculation that we are going to go through as an example for LOD include expression, right? So while discussing about LOD, it is always better to stick on to one example first, okay? From the same example, just go through the very same example again and again, try to get the concept behind it, and then you can definitely try this out in any other example. Okay, so that is the one very important point when LOD is concerned about, right? So basically this is the difference. We have average sales of categories, which is a different value, and average sales of categories in terms of subcategories, which comes up to a different value. Now, how will we arrive at this value? This is only by having average sales and category in our view and including subcategory in the calculation alone by using the include LOD expression, right? So now in this diagram, we have our average of sales, we have our category in the view level of detail. We are including the dimension called subcategory, where the average of sales will be calculated for the categories in terms of subcategories, and the result alone will be brought into our visualization so that you can compare between both the average sales of category and average sales of category in terms of subcategory, right? So basically this is what we are moving towards. This is the idea behind the calculation or the visualization that we are going to create. Okay, we are just trying to compare the average sales of categories with average sales of categories in terms of subcategories. Okay, and there's one more point. In order to bring the result of average sales of categories in terms of subcategories, we will remove subcategory from the view. Okay, we will create a calculated field which will include the dimension called subcategory, okay, which is not a part of my visualization. I'm including it only to calculate the average of sales, right? Yes, so this is the include LOD expression, and I'll just call this as sales of let's say subcategory, because it is in terms of subcategories, right? Just click on apply and OK. But when I try to bring this into visualization, okay, when I try to bring this into visualization, though there is already an aggregation called average that I have used in my calculation, okay, there is a second layer of aggregation that is applied to my calculation itself, okay, and which is by default the sum aggregation. I'll have to just change it as average, right? And now you'll be able to clearly compare between the average sales of categories and average sales of categories in terms of subcategories. Okay, and what is this second layer of aggregation all about? When you look into this diagram, we are performing the calculation in a space which is below the view level of detail, below this dotted line, right? Which means my view level of detail is more aggregated than the space where I am performing this calculation, right? So that is why, because my calculation is less aggregated than the view level of detail, when I bring back the result to the view level of detail, just to match the aggregation of my result with the aggregation of the view level of detail, I am applying a second layer of aggregation, right? When you just look into this line, this horizontal line over here, and this view level of detail, right? Your view level of detail is more aggregated, and when you move down to the space where your calculation is carried out, it is less aggregated when compared to your actual view level of detail. So that is why, in order to match the aggregation with that of the view level of detail, we are applying a second layer of aggregation on our result. Okay, only then it will be matched with the aggregation of my view level of detail, and the result will be displayed in the worksheet. Right, now there are two ways by which you can apply the view level of you can apply the second layer of aggregation. You can either change from this measure over here, okay, or you can simply edit this calculation. You can simply wrap up this entire calculation with a second layer of aggregation, right? So my entire include expression is wrapped up with an average aggregation. You can also try doing this. Anyhow, you should have two layers of aggregation. Only then your result that is calculated in a level which is lesser aggregated than the view level of detail will be matched with your aggregation of the view level of detail, right? These are a few points about include LOD expression. Okay, now we'll just go into our actual workbook of sample superstore. Yes, so we have our average of sales of categories, and we have average sales of categories in terms of subcategories. Okay, you can just look into the tooltip. We have different values for both of them because I'm sure by now you must be able to get the point why the value of both these are different, right? Now we'll just try enhancing the visualization. Okay, now we are going to create a dual axis graph, dual axis chart. Okay, and in order to create a dual axis graph, we need to have two measures. Okay, and we'll be discussing in detail about dual axis graph during our next session. We'll be starting with the next module, which is about charts and graphs.
Just a quick info, guys. Intellipaat provides Tableau online training and certification course mentored by industry experts. The course link of which is given in the description below. Now, let's continue with the session. Just a quick info, guys. Test your knowledge of Tableau by answering this question. Which of the following is not a trend line model? A. Linear trend line. B. Exponential trend line. C. Binomial trend line. D. Logarithmic trend line. Comment your answer in the comment section below. Subscribe to Intellipaat to know the right answer. Now, let's continue with the session.
We have average sales of subcategory. You can customize, you can enhance each and every chart, each and every graph, each and every measure. You can color them, you can change one into a bar chart, one into a line chart, just totally depending how you would want your view, your final view to appear, right? So I'll just show you one example. As of now, I'm changing both the measures as bar charts. Okay, and we have our average sales, which is blue in color, and we have our average sales of subcategory, which is orange in color, but you are not able to find the blue bar graph because it is just overlapped. Both the bar charts, bar graphs are overlapping on each other, right? So because of which, let me reduce the size of this so that you'll be able to see the blue graph right behind it. Okay, now with this type of visualization, the user will be clearly able to compare between what is the average sales of category, which is the blue graph, blue bar chart, and what is the average sales of category in terms of subcategories, right? So that is why we have a orange bar chart over here, right? So you can easily compare them with this type of a visualization. This was one example where you can make use of LOD expression. You are calculating with a dimension which is not present in your visualization, right? You are including a dimension to your calculation which is not present in your visualization, right? Now exclude is just in contrast with this, right? Now just in contrast with include, we have our exclude LOD expression. We are, as you look into this, we have the filled circle, which is a measure. It is average of days. Then we have our first dimension, treatment category, and we have some other dimension called admit source, and then comes the view level of detail, right? Now from the view level of detail, okay, we are excluding a dimension which is already present in our view level of detail. We are performing the calculation without considering this excluded dimension and then displaying the result in the view level of detail, right? So we'll just look into that example as well. Let's say, for example, I have the state and city related sales, right? Now let's have the state. Okay, we have the list of states, and let's say we have cities. Okay, and let's have the corresponding sales, right? Now we have the state under which we have quite a lot of cities, and their corresponding sales is displayed over here, right? Now what if let's just sort this out in a descending order. Okay, so we get this over here, right? Now you can either use your state and city hierarchy as well for this, right? And now we are planning to compare the average sales. Okay, I'm sorry, I'll just change this into average sales. Instead of sum of sales, let's have average of sales, right? So now I have the average sales of cities, okay, that has been visualized over here. I would like to compare the average sales of state, okay. For every state, I would like to have a state average, okay, with which I can compare which cities has an average sales which is above or below the state average to which it belongs to, right? And how can I calculate the average of state when I have city in my visualization, right? This is where we make use of an exclude LOD expression, right? Just like this example over here, we have our average sales, we have our state, we have our city in our view level of detail, right? From which we are going to exclude a dimension. We are going to exclude city from our visualization. We are going to calculate the average sales of state alone and then bring the result to our visualization, right? Now let me just visualize it, and then when we arrive at the final visualization, you'll be clearly able to understand, right? So I'm going to create a calculated field. This, I'll just name this as state average. Okay, I'm going to exclude a dimension. Now you can, when you are including a dimension, you can include any dimension of your choice, whatever is present in your data set, right? But while excluding, you will have to make sure you will have to exclude only the dimension which is already present in your visualization, right? So that is one important point when it comes to exclude. So here we are excluding the dimension, which is nothing but the city, and my aggregated expression is average of sales, right? I'll just click on apply and OK. Now this is the state average. You can simply bring the state average and place it into your visualization. Now there's one point. When we try to bring the calculation into our view in our include LOD expression, okay, we had to either apply a second layer of aggregation, or we had to add two layers of aggregation. We had to wrap up the entire include expression or with an average aggregation, which is the second layer of aggregation, right? But when it comes to include, what is supposed to be done? I'm just bringing state average into my view, right? And yes, I have the result that is getting visualized. This is because, as I told you, when it comes to include, the calculation is done in a space which is in a lesser aggregated area than the view level of detail. That is why, while bringing the result back to the view level of detail, in which is more aggregated in nature, we had to apply a second layer of aggregation, right? But in contrast, we have our exclude calculation that is done above the view level of detail, above this dotted line, which means the calculation is getting performed in a space which is more aggregated than the aggregation of the view level of detail, right? That is why when it comes to an exclude LOD expression, okay, because the result is already in a more aggregated area, there is no need to apply a second layer of aggregation. You can simply replicate the result in the view level of detail, right? You can just compare these two diagrams. The calculation is below the view level of detail, and here the calculation is above the view level of detail, because we are excluding a dimension which is already a part of the view, right? So that is why the calculation is done above the view level of detail, and instead of applying a second layer of aggregation, there's no use of applying a second layer of aggregation. You can just replicate the result to be visualized in your worksheet, right? In your view level of detail. Okay, let me go back to the workbook. I have brought the state average. We haven't applied any second layer of aggregation. We are just replicating the result over here. Okay, it says attribute because you cannot further apply any aggregation on top of this, right? Now let's enhance the visualization. Now we have both as bar charts. Okay, I would like to have the state average to be displayed as Gantt bar. So under state average, I am choosing the Gantt bar from the marks card. Okay, and let me create a and let me change the color of it first. Let's have a lighter color, something like this. Okay, and let me create the dual axis chart, right? And I would like to have my average sales of cities as a bar chart itself, right? Now let's try synchronizing the axis, right? After which we have our average sales of cities, and we have the average, the state average that is represented using a Gantt bar. So by this, you can clearly be able to find out which particular city has a sales which is lesser than the state average, or whichever is higher than the state average, right? You can also label them. You can also change the color of your bar chart. Let's say I would like to have this as light blue and orange. Okay, and you can also label them. You can simply bring your sales with a right click on your label and have it as an average of sales. Okay, and when you click on this label, you can decide on your alignment options. Okay, I'll just place it in the center, right? And then you can also label your state average, right? So with which you can easily compare whatever is your state average and whatever is your city average in one single chart, right? So this is an example of exclude LOD expression. We are excluding a dimension which is already a part of our visualization, performing the calculation with only the dimension that is left out. Okay, and then we are displaying, we are just, instead of applying, there's no need of applying a second layer of aggregation. We are just replicating the data in our view level of detail, right? So this was about include and exclude. So I hope you're able to compare both the differences between these two, right? And we just have one more to go, which is nothing but the fixed LOD expression. But when it comes to a fixed LOD expression, calculations are computed independently of what data is present in my visualization. I might have any dimension in my visualization, right? But the result of my calculation will remain fixed, right? So let's just look into an example for that. Let's say I would like to see which are the customers who are profitable and which are the customers who are not profitable, right? Let's say I'll bring in the customer name into rows, and let me bring in the sum of profit. Okay, now when you look into this profit, we have a few customers with positive profit and we have a few customers with negative profit, right? So now let me just create a very simple calculated field, right? I'll just call this as color. Okay, I'm going to just say sum of profit is greater than 0. So there'll be two different colors, one for the value of sum of profit greater than 0 and one for the profit value which is lesser than 0, right? So I'll just click on apply. Okay, and I'll place this into the colors mark. So now as you notice, and I'll just change true to be blue and false to be orange. Click on apply and okay. So here we have, you can also sort this out in descending order. So these are the list of positive customers, and as you go ahead, you'll have a list of negative customers, right? Which we have a different color code for the positive or profitable and non-profitable customers, right? But this doesn't answer any such analytical questions. right, as of what is the number of profitable customers, like let's say per city or in any state, in any particular state, what is the number of positive profitable customers and what is the number of negative or non-profitable customers, right? So how do we do that? So in order to answer such analytical questions, we will have to make use of our LOD expressions, right? And let's see how that can be done. Okay, now you can also bring in city over here, okay, where you have whether this particular city has a positive profit or not, this particular city has a negative profit or not, right? But in this same chart, I would like to view the number of customers in any city who are profitable and not profitable, right? So let's see how this can be done. I'll just clear the sheet. Okay, now let me create a calculated field, right? So whatever dimension is going to be placed in my visualization, this calculation is going to remain fixed. Okay, I'll just say fixed. I'm sorry, I'll just say fixed, and I'm going to fix the customer name over here because I would like to view the fixed count of customers, okay, in terms of whether they have positive profit or negative profit, right? So we are simply specifying a condition right here in our LOD expression. Okay, so we have our sum of profit which is greater than 0 and customer name. Okay, I'm sorry, I just didn't name my calculation. Okay, so this is it. We have our fixed customer name. We are fixing the dimension called customer name. Okay, and we are just calculating whether the customers have a positive profit or a negative profit, right? So this is the result of this calculation, and we'll just name it as, let's say, profitable customers, right? So we have this calculated field. Just click on apply and OK. So we have profitable customers. Yes, they are profitable customers with a profit greater than 0, or no, true or false value. No, they have a negative profit, right? Now let me just let's say bring in customer. Okay, I'll bring in cities. Okay, let's try calculating the count of customers in terms of cities. We'll have our cities in rows. Okay, and now let's put this calculated field called profitable customers. Okay, and while putting this into our columns, we will have to have a count distinct, or you can have a count aggregation. I think count will be fine, right? Let's have a count aggregation. Only then you will get a count of profitable or non-profitable customers, right? So as of now, we are able to view, we have a count of profitable customers as 355. The count of customers are clearly viewed over here. Okay, now let's try to make it even more clear. Okay, let's try to make it even more precise, and I'm creating another calculated field. So I'll just complete the visualization, and we'll come back to the different calculated fields that we created, and we'll just go through what is the advantage, what is the purpose of every calculated field, right? So now I'll just call this as profitable, whether this is profitable or not. We are just going to differentiate between them, right? So I'll just say if the result of my calculated field called profitable customers is equal to true, right? Then, right? So if the result of my calculated field called profitable customers, which makes use of the fixed LOD expression, is true, which means if the sum of profit is greater than 0, right, then they are profitable, right? Else you can just say they are non-profitable, right? And you can simply end your calculation, right? After which we will just click on apply and OK, right? And now let's just place this profitable into the colors marks card. Okay, and I'll just change this. I want profitable to be blue in color, and I want non-profitable to be orange in color, right? I'll just click on apply and okay. Now for every city we have a blue mark and we have an orange mark, right? So it says blue corresponds to profitable customers, where the count of profitable customers is 300. When you click on orange, it is the count of non-profitable customers, but it says count, the tooltip has to be enhanced, right? But as of now, this is the count of customers who has negative profit in this particular city, and this is the count of customers who has positive profit in this particular city, right? Now let's try enhancing the enhancing the tooltip. Okay, as of now I don't think the tooltip is fine. Now let me just click on tooltip. Okay, I'll just remove this. I'll just have it as count of profitable customers. So these many customers. Okay, you can just insert city from here in this particular city. Okay, your tooltip is going to be dynamic in nature, so it will automatically display the city wherever your cursor has been placed. So these many customers in this particular city are, whether they are profitable or non-profitable, right? To display that, we will make use of this calculated field, right? Just click on OK. And now when you look into the tooltip, it says 300 customers in New York City are profitable. So as an audience or as a user, they will be clearly able to understand what analysis you have made right from the tooltip that you have created, right? Or it says there are 50 customers in San Francisco who are non-profitable, right? So it clearly tells you from the tooltip itself, the users will be able to understand. And as we had made it dynamic, the name of the city also is getting updated according to wherever we place the cursor, right? And blue means it is profitable and orange corresponds to the non-profitable customers, right? Now, why do we say this calculation is fixed? Whatever dimension is placed in your visualization, or this calculation is computed independently of whatever data is present in your visualization. Why do we say that? Now we have our city related information. Now I can just simply replace city by state. You just have to place state right on top of city. Okay, and as you notice, for example, in California, the tooltip has also been updated accordingly. Instead of city, we have the state in our tooltip. Okay, you have the information that 473 customers in California are profitable and 104 customers in California are non-profitable, right? So whatever dimension I bring in my view, the result of this calculation is just going to remain the same. The result of this calculation is just fixed as it is, right? You can also try bringing any other dimension. Let's say subcategories, right? You might be able to see these many customers in this subcategory are profitable and these many customers in this subcategory are non-profitable, right? And you can also you can also label your visualization. Okay, I'll bring this count of profitable customers in the label part with a count aggregation, right? After which you'll be able to see, you can just expand this a little bit. You'll be able to see you have the exact count of customers right here in your bar chart itself, right? So this will allow the user to, very easily view your chart and, get to know what analysis you have made, right? So this is about the fixed LOD expression. Your calculation is computed independently of whatever data might be present, whatever dimension you might use in your visualization, right? So this is all about our LOD expressions that we have include, we have exclude, and we have fixed LOD expression. Next topic called LOD calculations, about how to fetch the latest 3 months details or 3-month data alone, right? So I'll create a new sheet. Now I'm going to bring in my order date. Okay, let's have it in terms of continuous months. Okay, and please note, I have first converted it into a continuous date field, okay, in terms of months, and then I am changing it into discrete, right? This is because I would like to have a text table in this manner, which has continuous month details, but the values should be displayed in a discrete format, right? So I hope you understood how we arrived at this. I have my order date in terms of continuous months, where I have every month name, a plot for every month, right? And after which I'm just changing it into discrete, so that I'll be able to get this as a text table. I'll be able to make use of this as a text table, right? Now let me bring in the sales and place it into the text part, right? So this is our continuous months in a discrete format. Okay, now as of now, the latest month is December 2018, November 2018, and October 2018, right? Now let's try to fetch out only the latest month, okay, which is December 2018, right? Let's see how that can be done. I'll be creating a very simple calculated field, right? I'll just call this as latest month sales, right? We'll call this as latest month sales because it is going to fetch only the sales of the latest month. And as our data is concerned, we have December 2018, which is the latest month, right? So for that, I'm going to make use of a few date functions, right? So now let's see how that can be done. I'll just say I'll make use of the if logical function. If I'll just complete typing the calculation, right? And then I'll let you know what is being done over here. Now we are calculating the date difference in terms of months, okay? And between, I'm just trunking the date to the month level, okay? And this details is to be fetched from the field called order date, okay? And after which, I mean, when it comes to date difference, we should have a date part, okay? We should have a start date and an end date between which the date difference will be calculated, right? So when you look into this, okay, so we have the date difference in terms of month. The date part is month, right? Now the starting date is the date trunk. I'll tell you what is date trunk about, okay, right? In terms of month, and then I'm going to calculate the max of date trunk. Now what is this all about? I'll just let you know. I'll split this up into 3 and I'll explain the result, what every single function is going to display, right?
Just a quick info, guys. Test your knowledge of Tableau by answering this question. What are the components of a dashboard? A. Horizontal. B. Vertical. C. Image extract. D. All of the above. Comment your answer in the comment section below. Subscribe to Intellipaat to know the right answer. Now, let's continue with the session.
We have month as the date part again, and we have the order date from which the corresponding details are to be fetched, right? And after which we have, I'll just make sure the curly braces are fine, right? Yes, now when this is equal to 0, then you can display the sales, else end it, right? Date difference, we have month to 1, 2, 3. Okay, I'll just close the date difference over here. I think this should work fine. Yes, right. So we are just calculating the difference between 2 dates, right? In terms of in the month level. Okay, so I am the result of this date trunk in terms of month level of order date. So this is the starting date, which is nothing but for every month we will have this value that is displayed. Okay, and then this max of date trunk. Now date trunk month of order date. Okay, the max of date trunk month of order date is going to be 12, right? Because the maximum month that we have in our the latest month that we have in our data set is 12, the month of 12 of 2018, right? So that is why we will have the month of 12 of 2018 over here. So when you find a difference between them, right, only the December month details will have a value of 0 when you calculate a difference, right? All the others will have a different value. For example, November will be something like 10 minus 2 or 12 minus 2. 12, which is the max of date trunk, minus 10, which is the number for October, which is nothing but 2, right? So the value is not going to be equal to 0. So only when it is equal to 0, we will be able to fetch the latest month details. Just click on apply and OK. So we have our latest month sales. Drag this latest month sales simply here into your visualization. Right now, as you notice, we have the actual sales, and when it comes to the latest month sales, we have only the latest month, okay, which is December 2018 value of sales that is displayed in this space. Right now, similarly, you can calculate, you can just create a calculated field for let me just create a duplicate of this. Okay, and I'm going to edit this. I'll name it as, let's say, previous month sales. Okay, and here I will have the value as 1. Okay, so now max will be 12. Okay, and only when it is November we will have 12 minus 11, which will where the value is going to be 1, right? So just click on apply and OK. When you bring this into the view, you will have the previous month sales, and similarly you can also calculate the prior month sales. Okay, just try duplicating this. You can edit this, have this value as 2, and then you can just name this as prior month sales, which is going to display the sales of the month of October, right? So this is how you fetch out every latest month details as per your requirement. Okay, now let's say you can just simply remove sales from your text part. Okay, and you can remove month from your rows, right, where we have only the latest month, previous month, and prior month sales, right? You can bring in measure values and simply place it into your rows so that we get a bar chart for the latest month, previous month, and prior month. Okay, and you can also label them if you require. Just bring in this calculation and label them, or you can just click on this, after which the label option, the text option in your toolbar, right, after which your bar charts will be labeled, right? So this is the latest month, previous month, prior month, and this calculation will be done according to whatever data is present in your data set, right? So this will get updated as your data set increases. Your data is getting added to your data set, right? And also for having latest 3 months together, right, you can just say a value. You can just change your calculation as, instead of equal to 2 or equal to 0 or equal to 1, you can just say anything which is less than or equal to 2, right? After which you will be able to, let's try doing that. I'll create a new sheet, right? Let me just create a duplicate of this and I'll try editing this. Okay, and in this calculation, let me just remove, we'll remove the condition. Let's have only the date difference, and let's also remove this, and let's change this to be lesser than or equal to 2, right? And just click apply and OK. Now you can, I'll just rename this. You can have it as latest 3-month sales, right? So we have our latest 3-month sales. Okay, you can bring this, let's say, into your view, okay, where you have true and false values. Now, okay, now let me just bring in order date, okay, and their corresponding sales over here. Let's change it into a bar chart. Okay, you can also have it in terms of continuous months, right? Or you can also change this to be discrete so that you have a separate bar chart, right? Now when you let's say, let me bring this latest 3-month sales into the filter first, and I would like to view only the true values. Click on apply and OK, after which only the latest 3 months values will be displayed, right? So this is just displaying all the 3 months values together in one view. Okay, so this was just an example of LOD calculation. This is not an LOD expression. This is an LOD calculation, a calculation which will be carried out independent of what change is being made to your data or what is present in your visualization, right? So this was all about LOD expressions, LOD calculations, about the inbuilt functions and calculations that we have in Tableau, right? Yes, we are going to start with charts and graphs. Now, this is again one important topic because it really matters. Whatever analysis you have made, you will have to represent, you will have to visualize it with an appropriate chart, okay, as per analysis you have made, right? And only then your chart, your visualization, whatever analysis you have made will reach the audience in a better manner, right? So we have various types of charts and graphs that you can make use of in Tableau in order to visualize your data. Now we have around 24 types of charts and graphs, which is readily available right here under Show Me, right? And we also have a few other types of charts and graphs that can be created, right? Let's start with the dual axis graph, right? Or a dual axis chart. Let's see how to create that, right? As the name tells you, we have dual axis chart or graphs. It means you need to have 2 axes, right? Which means you need to have 2 measures. So only when you have 2 measures, you can create a dual axis chart, right? Let's say I have my order date, and let's say we have 2 measures. We have sales and we have profit, right? So now we have a separate axis for sales and we have a separate axis for profit. Now, if I would like to compare both these measures under one graph or in one graph, how do we do that? Now, this is where we go into the dual axis graph or dual axis chart, right? As I told you, we need to have 2 measures in order to create a dual axis graph. Now, when you click on the drop down arrow of your first measure, you do not have an option called dual axis, right? Only on your second measure, when you click on this drop down arrow, you have an option called dual axis, right? So let's create a dual axis. So now automatically we have a color code. We have a separate color for sales and we have a separate color for profit, right? But again, we have sales and profit, and the way, yes, exactly, so we will have to synchronize the axis, right? So we have the values, the way your graph, your axis appears is different for both. So we will have right click on any axis and you will have an option called synchronize axis, after which both the axes will get synchronized, and you can just remove the header, you can remove one axis, and now we have our sales and our profit plotted in the same graph with just one axis, right? And you can also notice there's a structure change in between these 2 pills, right? So there's a straight line with which these 2 pills appear, and this indicates that you have created a dual axis between these 2 measures, right? Now, what if I would like to have one more measure? What if I would like to compare, let's say, the sales, profit, and discount of this particular superstore in a single graph, right? How do we do that? Now, let me bring discount, which is again a measure, and place it right next to profit in rows. Okay, so now we have already created a dual axis chart or graph for sales and profit. Now let's also try including discount in this graph, right? Now when you click on this drop down arrow, you do not have the option called dual axis, because as I told you, a dual axis graph can be created only between two measures, right? Then how do we include a third measure, or how do we compare more than two measures in the same graph, right? Now this is where we make use of the measure names and measure values, right? So let's remove these measures. Okay, let me bring in the measure values, okay, which is an auto-generated field under measures. I'm just placing this measure values into rows, and after which all our measures, all the fields under measures, we have discount, we have number of records, profit, quantity, and sales. All these measures have been plotted out in our graph, and just to differentiate between these, I would like to bring measure names and place it into the colors mark, after which every measure name has been given a unique color. Okay, and now I can simply filter out. I would like to view only discount, profit, and sales in my graph, in one particular graph, right? I'll just click on apply and okay. So now you have only your sales, your profit, and your discount, which has been plotted in a single graph, right? So when you would like to compare, or when you would like to plot two measures into the same graph, you can go in for a dual axis option. When you would like to compare or visualize more than two measures in the same graph, you can make use of the measure names and measure values, by which we can create a multi-axis graph, right? So this is how you create a dual axis graph and a multi-axis graph using your measure names and measure values, right? So now this dual axis option can also be used to create dual axis maps, right? You can also combine two maps and display the information on two different maps in a single map using your dual axis option, right? And we'll also be looking into how to create a pie chart and how to create a donut pie chart, where again we'll be making use of this dual axis option, right? So basically, in order to create a dual axis chart or graph, you need two measures, and only on the drop down arrow of your second measure you will have the option of dual axis, right, with which you can combine, you can visualize both these measures into the same graph, right? So this was about the dual axis graph. Next we have, you can just look into the show me. You have different types of text tables, heat maps, highlight tables, pie charts, and so on. And you have the requirements for every type of chart or graph, right? So we'll just go through a few. We have a dual combination chart, or we also call it as a Pareto chart or Pareto chart, however you pronounce it, right? Now, as say dual combination, you have two different types of charts combined into one, right? Now, let's say I have my, again, let's have our date, and let's have both our measures, sales and profit, right? So under show me, so these are the different options that you have for this combination of one dimension and two measures, right? So now let's look into this option. So we call this as the dual combination chart, right? So one measure has been plotted out using a bar chart, and one measure has been plotted out using a line graph, right? So this is how, and automatically you have this dual axis chart that has been created between these two, right? Now this is a readily available option which is available, right? And you can also do this manually. For example, you can bring in your order date, you can bring in your sales, and let's say your profit. And when you look into this marks shelf, you have three options, so three different tabs. You have all, you have sum of sales, and you have sum of profit, right? So now this is, we use Pareto. Yes, okay, yes, that is one type of chart that you can make use of. Yes, so as I told you, for comparison, we use Pareto. Yes, exactly. Yeah, now when it comes to your marks shelf, we have separate tabs for all. Now this simply means when you, let's say, change the size, or decrease the size, automatically both your graphs will correspond to whatever changes you make under the all tab, right? When you click on sum of sales, only your sales line graph will act according to the changes that you make in this space under your sum of sales, right? Now let's say I'm changing this into a bar chart, or you can have it as a circle mark, right? So only your sum of sales graph will correspond to whatever changes you are customizing using this tab, using these options under sum of sales. And the same with sum of profit, right? I would like to change the color, so only this particular line chart which corresponds to the profit will reflect the corresponding changes, right? So this was just one point. When you go in for a when you have two measures, you have separate options, separate marks cards which are available for each measure, as well as a generalized marks card which is available for both your charts, right?
Just a quick info, guys. Intellipaat provides Tableau online training and certification course mentored by industry experts. The course link of which is given in the description below. Now, let's continue with the session.
And I have my corresponding sales, right? Now, by default, whenever you have one measure and one dimension, it is automatically a bar chart that gets created, right? So this is the first combination. Now, what happens when I have one date dimension and one measure, right? So it is automatically a line chart that gets created when you have, it might be in any order, it might be you might have a measure in rows and a dimension in columns, or just the other way around, it doesn't matter. But for a combination of date dimension and a measure, it is always a line chart that gets created. You can very well go ahead and change it into a bar graph or any type of chart as per your requirement, but automatically for this combination of one dimension and one measure, it is a line chart that gets created, right? Now similarly, you have, let's say, two measures. When you have two measures, you have the shapes marks card that comes, that is automatically used under your marks shelf, because it is a scatter plot chart that gets created when you go in for two measures in your visualization in your row and column shelf, right? And similarly, when you have two dimensions, let's say I have my subcategory and category, okay, it is automatically a text table that gets created for the combination of two dimensions in your row and column shelf, right? So we have a text table when you have two dimensions, you have a scatter plot chart when you have both as measures, you have a bar chart when you have one dimension and one measure, and you have a line chart when you go in for one date dimension and one measure, right? So these are a few basic points. As you start using Tableau, definitely you'll be getting to know all these in the flow, right? So this was just for information about what type of chart gets created automatically for the different combinations with which that you bring into visualization, right? So as I told you, you have we just had our region and sales. Okay, by default it is a bar chart that gets created, but I can also go in and create a line chart. Okay, and and you can also have a date line chart, hierarchies, when you make use of a date dimension for which Tableau itself has created a default hierarchy, you can just go ahead. You can have a separate line chart for every year or for every quarter. Okay, or you can also change it into a continuous year, right? We'll have it as a continuous year with the measure, after which you have a line chart for it, and then you can keep going ahead in terms of your continuous date field, right? So now there are a few differences between using a discrete date field and continuous date field, right? So this is basically how each discrete date field and continuous date field act when you try to visualize data using these date fields, right? And you can also, let's say, bring in categories or any dimension in the colors mark, after which you will have a separate line chart for every category, okay, that you have in your data set. Or you can also bring in region, right? So you have a separate line chart depending upon the sales in a continuous month format for the different regions that you have in your data set, right? So this is how you color your line charts. This is known as a colored line chart. Okay, so these are the different options with which you can go in for a line chart, right? And next we have bar chart, right? So again, bar chart is something that we've been using. Let's say we have our subcategory with the corresponding sales. Now this is a vertical bar chart. You can just swap your pills to create a horizontal bar chart, and you can just place in, let's say, ship mode or any dimension, after which you are creating a colored bar chart, right? Now this becomes a colored bar chart, and you can just, let's say, I'll show the filter for the dimension category, and this becomes an interactive bar chart because you're interacting with your bar chart. Okay, and then we have something called as a leveled bar chart. Now when I bring category also into the view, we have a separate pane for every category under which the corresponding subcategories are placed, right? This is known as a leveled bar chart. So basically we have the horizontal vertical bar chart. We color our bar charts, we make it interactive, and you can also have such bar charts known as leveled bar charts. Now when you click on your sorting options, there's a sorting that takes place for every category. Okay, so yes, now these are again a few options while creating bar charts. Next we have pie charts. I'll just show you. When you have two measures, it is a scatter plot chart that's created, and I would like to split this plot into, let's say, I'll have different subcategories. You can place it into the details mark, right, by which the same shape has been given for all your subcategories, or you can also place it into the shapes marks card. Okay, after which you will have a separate shape that has been given for the members in your dimension called subcategory, right? Now this is again called the shape legend. Okay, just like we have our color legend, this is known as, we also have our size legend, and this is known as the shape legend. It is just a key which indicates that for which particular shape, which category belongs to which particular shape. And as you notice, we have repeated shapes over here because, this particular palette that we are using consists of only around 10 different shapes where we have 17 subcategories. You can just go in and choose from the set of palettes that are available, right? You can make use of these arrows, right? Or you have these thin arrows or weather related shapes, right? So these are a few options that you can make use of. Okay, so this was about the scatter plot chart and how you can make use of the marks card, the shape card in your marks shelf. Okay, this was about the scatter plot, and you can again make your scatter plot chart colored or interactive, right? And we also have the option called drop lines. Now let me bring in subcategory into detail. And now when you click on any one plot, okay, when you just right click, you have this option called drop lines, right? I'll just say show drop lines, okay. And again, when you right click on any plot, you have an option called edit drop lines. Now these are lines dropping from any plot that you select, right? Your lines drop both to your x-axis as well as to your y-axis, and you can just customize them. I would like my line to drop only to x-axis, okay, and I would like the line to be dropped always, and not only when I select, but I want the line to be dropped always. The line is supposed to drop to x-axis, right? Just click on OK, after which for all the plots in your graph, there's a line which is dropping to x-axis. Now this doesn't exactly show where your line is dropping or what value in which your line is dropping, right? You can also customize that. Let's say I'll go in for only when selected, right? And I would like the line to drop to both to x-axis and y-axis, okay? And I would like to give in an automatic label as well, right? Now when you click on OK, now only when I select any plot from my graph, right? Let's say I'm selecting this plot. Now there's a line dropping to both x and y axis, as well as we have the value that has automatically appeared at the end of the line. So with this, we can clearly identify what is the exact value this line is dropping at, or between these, what values this plot has been plotted out, right? So this is just for your convenience. When you go in for a presentation, you can just have such drop lines. So whenever you click, you select any particular plot, you will have lines dropping, you will have the exact value where on which your line is dropping for this particular plot, right? So this is what drop lines are all about. And next we have the bubble chart. So when you look under show me, you have packed bubbles. Okay, you have one or more dimension and you need one or two measures in order to create a bubble chart. Now let's say we'll have categories and we have the corresponding profit, right? And as I told you, by default, with a dimension and a measure, you have a bar chart that gets created, right? But when it comes to packed bubbles, we will have to go into show me and then select packed bubbles. Now this is how a packed bubble chart looks like. You have circles and you have a number of circles and you have the size of circles. Now the number of circles is decided by the dimension, right? Because the number of values, the number of members in your dimension decide the number of circles, okay? And the value of your measure decide the size of every circle, right? For example, I have my subcategory. You can also create a chart by simply clicking on one dimension, press Control from your keyboard, click on any other measure, and then go into show me, after which you will be able to see what are the different types of charts that can be created with this combination of one dimension and one measure, right? Needn't have to bring them into the visualization and then create a chart. You can just click both, any of your dimensions and measures, and then go into show me and select that particular chart, right? So we're under subcategories, we have 17 subcategories, and that is why we have 17 circles right here in our bubble chart. Okay, and the size of every circle is decided by its value of sales, right? So we have phones with the greatest value of sales, and that is why phones is having a larger circle compared to all other subcategories. Now there's one limitation while going in for a bubble chart, right? It is always better to avoid going in for bubble charts with dimensions having more data, right? For example, if I would create a bubble chart for customer names, right? I have quite a long list of customer names. Now, when I go in to create a bubble chart for customer names with their corresponding let's say profit or quantity or sales. Okay. Now this is how your packed bubble chart appears. Okay, it just forms a cluster. We are not able to clearly identify or analyze any information as such from this type of a graph, right? So it is always better to avoid using packed bubbles when you have more data. But when you have a limited number of members in your dimension, you can very well go ahead. Let's say, for example, ship mode and its corresponding profit. You can very well make use of packed bubbles, right? Where the number of bubbles is decided by the dimension and the size of bubbles is decided by your measure, right? And this was about the packed bubbles chart. We also have tree maps. Okay.
Just a quick info, guys. Test your knowledge of Tableau by answering this question. Which of the following is not a trend line model? A. Linear trend line. B. Exponential trend line. C. Binomial trend line. D. Logarithmic trend line. Comment your answer in the comment section below. Subscribe to Intellipaat to know the right answer. Now, let's continue with the session.
When I click on tree map, you have technology, office supplies, and furniture, right? When it comes to tree maps, as I told you, it is very similar to a packed bubble because the number of boxes, it might be a square or a rectangle, the number of boxes in this tree map is decided by your dimension, right? So under the dimension called categories, we have three different categories. So we have three different boxes, and the size of each box is decided by the sales or whatever the profit, right? So profit is our measure over here. Whatever is your measure, depending upon the value of that measure, your size, the size of your box is decided, right? So again, as I told you, the number of boxes is decided by the dimension and the size of each box is decided by your measure. Okay. And when it comes to tree maps, the main visual element of tree map is known as, it is also known as a space filling display, right? So when you notice, we have only three members in this dimension called category, but still the entire space in our worksheet has been occupied by this tree map, right? Or let's say I would have subcategory wise sales for which I'm creating a tree map, right? And even then I have the entire space in my worksheet that is occupied, right? Now this is why we call tree maps as a space filling display, because it occupies the entire space in our worksheet. And in this example, we have our subcategories. We have 17 subcategories. So the number of boxes is equal to the number of members in your dimension. And the size of each box is decided by your measure, which is nothing but sales in this particular example, right? And I'll just show you. Let's create a hierarchy. Let's say I have my country and my state, right? I'm just creating a hierarchy for this. And let's try using this hierarchy and create a tree map, right? As I told you, we only have one country called United States under the dimension called country, right? Even then the entire space is occupied in my worksheet, right? And when I drill down, so under this particular country, we have so many different states for which a tree map has been created. So you can also make use of hierarchies while creating tree maps. Okay. And this is one important point. It is known as the space filling display. It is the only chart which occupies the entire space, no matter what measure or what dimension you make use of to create a tree map, right? And again, when it comes to tree maps, you can have an interactive or a colored tree map, right? So any chart for which you simply create a quick filter, that becomes an interactive chart, okay? And you can also color them out. Let's say, for example, I'll bring a category into the colors marks card, after which your tree map has been divided into three different colors depending upon whichever category your subcategories belong to, right? And you can make it interactive in nature using your quick filter, right? So this becomes an interactive tree map as well as a colored tree map, right? So this was all about tree maps, and then we have pie charts, right? So now let's see how to create a pie chart and what are the different options and what are the different types of pie charts that you can create in Tableau, right? Now you can simply click on one dimension. Let's say we'll have a region and the corresponding sales, okay? And under show me, you can go in and create a pie chart, right? Or this is one way by which you can create a pie chart, or you can simply, let's say, drag in categories, the corresponding sales, and under your marks, in your marks shelf, you can choose your pie marks card, right? After which you will have a separate pie that gets created for every single category, okay? Or you can simply bring in the sales value and place it into your visualization, right? And then choose pie from your marks card, for which a pie chart has been created for the entire value of sales, right? And then you can bring in any dimension in your colors marks card, right? So these are a few ways with which you can go in and create a pie chart, okay? And now let's see what is a donut pie chart all about, okay? And when you would like to create a donut pie chart, we need to have two different pie charts that is combined together, okay? Now why do we call it as a donut pie chart? Because it resembles a donut, okay? I'll just try and visualize. I'll visualize and then let you know. You'll be able to clearly get the point why it is known as a donut pie chart. And in order to do that, we will have to combine two pie charts, and combining two different charts is done with the dual axis option that we have, right? And in order to create a dual axis chart, we need to have two measures, right? Now we will be making use of, let's say, the number of records. Okay, this is an auto-generated field, and we'll be making use of number of records twice in our visualization, and this is just for creating a donut pie chart, right? So because we need two measures to create a donut pie chart, we are going in for this measure called the number of records with an attribute aggregation, right? Which means it cannot be partitioned further, right? Or it cannot be, you cannot partition the data, right? So we'll just quickly look into that. We'll have our number of records and I'll have it as an attribute, right? Then again, we'll have our number of records. You can either go in for a dual axis chart, or you can also change it into a pie, okay? And then go in for a dual axis option, right? Where you can just decrease the size, right? Fine. And my first, I'll just change the color. Okay, why is my color not changing? Right. So I've just changed the color of one of my, number of records, one of my circle, right? And let this be blue in color. And then I'll try increasing the size, or I'll try decreasing the size for the second number of attributes, right? So you just have to first make sure which circle corresponds to which number of records, right? Whichever, I mean, both will be overlapping on each other. So you'll just have to make sure which circle corresponds to which number of records and then make the necessary changes, right? So I'm just decreasing its size. I think this looks better. Now this resembles a donut, right? That is why we basically call it as a donut pie chart. Now let's have, yes. So yes, this resembles a donut, and now let's try adding details to it. Now in my second circle, which is the inner circle, okay, I've just given it to be the same as the background color, just to resemble a donut, okay. I'll just make sure it's my second circle. Yes, now in this second circle, I'm going to place my entire value of sales, okay. And in my outer circle, I can place any dimension, right? For example, I'll bring my categories, place it into the label part, right? And categories, and place it into the colors part, after which you have a separate color that you have given for every category, and you have the entire value of sales. And you can also bring in sales and place it into the label part right next to every category, right? So this is how you create a donut pie chart. Now this is just for visualization purpose that we are making use of number of records. Okay, and this is just another way that you can use to visualize, to represent your data, right? Rather than going in for a normal pie chart, you can just try this out. Okay, and then we have heat maps, right? Now let's see what is a heat map all about, and I'll let you know how to create a calendar, how to visualize a calendar right here in our worksheet. Okay, now basically heat map is a visualization where marks on your chart are represented as colors, right? So as the marks heat up due to the higher values or density of records, a more intense color is displayed, right? I'll just show you. Let's say we have our month of order date. Okay, we have discrete months, and let's say we have our subcategory. So now when both are dimensions, we get a text table by default. Okay, you can just bring in sales in color. Okay, and we'll also have sales in size. Okay, and then we have the mark as circle. Okay, now so you can also increase the size of the circles a little bit, right? So now as the value of sales increases, the intensity of the color in your chart also increases, right? So darker the color, darker the value of sales. Okay, so this is why we call it as a heat map, right? Your marks heat up due to the higher values of whatever your measure is, right? And when it comes to a heat map, you can also decide the color using one measure and decide the size using another measure, right? Let me decide the size by profit, right? So though phones is darker in color, the size is lesser when compared to copiers, right? Which means the size is decided by, the size of the circle is decided by the corresponding profit, and the color, the intensity of the color is decided by the sales, right? So in this heat map, we are making use of two measures. One measure decides the color, and one measure decides the size of the circle that we have in our heat map, right? Now let's see how to create a calendar. Okay, so we'll be making use of this heat map to create a calendar, and for that we need to create a few calculated fields, right? As I told you, we'll be creating, and this will also help you go through, help you understand of what different calculations can be used, right? So this is just for a practice purpose. So let's try creating a calendar. Let's try visualizing a calendar right here in our worksheet. Okay, and for that we'll be making use of a few calculated fields, right? So my first calculated field, in order to create a calendar, we need the week days, we need the week numbers, we need the day numbers, and the month names, and also to which particular year that particular month belongs to, right? So we have quite a lot of things that needs to put up into our, that we need to calculate and fetch out from the data that we have in order to create and visualize a calendar, right? So first, let me fetch the weekday names, okay, which means the weekday names as in Sunday, Monday, and so on, in order to visualize, bring in my calendar. So I'll just call this calculated field as weekday, and I'm going to make use of the date name function, okay? And you have the syntax, and you have the explanation, and you have an example for it, right? So the date part that we are going to fetch is the weekday, okay? And we are going to fetch the weekday names from the field called order date, right? So this is our first calculated field. Okay, I hope it was quite simple. Just click on apply and okay. So we have our weekday. Next, we need the week number, for which we are creating another calculated field. Now, week number. So in year, we have around 53 weeks, right? So in order to clearly display which particular week we are visualizing in our worksheet, we need this week number, okay? And again, we are going to make use of the date name function. We are going to fetch out the week from the order date. Now, when I complete the visualization, you'll clearly be able to understand what is the purpose of every calculated field. We'll also go back to every calculated field and we will try going through it again once we complete the visualization, right? And next, we need to fetch the year to which your the month in your calendar belongs to, right? That is why we are creating a calculated field for year, and we have inbuilt function called year, which simply fetches and displays the year of whatever field that you specify in its inside the year function, right? Just click on apply and okay. So we have our year, we have our week number, and we have our week day. Then we need the name of the different months. Okay, I'll call this as month name. And we are again making use of the date name function. This time we are going to fetch the month part from the order date, right? Click on apply and okay. And finally, we need the different days of our month, right? So that is why we are creating another calculated field called day. We will make use of the date part function. Okay, we are going to fetch the day part from my order date, right? Just click on apply and okay. So now we have our year and day which has been brought under measures. I'll just place it under dimension, okay, because I need discrete values of this calculation, right? So now next we have our year, we have our month, we have the weekdays, week numbers, and the different days of every month, right? Next step is to visualize a calendar using all these calculated fields, right? So first of all, we'll bring our weekdays, place it into columns. So we have all the weekday names right here, okay? And then we have the week numbers that I'm placing into rows, right? So we have around 53 weeks, okay? And then we need to filter out year and month, because I need only one particular month of one particular year calendar to be displayed in my worksheet, right? So that, for that purpose, I'm just showing the filter for month name as well as showing the filter for year, okay? And we will be changing this into a single value drop down, okay? And this also as a single value drop down. You can also have it as a single value list. Just to save the space, I'm going in for a single value drop down, right? In this manner, we are just visualizing only the month of January, which belongs to the year of 2015, right? So this is why we basically made use of our filters, okay? Right. Next, so this is the first week number. When you simply change it into, I would like to say 2017, the month of August, right? So the week number changes accordingly, right? So as a next step, we will bring our day into the text part, okay, where we have the different days, and we do have a few blanks, missing dates in between. And as I told you, this is because the data set that we have been provided with does not contain information regarding this particular date. For example, August 10th of 2017, there was no entry made There's no entry, there's no data available in our data set for this particular date. That is why it has been left blank, right? So as a Tableau developer, we are just visualizing whatever data has been provided to us, right? So these missing values, it doesn't matter. It is again purely based on your data, right? So we are not concerned about that. We are just trying to visualize with whatever data that we have been connected with Tableau, right? So we have our calendar for every month of any year as per your requirement, okay? And then you can just try to color them out. Let's bring weekday into the color marks card, where you have a separate color for every weekday, okay? And you can also change the mark to square, right? After which you have a square right next to every day number. And under the label marks card, you have an option called alignment. I'll change it into center aligned so that they are placed right in center of my box, of my square, okay? And next, you can just increase the size of your square. Let me just, yes, you can increase the size of your square, and then you can change the font color to black. You can make it bold, right? So all these colors are purely depending on your requirement. Okay, however you would like to visualize it, you can just go in for that, right? And you can increase or decrease the size. You can edit the label, your size, your font, your color, okay? And you can also edit colors, okay? You can change the colors as per your requirement, right? So this is how you display a calendar, okay? You bring a calendar right here into your worksheet, okay? You can just say, I would like to view the calendar for the year 2016 and the month of December, right? So you have a perfect calendar that has been visualized, that has been brought right here in your worksheet with just a few simple calculated fields that we created. One to fetch the weekdays, the weekday names, to fetch the week numbers, right? The year to which it belongs to, the month to which this particular calendar belongs to, and finally the days that we have simply placed into the text part, right? So after which we have just enhanced our visualization, okay? And as I told you, we can also have it as a single value list, okay? With such radio buttons, you can simply try using this as well, okay? And when you go in for all, you have all the different months of all the different years that has been brought into visualization, right? So this is just a calendar that we have created, and using a few calculated fields, Tableau, right? So this was about creating a calendar with Tableau, right? So what's the real-time scenario for calendar, right? So you might want to have one sheet which is exclusively meant for calendar. So when you go in for dashboards, when you have multiple sheets, you can have a parameter, right, where you're allowing the user to simply choose a year, or you can have such interactive filters, right, where the user will choose a particular year and month whose corresponding data is displayed. And you can also have one sheet which displays this calendar so that the user can easily identify which, what are the missing dates, and anything regarding the calendar of that particular month, right? So this is just for your convenience. Again, if you would like to include this in your dashboard for additional information, then you can just go ahead with that, right? So this was basically just how to visualize your calendar and real-time scenario, in the sense, again, as I told you, it totally depends on your whatever data you're trying to visualize and whatever is your real-time scenario. If you are in need of it, if you would like to given a calendar, given a worksheet for a calendar as such, you can just go ahead with that, right? So yes, and the difference between a heat map and a tree map. Now, heat map, as I told you, it the the colors, your map, your chart itself, the colors in your chart gets the intensity depending upon the value of your measure, right? Whereas when it comes to a tree map, it occupies the entire space in your worksheet. You have the structure, which is decided by the dimension, and the size of your structure, the size of your box, your square or rectangle, the size is decided by the measure, right? So both are completely different. They are not the same, right? So these are just different ways by which you can visualize your data, right? So whichever type of chart you feel is appropriate for visualizing the data or analysis that you have made, you can just go ahead with that. We also have something called waterfall chart, and we have, I think, some 2 or more 3 types of charts that can be discussed about. We have something called as a motion chart, right? So we'll just look into that. And when it comes to real-time scenario, it is all up to you to decide which chart will be appropriate, okay, in order to visualize your analysis, your data that you have made with the data that you have been connected with Tableau, right? So I'm just telling you, these are the different options that you can make use of, right? And it is all up to you to decide which will be appropriate for your requirement and for your analysis of your data, right? So I hope you're able to get what I'm trying to say, all right? Waterfall chart, it is just effective for dashboards, right? And for displaying the effect of positive and negative values, right? Now let's say, for example, how sales or profit goes from one place to another, like a waterfall, right? So that is why we call it as a waterfall chart. And let's say, for example, we have subcategories and we have the corresponding sales, right? And in our marks shelf, I'm going to make use of the Gantt bar, okay? And then sort it out in descending order. And we will just make use of this measure in the size as well as in the colors marks card, right? So this just resembles a waterfall, just tells of how your sales moves from one subcategory to another, okay? And this is just another way by which you can visualize your data, right? And we also have funnel charts, okay, that you can create using Tableau. Now these are a few types that is not readily available under Show Me, okay? Under funnel chart, we have a basic funnel chart and we have something called as an advanced funnel chart, right? So with funnel chart, you can just represent, let's say, your measure at different stages or sectors, right? Now let's see how to create a basic funnel chart. I'll have my sales, okay? And I'm going to make use of this segment in the size marks card, okay? And then I'm going to make use of the segment in my colors marks card. I'm just coloring out the entire value of sales depending upon these 3 segments in my dimension, okay? And size is going to be decided by the measure, okay? And I'll just make it into an entire view. And here we have our basic funnel chart, right? And you can simply label them. Let's have the different segments, their corresponding sales. And here in this sum of sales, you can apply a quick table calculation of percent of total, right? So with this type of a visualization, the audience will clearly be able to understand, right, the sales value of which segment is higher, is more when compared to the other segments, and what is the contribution of this particular segment to the total value of sales in terms of percentage, right? So this is how you go in for a basic funnel chart. So first I had my sales in the view, then I just colored it out using any of my dimension, okay? And then I brought in the measure to decide the size of every segment, right? And then we have our funnel chart. You can just make use of any measure, any dimension, and go ahead and create such a funnel chart, okay? And let's see what is the advanced funnel chart all about. Now for this, let's make use of the ship mode. I have the different ship modes, and let's have the corresponding sales, right? And in my marks card, I'm going to go in for my area. I'll just swap this up and I'll have it as an entire view. Okay, we'll sort it out in descending order. So now this is the different ship modes and their corresponding sales value that has been plotted out in our graph, right? And it is an area mark card that we have used. Okay, now this resembles half of our funnel, right? This just looks like half of our funnel. Now just for visualization purpose, just to bring in the image of an entire funnel in our worksheet, we are going to make use of a simple calculated field, right? Now this is displaying the positive of sales, the positive sales values, right? Now when I create a simple calculated field, I'll just say negative of sales, right? Just click on apply and OK. Bring this calculation, place it right before the actual sum of sales. And then you have the mirror image, the symmetric part, the left side of our funnel that has been brought into visualization, right? So now this looks like a complete funnel. As I told you, this negative of sales, the calculated field that we have created, is just for visualization purpose. Okay, just to complete the image of a funnel, we are making use of this calculated field, right? Now when it comes to enhancing the visualization, I'll go into the sum of calculation, which is nothing but this left part of my funnel. I can change the color of it, okay, and I'll label it using the different ship modes. Okay,
Just a quick info, guys. Intellipaat provides Tableau online training and certification course mentored by industry experts. The course link of which is given in the description below. Now, let's continue with the session. Just a quick info, guys. Test your knowledge of Tableau by answering this question. What are the components of a dashboard? A. Horizontal. B. Vertical. C. Image extract. D. All of the above. Comment your answer in the comment section below. Subscribe to Intellipaat to know the right answer. Now, let's continue with the session.
my requirement, right? So this is how you create an advanced funnel chart. Okay, and this mirror image or the left part of our funnel chart has been created using the negative value of whatever measure with which the right side funnel has been plotted out. Okay, and this is just to complete the image of a funnel. Just for visualization purpose, we have created this calculation, right? So this was all about an advanced funnel chart. And finally, we look into what is a motion chart, right? Now, as the name tells you, your chart appears as if it is in motion, right? So that is why it is moving. That is why we call it as a motion chart. And we've already gone through the filter shelf, and we are, going through the marks shelf then and there. We are making use of the different marks cards. We've also gone through what is a column shelf and a row shelf. Now we have this page shelf, right? So we'll be making use of this page shelf to create motion charts. Okay, and let me say, for example, if I'm using region and if I'm placing it in my page shelf, okay, there's a separate page that gets created for every member of my dimension called region, right? So under region, I have four different: central, east, south, and west, right? So when I make use of these options, I have a separate page that has been created for every single region, right? When you make use of these arrows, we have this page is for central, this is for south, and finally we have a page for west. So every member, every value of this dimension will have a separate page that gets created. Okay, and let's say, for example, I'm bringing in my order date. Okay, and then I'm bringing in the order date in terms of let's say month. Okay, and the corresponding sales. Okay, Now, if I make use of these arrows, you have a separate line graph that is plotted for every year, right? So you have this dimension called order date that has been placed into a page shelf. It has 4 different values: 2015, 2016, 17, and 18. So every year has been allotted a separate page, okay, that you can go through using these options, right? So we'll just go back to our first page, which is 2015, right? You can toggle between these pages using this drop down arrow, or you can make use of these arrow marks right next to them, or this slider with which you can just toggle between these years, right? And you have this option called playback, play, and you have stop option. And you also have 1 horizontal bar, 2 horizontal bar, and 3 horizontal bars. Now this is the speed in which your chart will move, okay? Your pages will move one after the other. And this is the slowest of all, this is the normal speed, this is the fastest of all, right? Now when I go in for the slowest speed, okay, when I click on this play option, you just have to make a note over here. We had our 2015, next comes the 2016, then comes 2017, and then comes 2018, right? So once you click on this play button, automatically the pages start appearing one after the other, okay, depending on whatever speed you have wanted your pages to move in, right? If I go in for a normal speed, when I click on play option, now this is a little faster. Okay, now this is how your different years, whatever data is present, whatever chart is present for every year of this particular dimension will be appeared as if your chart is in motion, right? And you can also look into the fastest of all. This is going to be too quick, right? You can just make a look, you can just note this part over here, which tells you which year this particular page or line graph corresponds to, right? Now, when I click on play button, you just have to make a note on this year. Now I'll click on play, and as I told you, it was too quick, right? Of how the line moves from one year to another, right? Your pages are moved, are your pages appear one after the other, okay, of whichever dimension you have placed in your page shelf, right? Now you can also go in for a continuous month, right? When you go in for a continuous month, let's say I'll go in for a normal speed, and here you have the line graph for the first year, second year, third year, and the final year. This is how your chart moves, right? So depending upon whether it is a discrete date field or a continuous date field, you can move, you can display this motion chart, okay? And this option called show history, right? Now, when you click on play button, we have quite a lot of options on show history, right? For example, let's say I would like to highlight, I would like to show the history for all the marks, okay? And you can just format the amount of fade or the formatting color, okay? And now when I click, now as you notice, you have a faded history, a faded line chart for the past years, for the history, right? So we have shown history with a particular amount of fade, okay, for the previous years. So which means when I click on play option, we have the first year, second year, third year, and the final year with the history, with the past years whose line graphs is faded in nature, right? So this was about how to show the history. And when it comes to marks, trails, or both, this is right now unavailable, right? Only when you choose the circle mark from your marks card, you will be able to select trails or both, right? If I say show only marks, when I click on play button, only the plots will be highlighted in history, okay? If I say show trails, right, this is how it appears, okay, as of from where the start, the how the starting of this, and you know what is the trail between, you know, between these different line graphs of these different years, right? Now if I say show both, okay, and you can decide your color, your trail format, whether it should be a dotted line with this thickness or this color. These are the formatting options. Now when I click on play button, right, now this is how it appears, right? So you are just showing your history. Okay, you can also show it only for the last, let's say, 2 months, right? And you can show marks, you can have separate color. Okay, so it is all up to you, right? So for only for the previous 2 years, you are displaying your history, right? So yeah, so basically your chart appears to be in motion, and that is why we call this as a motion chart. Okay, so any dimension that you place in your page shelf will, every member of that particular dimension will be allotted a separate page. As we also went through region, you can also have categories, right? So for every category, you will have a separate page that gets created, and you can create any bar chart or any type of chart over here in the worksheet, in the workspace, which will be available only for this type of category. And you can make use of these play options, the speed options. You can also customize. When you click on this drop down arrow right next to your title called category, you can either remove the title, you can edit your title, whatever it is supposed to be. You can customize it, which means you can, for example, remove the slider, okay? Or you can also remove the playback controls. You can remove history controls. You can also remove the page readout, or you can bring them back, bring the slider back, right? So these are a few options that you can customize of how your page shelf option, your page, your motion chart options should appear in your worksheet, right? So this was about a motion chart. It appears as if your chart is in movement, is in motion, right? And that is why we call it as a motion chart. Okay, so we have just gone through all the different types of charts and graphs that can be created with Tableau. Okay.
And this quickly brings us to the roles and responsibilities of a Tableau developer. There are lots of roles basically when it comes to Tableau, and the most important thing that you need to know is that it is basically well suited to the people who really like problem solving skills. They want to be a team player, and they know how to manage their time very effectively. And this is done to ensure that they all meet their timelines and keep to the projected schedules as well, guys. So there are more than 5 roles which Tableau developer can assume, but the 3 main ones which the companies are hiring for on a constant always are Tableau developer, analytics engineer, and a business intelligence architect, guys. So you can be called as a Tableau developer, an analytics engineer, or a business intelligence architect if you are a certified Tableau expert, and if you pretty much have good experience working on with Tableau, or that you want to learn, and after learning, mastering the concepts and having a certificate, you can pretty much exploit all of these designation, guys. So coming to responsibilities, the most important responsibility in my opinion is the first point, because again, you need to develop, you need to maintain, and you need to manage advanced reporting, guys. It's not just basic XY axis and put some graphs. You just saw what the analytics looks like. So you need to manage advanced reporting, you need to do very good dashboarding, and you need to provide other business intelligence solutions at the same time. And then you need to be performing very good data analysis, you need to document whatever you're doing, you need to provide validation to the data that's being processed, and you need to know how you can design and map these data and convert it from raw data into good information as well. And the third point is pretty much you need to be on the roll, you need to be a runner when it comes to this, because you need to review and improve all their existing systems. You need to collaborate with brand new teams, brand new people, lots of teams, to basically integrate all of these new systems in case they're using any legacy or old applications, guys. And then after this, you need to conduct a lot of tests, because again, unit testing is something very important when it comes to Tableau. And then you'll be developing very good amount of database queries, because you need to know how these affect your visualizations, right? So basically, you'll analyze whatever the effects that your dashboarding brings about, and then if there are any issues with that, you can troubleshoot the same, fix it, test it again, and do all this again. So The last point is again creating amazing tools to store data within the organization, because again everything from storing data, managing data, analyzing data, and putting out dashboards, you as a Tableau developer will be responsible for all of these guys. And this quickly brings us to the skills of a Tableau developer. There are three major skills of a Tableau developer that are considered very important: programming skills, statistical skills, and data handling, guys. And I'm sorry, coming to programming skills again, having very good statistical programming languages and having knowledge in them, like Python and R is a very good skill. And at the same time, knowing a statistical language is not as important when it comes to if you cannot make it talk to data. So having a good database querying language and knowing something like SQL is a great start as well. And having very good mathematical skills, very good understanding of statistics is a must. And being familiar with mathematical testing, statistical testing, distribution testing, maximum likelihood estimators is also a requirement, guys. And this basically will help you achieve better analytics. And guys, do not be overwhelmed by the skills that you need to become a Tableau developer. Again, you will be trained on all of these, and after being trained, all of these will look very simple to you, because at the end of the day, if you're training with a good certification program, it will make you an expert in all of the skills that's being shown on your screen right now. And then coming to data handling again, you need to understand the data you're working with. You need to wrangle through the data and see how it works, because if the data can be exploited in a good way, it can pretty much give you great analytics, and you can drive all of your models, whatever business requirements you have, through a success, guys. And after this, again, as I've been telling, data is very unruly, data is raw, and it needs to be refined all the time. And making sure that you're using the refined data to give visualizations are very important as well. And knowing data management techniques are very good, and they form a very vital requirement as well, guys. And this brings us to the average salary of a Tableau developer. I've broken it down into two terms in the United States of America and in the subcontinent of India, guys. So a junior Tableau developer in the USA gets somewhere around $75,500 annually, and in India gets a junior Tableau developer gets somewhere around 7 lakhs per annum. And then coming to a senior Tableau developer with some amount of experience, very good certification, and great knowledge, gets a package of somewhere around $105,000 in America and 17 lakhs per annum in India, guys. So these are average numbers, and there is no hard and fast rule that you will get these numbers. Again, you can get 15 lakhs per annum for a junior developer, 25 lakhs per annum for a senior developer as well, guys. It all depends on your skill. It all depends on how good you are, because companies these days don't mind paying a lot if they know you are good at what you do and you bring a lot to the table, guys. Irrespective of where you are, irrespective of what money you ask for, if you're damn good at your job and if you are certified, and people know you're hiring, people know that you have put in some work to understand the data and you can drive their business to success, they are ready to pay lots more amount, guys. So this quickly brings me to the learning path of a Tableau developer. Well, the most simple way that you need to go about learning Tableau is, again, first you need to understand the basic W's of data analysis, guys. Why, what, when, who, and so much more. All the questions which start with W will be your first starting point of data analysis. And after that, you will be learning the basics of mathematics and statistics. And after this, you'll be learning all the data blending techniques, where you'll be understanding data, churning through data, and figuring it out. And after all of these, you'll be working with data hands-on by learning a couple of database technologies, querying, SQL, and so much more. And after that, finally, you'll be using all of the 4 skills you've learned previously, all the routes that you have taken to come there, to visualize all these data, to create reports, dashboards, and to go on to become a certified and pretty much a very good Tableau developer as well, guys.
Now, moving on to what exactly is Power BI. So it is a business analytics tool which was developed by Microsoft in 2013. It is generally used for interactive data visualizations and business intelligence. It provides an interface which is easy and simple to understand and work with. End users can create their own dashboards and reports using Power BI. Right. Now, as we've discussed about these tools in a brief, now let us discuss about the data visualization in both of them. Right. So first and foremost, let us understand what exactly is data visualization, guys. So data visualization is nothing but representing the particular data in the forms of charts, diagrams, graphs, and so on. Instead of going through the reports which are made up of complex and large amount of data, you can just use graphs, diagrams, charts, etc. That is, as they will be more convenient for the users to understand, isn't it? Which BI tool you should choose for data visualization? Well, it depends. If you're looking for a data visualization tool for customized data visualization, then you can go with Power BI, as you can drag and drop into the visualization through a sidebar and you can import the data as well, right? It also has opened up software development kit, which helps to convert data from various data sources into interactive reports and dashboards. Whereas when it comes to data visualizations using Tableau, then it is majorly used for pure visualization. Like if you're looking for more organized and clean approach, then you can choose Tableau. In this, data visualizations are created in the form of worksheets or dashboards. Right. Tableau provides connections to multiple different sets of data sources, and it is majorly used for larger sets of data visualization in an organization. So it has additional drill down features also. Now let us move forward and discuss about few of the parameters based on which we will differentiate between both of these tools. So the first parameter that we have is performance here. So guys, in Tableau it can handle large amount of data from different data sources with better performance, whereas Power BI can only handle a limited amount of data here. Second parameter is the source of data. Power BI has limited access to the other servers and databases as compared to Tableau. For example, Oracle databases, PostgreSQL database, SQL Server database, SAP HANA database, and so on. Whereas in case of Tableau, it has got access to multiple number of different servers and database sources such as text file, JSON file, PDF file, Excel, statistical files, Microsoft SQL Server, MySQL, and Oracle, Redshift, and the list goes on. Right. Now, in the third point we have is the difficulty level of learning or learning curve. So guys, in Power BI, it is comparatively easier to learn as compared to Tableau. Even if we see from the learner's point of perspective or the business point of perspective, Power BI is comparatively easy to understand as well as easy to learn. I'm not saying that Tableau is very much difficult to learn or understand, but Power BI is comparatively a little more precise when it comes to such kind of terminologies, right? So now if we talk about its data capability, so guys, in Power BI, each group or workspace can handle up to 10 GB of data, and more than 10 GB of data are supposed to be in cloud or Azure, I would say, right? But if it is in local database, then Power BI just pulls the data and does not import them. But in case of Tableau, it works on columnar based structure, that is, it only allows to store unique values for every column, and that is how it is possible to fetch billions of records or rows in this. Right. Now moving towards our fifth parameter, which is integration. So with integration, in case of Power BI, you can easily integrate with different data sources like SharePoint, Azure, Power Flow, Power Apps, 365, Excel, and many other Microsoft products. Whereas Tableau is used for more scalable approach here with different outsourcing tools as well, even including all of these Microsoft based tools as well as outsource based tools also, right? And the sixth parameter is about the data shaping. So guys, Power BI offers query editor which allows its users to do many things in an easier manner, and it is more flexible. It also offers self-documenting and other features as well, whereas Tableau does not offer any of these kinds of services. Now the seventh parameter that we have is the data modeling. Power BI provides Power Pivot DAX which are more accessible to the users, whereas Tableau does not provide any of them. Finally, we have application. So guys, Power BI is used for dashboards, custom visuals, and more like open source approaches. But Tableau is used for longer run operations and ad hoc analysis. As we have discussed about the parameters, now let us head towards the pricing part. So guys, when it comes to pricing, then Power BI is more affordable option as compared to Tableau, because Power BI offers 3 subscription tiers, that is Desktop, Pro, and Premium. Desktop cost is not chargeable for its users, and Pro cost starts as $9.99 per user per month. Pro also offers 60 days of free trial, and in this, server cost, web user cost, etc. is lesser. And the premium plan starts at $4,995 per user per month as per the storage resource.
Just a quick info, guys. Intellipaat provides Tableau online training and certification course mentored by industry experts. The course link of which is given in the description below. Now, let's continue with the session.
$35 per user per month, and Tableau viewer cost starts at $12 per user per month, which is a bit higher as compared to Power BI. So if you look at it from the initial cost perspective, then Power BI is way cheaper as compared to Tableau. But for longer run, that is total usage cost per year is lesser in Tableau. So guys, after knowing about pricing, let us differentiate them based on some of the functionalities of both Tableau and Power BI. First, we have in the functionalities is the support level. So guys, in Power BI, customer support is limited for users for free BI account, and it offers robust support resources and documentation, whereas Tableau offers comprehensive knowledge-based support for its users. Now, if we talk about licensing, then Power BI has rigid licensing, whereas Tableau has flexible licensing. And in case of infrastructure, Power BI has SaaS or software as a service infrastructure, whereas Tableau has a flexible infrastructure here. And when it comes to scalability, for larger dataset, Power BI has good scalability, whereas Tableau has much better scalability for larger datasets as compared to Power BI.
So, coming to the first question on the top Tableau interview question said, the first question usually goes with a comparison question because it is vital that you understand the differences. For example, the question states, compare ClickView with Tableau. I'm sure you already know that both of these are amazing business intelligence tools that you can work with very easily, and each of them have their own niche applications, right? So let's check out the differences. So whenever we talk about data integrations in terms of capability with Tableau and QuickView, Tableau has an edge over QuickView in this particular sense. And then whenever you're working with multidimensional data as well, Tableau has the capability to handle it that much better, efficiently and faster. And of course, most of us work with PowerPoints as well. So whenever you have a lot of work with PowerPoints, dashboarding on that and creating good amount of visualizations and insights on that is great, especially if you have the support for PowerPoint, right? The native support, and Tableau does that, while ClickView is a little bit held back in this regard. And then when we talk about scalability and visual drill down as well, right? In terms of visual drill down, yes, ClickView is amazing to work with and it provides good amount of efficiency, so you don't have to do a lot to have a big impact on the output. But then when you talk about scalability, right? Scalability, Tableau, there is no beating Tableau out here, because ClickView has a direct limitation applied because of the ability of it to maximize its usage of RAM, while with respect to Tableau, right? So it can scale, and RAM is not a limiting factor out here. So this is the basic comparison that you can state to the interviewer whenever you ask the comparison between ClickView and Tableau. And now, when we come to the second question, it states, how is the context filter different from all of the other filters? So one thing you always have to know is that whenever you create a context filter, right, what Tableau does for you is that Tableau will create a temporary table just for this particular filter. So when you create a context filter, Tableau will create one temporary table just for this particular filter set, and every other filter will get applied on the context filter, guys. So every other filter will get applied on the context filter as if it was cascading parameters, right? Pretty simple and straightforward. But then when you have created an actual context filter, let's say on an example such as countries, USA and India, what Tableau will do is Tableau will create a temporary table for both of these countries and all the data that goes into these particular countries as well. And let's say now if you have any other filters that have to be applied, and if you do not have any context filter, right, and every single record will actually be checked for filters and then applied if required. So if you have a context filter, make sure to mention about Tableau being able to create the temporary table and then mapping the data based on it, and later applying all of the context filter data on top of it. Now, moving on to question 3. Question 3 is again another follow-up question. It's regarding context filters itself. So the interviewer may ask, what is the disadvantage of making use of context filters?
Well, the context filter is an entity that is actually not changed a lot around by the user, right? So what happens is, if you have to change these context filters, then in the backend the database has to be reamped, it has to be recomputed entirely, and whatever temporary table has been created during your first set of filters will be removed. It'll have to be rewritten, and all of these takes a lot of time, effort, and computation power as well. So at the end of the day, it's all about slowing down performance if you have to change your context filter. And then whenever we are adding dimensions to context, right, what Tableau does, we already know this, is that it creates a temporary table. And one disadvantage with creating a temporary table is that every time we initiate a view, or every time we instantiate a view option, or check the output, so what usually happens with this is that since it's creating this temporary table, it will reload it every time. So creation of a temporary table leads to a lot of reloads as well. And one more important thing you have to know is that whenever we're working with tools like Microsoft Excel and Access, or let's say any other general, text data sources, right? So the temporary table that gets created actually gets created in the Microsoft Access table format. This can be a disadvantage if you cannot scale this into other tools, in case if you have any down the pipeline as well. And then of course, whenever you're working with SQL Server, let's say Oracle data sources, or even MySQL, you must have the explicit permission to create that temporary table on the server itself. So having these access parameters and having these permissions is very vital too. So the talk is not always about a single dimensional data, right? So whenever we talk about multi-dimensional data sources, temporary tables usually are not created for this, and context filters are basically defined through which an understanding on what filters are independent, what filters are dependent, and then later mapped and put into place. So since temporary tables here are not being created, and since you're basing it on the fact that it is either independent or non-independent, this might again take a little bit of hit as well. So these form to be some of the disadvantages of making use of context filters. Now, question number 3 states, what are the 5 main products that are offered by Tableau? Well, this is something you really should know as a person interviewing for a Tableau developer interview or any of the similar roles. So make sure to mention all 5 of these products. We have Tableau Desktop, we have Tableau Server, we have Tableau Online, we have Tableau Reader, and we have Tableau Public. With this, we can check out the next question, the 5th question, that says, what is the latest version of Tableau Desktop? Now, this is a very tricky question, and it's asked in a lot of Tableau interviews, is what we've seen. And this is only done to make sure that you are up to date with the latest version of the tool, that you understand all of the change logs of what Tableau is changing around, right? See, Tableau, after it came out, it has had a huge number of changes. It's become very efficient now, it's become very beautiful, very easy to use, and all of that. Alongside this, there have been a lot of changes as well. So what the interviewer expects with this question is to check if you are up to date on their website, to check out all of their latest offerings, to make the full use out of it for your business intelligence solution as well. So as of September 2020, when we're recording this particular video, their latest version of Tableau Desktop is version 2020.3. That's March 2020. Well, moving on to the 6th question, it says, what is data visualization? Now guys, data visualization, business intelligence, all of these are key questions that are asked in Tableau interviews, so make sure to pay attention, right? So whenever you speak about data visualization, you can talk about what it is, right? So what we usually do is we have data either in a structured or an unstructured format. It can be in a presentation, it can be in an Excel sheet, or it might come from a variety of different sources. So instead of looking at an Excel sheet which has probably 100,000 entries, we create beautiful looking dashboards through which we can gain some insight, which would have been very difficult to do with the naked eye unless we had this visualization, right? So that's the basic aspect of data visualization. You can have multiple graphics, you can have complex looking animations, and you can have aesthetically very pleasing to look at graphs as well. So this will help, especially whenever you have to pitch a product to a person who is not from a technical background, or let's say if you have to explain a concept to your juniors, or even in a business meeting where a lot of graphs will make more sense rather than an Excel sheet with 100,000 entries, right? So you can use an approach like this to answer this question. Now, moving on to the seventh question, it states why Tableau? So, the interviewer here is again trying to find out why and what is your inclination with making use of Tableau and where it shines. So, you can talk about all of the advantages of Tableau, and two of the most important concepts that you have to talk about is about data sharing and how you can analyze it, and later it's about creating views and the ability to share it. Let's walk over with the first one. So let's say you have data from multiple sources, right? You might have a server on premise as well. You might have a database in that server, or let's say a database on the cloud, a data warehousing solution, a cloud application, or an Excel file, or a PPT file, whatever it is. With Tableau, you can analyze this very easily without having to put much effort. This is point number one. And then point number two, you can state is that, so it doesn't end with you creating beautiful looking visuals, dashboards and all of that. At the end of the day, you have to have the ability to easily share it across your team, across the floor, to make sure that people in your team and people from a variety of other teams can access to this, right? So you can have the sales team look at the data, you can have your data analytics team understand the data, you can have your data engineering team in fact come look at the data as well. So your ability to easily share this data, blend it and merge it with other data, and one important thing is to keep it up to date automatically, right? So all of these can be done very easily with the help of Tableau, guys.
Just a quick info, guys. Test your knowledge of Tableau by answering this question. What are the components of a dashboard? A. Horizontal. B. Vertical. C. Image extract. D. All of the above. Comment your answer in the comment section below. Subscribe to Intellipaat to know the right answer. Now, let's continue with the session.
So with this, we can check out the eighth question that states what are filters and how many types of filters are there in Tableau. A filter, as the name suggests, is used to funnel data. So what are we funneling out here? So let's say we have 10 rows of data in an Excel sheet and we only want to see the data from one particular person, or let's say of one particular criteria. Let's say if you have the student details of a particular college, we want to filter them by name. You usually filter them by age. Let's say you want to pick up all the people, all the students in the college of the age 23 years. So applying a filter will make sure that the backend will run and it will only show you results of these students who are of age 23, right? So we're trying to prevent unnecessary data in that context, and we're trying to only see what it is that we exactly require and then work with that. So for this follow-up question which states how many types of filters are there are three types of filters, and we already checked out one, right? So there's quick filters, there's context filters, and there's data source filters. So make sure to mention all of these when this question is asked. Now, moving on to question number 9, it says how to remove the show all option from a Tableau auto filter. See, again, this is a question that is asked to see your proficiency in terms of handling the tool, even though you might not be sitting in front of the tool right now, right? So when you think about it, answer this question in a very simple way, in a very straightforward way. It's a very straightforward question with a very simple answer. So to remove the show all option, right? So all you have to do is right click on the filter, click on the customize button, and it's a simple check on the show all button, and this ensures that the option is actually, and this ensures that and then after you uncheck all of this, right, this makes sure that your option is removed. So since you're sitting in front of the interview, even though you might have a laptop, that's it is an added bonus that you first verbally say out the answer, and then of course you can run Tableau desktop on your machine right then and there, and then show all of these practically to the interviewer as well. So make sure to keep that in mind. So moving on to the 10th question, it states, can we use non-used columns, as in the columns that are not used in the reports but that are present and used in the data sources in actual Tableau filter? So can we use non-used columns in Tableau filters? The answer is a very straightforward yes, right? So think about an example when you're approaching with this. So if you have a data source where you have employee data, right? So you can have employee ID, employee name, the department, designation, salary, and all of it. And let's say now we have reports where we only using employee name and employee salary, right? So what you can actually do is you can apply So you can apply filters on employee designation even though you have not used these reports from the data source, right? So it is very simple, it is very straightforward, and yes, it is achievable. We can make use of non-used columns, but then it has to be used in the data source, but then it really doesn't have to be used in the reports, guys. So moving on to the 11th question, it states, what is the benefit of Tableau extract file over the live connection? Well, when you think about Tableau extract file, right? So extract can be used anywhere without having to create a connection. That's the biggest advantage of it. So you can create your own custom visualizations without even having to connect to a database prior as well. So this is the ability provided by the Tableau extract file, where you can pull in all the data and work with it without even having to connect with that particular database as well. Now with this, moving on to the 12th question, it states, what is the difference between TWB and TWBX file extensions? Please explain. Well, one thing you have to understand is that whenever we talk about TWB, right, the Tableau workbook files, it is a live connection. It points directly to the data source, and whenever the user is receiving a TWB file, he or she needs permission to access the data source. And with a TWB data file, no data is included prior as well. So it's a live connection. It points to the data source, and you need permission to access the data source, and initially there is no data that comes included with the file as well. Now, whenever you talk about TWBX file extensions, right, here what we're actually trying to do is we take the data offline and we store it on the local machine. So be it in a package, be it in a zip file, or any other packaging files, where we completely remove this kind of dependency of having to need the permissions and having to have these access protocols in case if you do not have all of that as well. So TWB files require permissions from the data source, but then TWBX is all about bringing the data offline, keeping it in the native place, and to make sure that you avoid the need for permission as well. Now with this, we can check out the 13th question that says, what is the maximum number of tables we can join in Tableau? So this is a very commonly asked question, and you are supposed to know the answer to this, guys. It's a very straightforward answer. So in Tableau, we can have a maximum of 32 tables that we can join at a time, and no, it is not possible to combine more than 32 tables in a very straightforward way either. So make sure to answer this in a clear and a concise way. Now with this, moving on to the next question, it states, what are dimensions and facts? Again, it's a very simple example, but it always adds a lot of value if you can explain it with an example, right? So dimensions are nothing but the text columns where we are describing what the actual data is pertaining to that column, right? So you can have a product name, you can have the name of a city, and a lot of other things. So dimension is nothing but the simple description of what data we are trying to pull in from that particular column. And then when you talk about facts, right, facts are the actual measures of data that you might have in that particular data set. So whenever you think about facts, think about numerical values, right? So you can have a profit percentage, you can have the profit in, of course, in monetary value, you can have the sales figures, you can have the sales in that particular monetary value as well, and a lot of other things. So when you think about dimensions and facts, it's a pretty simple concept. Now, moving on to the 15th question, it states, can we place an Excel file in a shared location and use it to develop a report and refresh it in regular intervals? What the interviewer is trying to ask is to see if you've had the experience of doing this. So let's say if you had the data source, an Excel file, and if you had to place it in a shared location, could you actually use that right from there directly to create a report and then, refresh it as and when you require? The answer to this is yes. Tableau is an amazing tool. It's very powerful to use, and yes, it can be done in a very simple way as well. But then if you have a requirement for better performance, right, it is always vital to extract it, bring it to your machine, use it locally, and then work with it. But then if your criteria doesn't really have to do much with having the best performance possible, then yes, it is possible to work with a shared location file and to develop a report and later update it as and when you require as well. Now, moving to the 16th question, it states, what is the difference between a heat map and a tree map in Tableau? Well, guys, a heat map is one of the things that you really have to know, and I'm sure you guys would have used a tree map or even a heat map for that particular instance in your journey of learning Tableau as well. So a heat map is nothing but a very simple way where you can categorize the data in that particular data set by making use of variety of options of, let's say, sizing, or let's say even by making use of a variety of colors color as well. So why do we do this is to make sure we differentiate it from one entity to the other, right? So you can map and check all of the orange color looking entities on your screen right now. You can try to differentiate and compare all of the black colored entities. So you can try to compare all of the black colored entries to another colored entry as well, right? So using colors and sizes is an amazing way, and it can be done using a heat map. But then now when you're talking about a tree map is far more powerful than a heat map, because here we're trying to have a hierarchy. So here we're trying to have a structure which is very similar to a tree data structure, and here we're trying to, so not only are we trying to visualize a part of the relationship here, what we're trying to do actually is in a very simple way denote the entire relationship that exists between entries for our particular workbook as well. So as you can see on your screen, you have the states of United States. So you have all the state names of the United States of America, and you can map it based on color as well. You can map it based on size, and eventually you have a hierarchical tree structure through which you have mapped it, and the node structure goes on and on, very similar to a tree structure. Now moving on to the 17th question, it states, what is balanced access? Well, in a balanced axis, what happens is that there are multiple measures that are actually shown on a single axis, and all of the marks that are shown, right, it's all done in a single pane as well. So to do this, all you have to do is you have to first drag a dimension into a column, and after you have dragged the dimension, all you have to do is drag the first measure and drag the second measure, but this time not to a different axis but then to an existing axis, right? So you can see the simple difference between the second and the third point, and this is what that makes a blended axis what it is. So dragging a dimension, dragging the first measure into the column, and dragging the second measure onto the existing axis rather than a new one. So this is all about blended axis. Now when you think about the 18th question, here is another very fun question which again is asked a lot. So what makes Tableau stand out from all of the other tools, right? So whenever we talk about business intelligence, whenever we talk about all of these tools, they are fantastic to use. I'm sure all of the developers who have went into creating all of these tools have taken a lot of time, pain and effort to make it very easy for us to use, right? So thinking about that, all of the other BI tools are extremely pricey and can get out of hand if you're a small company. But then what Tableau does that's very different from most of the other people is that they have a free offering, right? So Tableau Public is free, and it has an academic distribution in case if you're a college student and you want to learn and work with Tableau as well. So having this option to use it for free definitely is a standout point. And then when you think about how well recognized Tableau is, all of the big firms make use of a business intelligence tool in one way or another, right? Right from the startups to all the trillion-dollar businesses out there. Tableau in fact is also well recognized by very big firms such as Forrester Research, and it's considered to be one of the most easy to use product as of now, and one of the most agile products available as well. So it's not only just this, right? See, there are other BI tools which can do a lot of things more, in a substantial way than what Tableau can do. Tableau is just a data visualization tool, but then you can have and do a lot of things. But then you can have a lot of other tools which have a complete technology stack that they bring along as well, right? So considering that, you will have to make use of these other products along with Tableau. Let's say if you have enterprise grade data to perform ETL, maintenance, data storage, and all of that as well. So in that regard, definitely it is one of the vital points to mention of why Tableau stands out the way it does. Moving on to the 19th question, it states, how do we do data testing in Tableau? This is a tricky question, and I've put in a lot of tricky questions for this particular presentation as well. So make sure you pay attention throughout. Now, how can we do data testing in Tableau, right? When you think about it, data testing is not possible in Tableau because Tableau is a data visualization tool and it is not a testing tool such as Selenium or something. So make sure to answer it and do not be confused. The interviewer may be trying to see if you get confused with concepts such as this. So it's a very straightforward no. Tableau is used for data visualization. Tableau cannot perform data testing, but of course it is one of the best tools out there for data visualization today, especially when you have data which is already pre-processed or data which is already structured, and you can work with it easily as well. But still, it doesn't add a lot of value in terms of data testing as well. Now with this, coming to the 20th question, it states, can you get values from two different sources as a single input into our parameter? The answer is no. Tableau currently actually does not support multi-valued parameter, right? So, there's actually a technique which is called as the dynamic parameter with a blend technique that can be used to highlight every single value out there. But then you cannot make use of multiple values because this is how Tableau is built and this is how Tableau is, worked on. And one very important concept that you should know whenever you're answering this question is that the parameters in Tableau, right, they are not dynamic. So you literally cannot start filtering stuff at the runtime as well. So this is something which you should talk about along with the technique when you ask this particular question. So the answer is no. Currently Tableau does not support multi-valued parameters, but then of course down the line with a lot of updates, then it definitely is something that we all are waiting and in anticipation for as well. Now, moving on to the 21st question, it states, how do we use parameters in Tableau? So you can use parameters with the following entities, right? You can use parameters, map them with filters. You have parameters across calculated fields, across actions. You have measure swaps, you have changing views, and you have auto updates as well, right? So make sure to at least mention 3 or 4, but then it really adds value if you can mention 4, 5, or in fact all of these as well. So using parameters in Tableau is definitely a core concept and you're supposed to know it in and out at this point of time. So it always adds values to talk about where parameters are used and in fact how parameters are used as well. Now moving to the 22nd question, it states, what is the use of the new custom SQL query in Tableau? Well, one thing you have to know about is that the custom SQL query, right, it's a query that is written after you've connected to the data and you want to pull the data to have a structured view of it. Now, to give you an example, think about having 50 columns in a particular table, but then we do not require 50. We only want 10, 20 or 30 of it. So instead of taking all the 50 columns and then working with it individually, what we can try to do is we can write an SQL query that has the ability to filter out and just give us the 10 columns that we want and then work with it later and create a structured view based upon that. So why do we even have to do this? One, you want 10 out of 50, you're getting that straightforward. Number 2, when you think about computation power, the performance will go up to an exponential extent because this is a very simple example that we're talking about. In an actual production environment, this will not be the case. So the performance hit in case when you want 10 but you still have to pull in 50 is avoided. If you want 10 out of 50, you can have 10 out of 50, guys. That's a very simple example. Make sure to state it with the example as well. Now, moving on to the 23rd question, it states, what are the differences between Tableau and other traditional BI tools, right? One thing you already know about Tableau if you're here is that it is one of the most easiest tools to use. It's best in its class. It has a free offering and in fact it provides very good visual analytics capabilities as well. So whenever you think about data foundation concepts, here is where Tableau has it a little slow. It really doesn't help with plumbing, so you will have to make use of an SQL server alongside Tableau to have the complete package of using it. And of course, Tableau licenses can get relatively expensive if you're looking to scale up your organization and scale up your data quickly as well. But then traditional BI tools can do it all, but then it might have a significant cost upfront and then with a lot of parameters, right? So think about higher consultations, you have hardware changes, you have to have good software there as well. So all of these will cost money and this will come up to you as soon as you get started itself. So that is one of the biggest differences. And then when you think about all the big vendors out there, right? So if you have to check about reasonable value for money and if you have to check about what best you can get for the money that you've spent, someone like Microsoft is the person who can do it to the best of their capabilities, right? So they're a huge organization. And then when you think about open source vendors, there's Jaspersoft, there's Pentaho, and there's a lot of other tools that you can make use of as well. But then this does not have an enough talent pool as of yet. This does not have the enough amount of traction that is required for developers to kick in full time to build Pentaho and Jaspersoft into an amazing tool that can directly compete with Microsoft's offerings as well. So think about Tableau, think about Power BI, think about tools like Pentaho, Jaspersoft, and you will have a clear understanding of where the basic differences lie as well. Now, so moving on to the 24th question, it states, what are the similarities and differences that lie in between a tool like Tableau and a tool like Palantir? Well, one of the things you really have to understand is that Palantir and Tableau do things very, very differently, right? So Palantir is known for its ability to be a security tool in terms of handling problems such as fraud detection, handling the payments, and all of that, right? So the customers, or let's say the investors in Palantir, are people such as PayPal, the Central Intelligence Agency, and a lot of others. And on the other end, you already know that Tableau is a visualization player. It has its roots very strong into the Stanford University research as well, right? So one thing it'll always add value is that you talk about new points, right? So think about VQL or VisQL. So VisQL is basically the visual query language that will allow users to build any sort of visualizations that require on already existing data warehouses and spreadsheets, right? So Tableau's support for this is definitely a point that you can mention whenever you asked to talk about Tableau as well. So here is another point to your arsenal of Tableau knowledge. Moving on to the 25th question, it states how to create cascading filters without making use of a context filter. Well, it's very simple. All you have to do is think about a situation, right? So let's say we have two filters, filter 1 and filter 2. And based on filter 1, we have to make use of filter 2 on that particular data. And now when you have to say and now let's think of it as filter 1 being country and filter 2 being it as states, right? So if you choose the country as India, then filter 2 must display filter 2 must display only the states of India and not states of every single country out there, right? So this is how you can cascade filters without having to make use of a context filter. Now to do this, right? So for the filter 2, make sure you select the option wherever the value. So make sure you select the option of only relevant values for the filter for the second. So make sure you select the option for only relevant values for the second filter, to actually go on to do a thing like this. It's a pretty simple thing and it can be easily done by making use of Tableau. Moving on to the next question, it states, is Tableau good for a strategic acquisition? Well, of course, Tableau is an amazing tool for strategic acquisition as it provides amazing data insights, and you can do a lot more with Tableau with the approach of you having to put in a lot less effort as well, right? So in terms of acquisition, what it does, it will help you plan properly, set up a pipeline, understand what anomalies are lying there, and try to fix them as well. You can improvise your entire process and have it better as well. So it'll give you a lot of insights which might skip your eye if you're directly looking at the data with your naked eye as well. So in terms of strategic acquisition, it's a big yes for sure. Coming to the 27th question, it states how to display the top 5 and the last 5 sales in the same view. So to do this in a very simple way, there are two ways. Make sure to mention both as well. One, of course, you can apply filters where you can do it in a straight way. And number two, you have calculated fields where you can achieve the same effect of, let's say, top 5 sales and the last 5 sales in the same view without, you having to do much as well. So make sure to mention the both ways. Now, question number 28 states, let's say, suppose without having to use a line or a bar chart, I want to design a view to show the region-wise profit of sales. How can I go on to do this? So what we're trying to do here is, we want to show the region-wise profit and sales without having to use a line chart. So how would you suggest that we do it? If you do have a computer or a laptop in front of you right now, it will always add a lot of value if you can show all of these practically with any of the previous projects or data sets that you might have worked with. But then take a simple approach to verbally explain it first. See, for example, you can generate a map by making use of cities, and later, you can just drag the profit and all of the sales to that particular details, and then, add the state as a quick filter and work with it as well. So you can use a very simple approach, and to explain it can be done in a very simple and a concise way, but then it'll add value if you can show it practically, right? So pull out a data set, and tell the interviewer that you want to show how this can be done practically as well. So that will impress them definitely. Now, moving on to the 29th question, it states, design a view in a map such that if a user selects any state, the profit and the sales in the cities under that state would show up. So if someone selects any state, right, so whatever the profit is there in that particular state and whatever sales sales in the cities of that state that should show up. How can this be done? This can be done if you have state, city, sales and profit as our fields in our data, right? So we require these data. Make sure to mention that first. Without the data, you cannot mention it, right? And to have this particular effect, so all you have to do is click on the state field, drag the city out into our marks card, which comes under the state field, of course, and then drag the sales into size, drag the profit and drop into the color, click on the size legend. You can, increase it to whatever size that you require, say for example 75%, and then click on the state field and show quick filter. And after you have done that, all you have to do is you have to select any of the states and see if it is working or not. So if you've done steps from 1 to 6 right, then of course with the 7th step you will have the view which indicates the number of sales, and the color will directly indicate the profit values as well. So it's a simple thing with 6 simple steps. So this is the hardly 30-second task, but then at the end of the day, the insight you can drive out of this task is huge. So make sure you mention the advantage, how to do it, and what we require to do it as well. Now moving on to the 30th question, it states how to add custom color in Tableau. Custom color can be added in Tableau by making use of preferences.tps. So go to my documents, go to my table repository, and you will find a file called as preferences.tps. And here, you can add a color code. You can add the hash code, which is also called as the custom color code, wherein you can add wherein you can add it and make use of it directly as well. But then one thing you have to note is that, let's say in Tableau version 9.0 and above, right, you have a direct color picker option, which is basically giving you a user interface to do the exact same thing. So all you have to do is you can click on the color that you require, hit OK, and you're done with it in a very simple way as well. So coming on to the 31st question, it states how can we combine a database and the flat file data in Tableau desktop? How can we do this? It's again not a very difficult concept. All you have to do is you have to connect the data twice, because for the first time when you're connecting, it's for the database tables, and the second time you're connecting, it'll be for the flat file data. And then go to data, edit relationships, and give a join condition based on all of the columns that you have to find in common from our database file to the actual flat file data as well. So it's simple, connect it twice, once for database, once for flat file data. Go to data, edit relationships, put a join condition on the columns for the database tables to the flat file as well. And as soon as you're done with this, you have combined a database and a flat file in a very simple way in Tableau desktop. Now, moving to the 32nd question, it states, what does Tableau do? Well, here's another tricky question, right? So Tableau can do a lot of things. Use the insights from all the 31 questions that you have come across until now to answer it. But then one important thing you really have to state is that Tableau is one of these tools which has a goal to make sure that it will help people see and understand data better, in a very aesthetic way and in a very simple way as well. So Tableau brings about a data analytics solution, it brings about a business intelligence solution and a data visualization solution. It puts it right in the hands of common people, right? So what it does is you will have a broad population of business users who can actually work with their data, ask questions on their data, understand the performance of their data, and eventually solve a lot of problems using this as well. So this question you can talk about 20-25 minutes and still you can have a lot of points that you can talk about Tableau as well. But then make sure to mention all the primary concepts. So make sure to mention all the primary points and how it adds value to the people, right? So what we're trying to do with Tableau is solve a problem. So make sure you talk about what the problem is and how Tableau aims to solve it. Moving to the 33rd question, it states, what is Tableau Public? Tableau Public is a free tool. It's a free service that lets anyone anywhere in the world publish an interactive data set onto the website, right? So once you're connected to the internet, you can do a lot of things. Once you have installed Tableau Public, I still say the same thing. You can do a lot of things. Now, whenever you think about making use of Tableau Public, make sure to explicitly mention that you really do not require any programming skills out here, right? So there's a lot of people, a lot of learners who keep asking us in case if they require a program programming head start to start with Tableau? The answer is no, you really do not require anything, right? So with Tableau Desktop, anywhere anyone on the web can interact with the data, see the data, work with it, download it, create their own visualization, edit the visualization, and in fact, you can also check out what everyone else are doing as well. So you can do that to get ideas. You can do that to see how aesthetically pleasing things can get if something is done in a neat way when you're making use of Tableau as well. So it adds a lot of value, and make sure to mention all of that. Now, with question number 34, we're talking about data modeling. So what is data modeling? One thing you have to know about data modeling is that it is the basic analysis that we perform of all of the data objects that we're using, in our context right now. So whenever we're trying to model data, we're trying to find relationships. We're trying to associate each of these data objects, comparing them one with the other to see how we can base any assumption on them, or how we can apply, certain steps on them to see how we can drive insight, right? So it's a pretty simple thing. To analyze the data objects, you really require context, you really require certain relationships to work with, and data modeling is a way where we go on to show all of these relationships as well. It is as simple as that. Moving to question number 35, it states, what is your daily process with Tableau? What is your daily work process with Tableau? This is another tricky question, and this is completely based on your way to work with Tableau. There is no one right answer for this, and start your answer with this, right? It completely depends on what projects you're working with Tableau, the complexity of the project, the client requirement, the performance requirements, the complexity of the actual time involved in doing the project, and a lot of other things. But then, of course, you can have a very simple data work process that I've mentioned on the screen. That's an example. So what usually happens whenever you're working with Tableau is that first you will get an understanding of what the requirements are, and after you understood what the requirements are, you're going to start pulling in all the required data. You're going to create a storyboard based upon that, and eventually apply and create visualizations in Tableau. And the last step, of course, you're going to present it to a client for review, right? So use this as a foundation, and you can talk about your previous experiences on this as well. So use all of these as foundational points, add more value to them based on the experience level that you have, and convey it to the interviewer in a clean and a concise way. Then, coming to the next question, it states, how does Tableau work with big data sets or huge data sets? To start off the answer to this question, make sure to state this. Tableau's performance varies a lot depending on the performance of source data as well. So depending on how clean the data is, how structured it is, or a lot of other parameters that is present in the data set as well. So your performance is having a direct correlation with the performance of the data source itself. So what happens is that the main impact on performance comes whenever we talk about the time that takes to execute a query, right? So if your data source is taking an ample amount of time to execute a query, then what does Tableau have to do? Well, Tableau has to sit and wait until your data source can give you this data, right? So that means you are waiting, Tableau is waiting, and your data source is taking some time. So this really doesn't add a lot of value. So you can state all of these to say how Tableau can deal with huge data sets as well. You can do it very well, of course, but then it takes certain time to go on to do it. Now, coming to the next question, it states, how will you publish and schedule a workbook in Tableau server? It's a very simple task. All you have to do is create a schedule for a particular time, whatever time that is you require, and or let's say even the client has provided you a time. All you have to do is create an extract for the data source, pull all the data, and eventually publish it on the workbook in the server as well. So creating extract is the actual important step that you have to concentrate on, as whenever we talk about publishing a workbook, especially while scheduling it, right? So there's a lot of authentication methodologies that you have to check as well. So before you can publish it, there is actually an explicit option that states scheduling and authentication. You can click on that, you can select the schedule from whenever you have to publish it, and then directly hit publish. So all the data sources and all of the assignments that have to be published will run through the schedule and be done automatically without you having to put a lot of time, or let's say punching back in whenever you have the scheduled time and then looking at something there as well. So you really don't have to do any of that. This entire process is automated. It will get refreshed on a regular basis, and you can work with it automatically without having to put much effort as it is. Now, coming on to the 38th question, it states, distinguish between parameters and filters. Well, parameters, you already have to know this. It is the dynamic values that will replace all of the constant values whenever we talk about any calculations, right? And parameters, if used right, can be used as filters itself. But what are filters? Filters are used to restrict the data based upon conditions that we have. And where have we mentioned all of these conditions? We have mentioned it in the filters shelf, right? So it's a very simple thing. Talk about what filters are, talk about what parameters are, and make sure to state that you can also use parameters as filters if required as well. So that point is a highlight, and it'll add a lot of value if you can state that directly too. And now coming on to the 39th question, it states how to view an SQL generated query in Tableau Desktop or by Tableau Desktop. So all of the queries that get generated actually go into a log file, right? So there's the Tableau or desktop log file. So there's the Tableau desktop log file that you can get into as soon as you go into C Drive, Users, My Documents, My Tableau repository.
Just a quick info, guys. Test your knowledge of Tableau by answering this question. Which of the following is not a trend line model? A. Linear trend line. B. Exponential trend line. C. Binomial trend line. D. Logarithmic trend line. Comment your answer in the comment section below. Subscribe to Intellipaat to know the right answer. Now, let's continue with the session.
Where all of your data is mentioned, all of the detailed information about the query. So make sure to mention all of these as well. Once you have to have a live connection with the data source, you have to check all of the files. If you're making use of an extract, there's another file, and the actual file which will contain all of the queries as well. Now moving on to the 40th question, it states what is page shelf? Page shelf is a very simple concept, but do not be fooled by how simple it is, because it's a very powerful part of Tableau. It's a foundational concept in Tableau where you can actually control the display of the output and any result that gets printed on the output as well. So page shelf acts as a primary barrier, acts as a primary visualization criteria where you can work with a lot of things to make sure that you can control a lot of parameters when displaying or when controlling the output as well. So in that regard, page shelf adds a lot of value. Now, coming to the 41st question, we have another different question. So moving on to the 41st question, we have a question that states, what are the major differences in between Tableau 7 and Tableau 8? Now guys, you really have to know this question. This is another trick question that can be asked to you to see how proficient you are with Tableau and all of the years of experience that you say you bring with, right? This is a way to verify that as well. So, with respect to Tableau 8, you have a lot of new things that got implemented. Think about tree maps, think about bubble charts, think about whisker plots, box plots, and all of that, right? So new features are amazing. One very important thing you have to talk about is the introduction of the R script and how you can directly copy the worksheet from one workbook into another one without having to redo it or without having to put in a lot of effort there as well. So not only this question, whenever you asked about any question pertaining to older version of Tableaus, in case if you have used it, I'm sure you'll be able to answer those questions. But then in case if you haven't used it, make sure to explicitly mention saying that you haven't had a lot of experience using that as well. I mean, of course, it's going to be 90% same with one version to the other, but then it always adds value if you know it exactly as well. So make sure to mention that. Moving on to question number 42, it states how to create filled maps. So to create a filled map, right, let's take an example. Whenever we talk about map view, right, so all you have to do is click on the geographical field, click on anything such as zip code, click on area code, state, or any of these, and select the filled map mark type, right? And select the filled map mark type. So with this, what you can do is the automatic mark type that will show all of the types of views as circles over the map, right? So once it starts showing it as circles over the map, then you can have the marks card, and from the marks card you can select all the filled map to eventually color your geographical areas as per requirement as well. And to color all of that, it's a very simple thing, and I'm sure you already know this. And step number 3 is very simple. Drag a field to the color shelf, define what locations need need to be colored, how these locations need to be colored, and just drag a field to the color shelf and you can be done with that. And of course, you can explain this probably in under a minute to the interviewer, but then if you have your laptop, I would really suggest you take your laptops to the interviewers in case if that's allowed, and then make sure to show this practically to the interviewer as well, because all of these concepts, you can explain them easily and in a very straightforward way verbally, but then what will add value is if you can actually show them practically as well. Now, moving on to the 43rd question, it states, does a parameter have its own drop down list? In Tableau, yes, a parameter has its own drop down list, and whatever entries that you make in the parameter while actually creating, right? So it can be directly viewed as items in the drop down list. So the answer is simple, the answer is straightforward. It's a yes, it's possible to have a drop down list for a parameter. Moving on to the 44th question, it states, how is data blending different from data joining? Again, this is a question which is asked a lot of times in this interview, just like all of these other questions that you've been going across right now. So make sure to concentrate. Now, when we talk about data blending, right? So data blending, as the name suggests, in fact, is the process where we combine the data from two different sources or more than two different sources as well. So, your two different sources can be a Microsoft Excel file. You can have another set of data on an SQL server, Oracle server, a cloud computing platform, or a server which is on premises, a remote server which is in the client's location, and a lot of other things to bring these data together to use in Tableau, right? That's what data blending is. And data joining, on the other hand, is a very simple concept. It's a straightforward concept, just like data blending, but it's very different. What we're trying to do here is we're trying to combine the data from two or more tables and sheets from the same data source. Data blending spoke about two different data sources and bringing it together. Data joining is all about talking about two different sheets or tables that are present in the same data source, guys. That is the basic difference. In joining, we talk about same data source and everything that is present in that data source, and in blending, we talk about more than one source. So make sure to explicitly mention that without fail. And now, question number 45, it says, is it possible to store a huge amount of data in the memory engine by making use of Tableau? Is it possible to store a huge amount of data? If yes, how can we do it? So if an interviewer asks you a question like this, right, the second part of the question might give you a clue to the first part in case if you're unprepared as well. So he or she can state, if yes, how is it possible, right? So the actual answer to this question, now coming to that, is yes, it is possible to store a large amount of data in the memory engine by making use of Tableau. But then it is not as simple as that, because there is no one straight answer to this, because you can store massive amounts of data based upon the Tableau server implementation. You can have a lot of configurations for that, right? You can have 8 core configurations, you can have 16 core configurations, and you can have more than that as well. So depending on how your Tableau server is configured and built, based on that you can store it. So it's a relative answer to the relative question. And not only if just hyper is used or not, let's say there are many other factors that will affect, such as the server memory can also have an exponential effect in how much data that you can eventually store and directly use in a rapid fashion for the memory engine, and a lot of things as well. So make sure to talk about the server memory and make sure to talk about the server configuration in general as well. Now, moving on to the 46th question, it states, what is the difference between rank and index in Tableau? So whenever we talk about rank and index, one commonality is that both of these come under table calculations in Tableau, guys. So index is the actual entity that will deal with the record's physical location, and think about incremented numbers, for example. So as soon as incremental numbers are assigned according to the record's physical order, right? So as soon as this order is particularly met, and how is it met? By making use of index. Now, whenever you think about rank, right, so rank usually deals with the record's value. Whatever highest value is there gets the highest rank, whatever lowest value is there gets the lowest rank. So it's a pretty simple and a straightforward business in terms of rank and index as well. Index deals with its position, record deals with its values, right? So if you have used any other programming language as well, you will understand the usage of index. And rank, as the name suggests, is a numerical value that denotes how it maps in the real world as well. Now with that, coming to the 47th question, here is another very simple question, but then if you do not know how to answer this, it can get a little difficult as well. So to answer this question that states, suppose my license expires today, can my users be able to view the dashboards or workbooks that I published in the server earlier? Well, you really have to know the answer to this question, guys. If your license expires today, right? If your server license expires today, the username of the server will change. It'll go from the name that you have put in and it'll say unlicensed user. It means that whoever created the dashboard and published it into the server cannot access it anymore. But then everyone else can still do it. So the site admin, what he can do is he can change the ownership to another person, and so at this time, what the site admin can do is the site admin can change ownership to another person. This way, we are trying to make sure that if we have and if you're making use of extracts, right, it doesn't fail. But if you do not change ownerships, you really cannot extract the data anymore if it's unlicensed. So yes, if the license expired today, you cannot have access to it, but then everyone else can. Moving on to the 48th question, it states, what is the difference between the quick filter and the normal filter in Tableau? Well, quick filter is an entity that's used to filter options and to select options in a very rapid manner. And a normal filter is something with which you can limit the options from the list. You can calculate some conditions, work with the data, limit it based upon a value, limit it based upon an index, or limit it based upon a general field in a column as well. So quick filter is used to view the filtering options, while normal filter is actually used to view a lot more compared to that as well. And hence the name quick filter and normal filter in Tableau. So make sure to mention this basic difference in a clear way to the interviewer. Moving on to the 49th question, it states, what is your plan after joining for the Tableau developer role, or let's say any other Tableau role that you might be joining for as well? So to answer this question, make sure that you keep it concise, you keep it clear, and do not talk about it for 20 minutes. So you can start answering on how you have actually worked with Tableau in your previous years. It may be your learning, it may be your use in a production environment and whatnot. And think about talking about a plan where you first understand the company structure that you're interviewing for, and how well you can have an impact in terms of Tableau will only come if you can understand how well the data is implemented there, right? How the data workflow is set up, how the infrastructure is set up, and all of that. So talk about you first having the ability to easily grasp and understand new things, and then talk about how you can better it or improvise something in the coming days with further iterations as well. It's not only just that, right? So it's all about you fitting into a role, being a team player, the ability to talk to multiple teams, and the ability to solve the problem at hand. And if you can do it very efficiently as a Tableau developer, then you open up your resume not only to just one or two interviewers, but then even to the top companies across the globe as well. So this is a very tricky question. This totally depends on your potential, your capability, but guys, it is extremely vital, as I've highlighted in the answer, that you have to keep it concise and you have to talk about how you will fit in there, right? So you really cannot barge in and say, I'm going to start changing everything up. Yes, you might have to start changing everything up only after you have understood it and you've seen a problem and you have a thorough way of solving that with your solution, which is supposedly better as well. So make sure to mention all of that. Now, coming to the last question, it states, have you earned any sort of certification to improve your learning and implementation process? Well, guys, if you've made it to this question, congratulations. These 50 questions will add a lot of value to your Tableau interview, and I'm sure you can use this as a guide to ace all of your interviews as well. But then this question is very important. If you have ever used a certification program to learn and gain knowledge, you will understand that it will portray a lot of things, right? So you can gain a lot of knowledge in a clear way, in a concise way, from professionals across the globe, and you can make use of real world projects to concrete your learning, and you can do a lot more for a learner. But now let's talk about what it does whenever you're in an interview, right? So if you have certifications, let's say you are a certified Tableau developer, as soon as you step into this Tableau interview and you state that you have a certification and you talk about it, one thing it will show to the interviewer is that you want your career to be built around here, right? So because you would have spent a considerable amount of time, you would have spent a considerable amount of effort to go on to do something in this field as well. So in that aspect, you definitely will show a lot of aspiration there too. And another thing where you're showing strong aspiration is, let's say if you've jumped from another different background, you might be coming from a management background, you might be a Python developer who wants to become a Tableau developer now, and everything else too. So it'll show that you have the ability to grasp novel things, new things, and understand how they work. And you being serious about it also shows how your certification has added value to your life as well. And of course, since you'll be learning a new thing, in case if it was new to you, not taught in college or any of that, it will show that you are an effective learner and you have the capabilities to be taught. So being teachable is everything in today's world, and I'm sure most of you already know that as well. So one important thing you have to talk about is, of course, talk about the certifications, talk about what you learned through that certifications. But then here's a secret, guys. Here's a secret tip. Talk about how you used it rather than talking a lot about what it is, because there's a good chance they already know. So there's a good chance that the interviewer might know all the certifications that already exist with Tableau, but then he or she will absolutely have no clue what you have implemented, right? So talk about your projects, talk about your ideas, talk about the new things that you have tried, talk about your practical implementations that you have done after your learning. This is where you try to understand, and this is where you actually impress the interviewer as well, guys. So I hope these 50 questions add a lot of value to your interviewers, and I take this opportunity to wish you all the best for all the upcoming interviews as well. As always, I'll see you in the next one.
Just a quick info, guys. Intellipaat provides Tableau online training and certification course mentored by industry experts. The course link of which is given in the description below. So guys, we have come to the end of the session. If you have any doubts, please put down your comments in the comment section below. We will try to answer it as soon as possible. Thanks for watching.